Hi, everyone. We'll be getting started in just about 1 minute or so. And Pulkit, if you'd like to go ahead and, yep, there we go. We'll go ahead and get the recording started and get the live stream up as well. And you're still on mute, just FYI.
Oh, sorry. So if you guys can let me know if my screen is up or not.
Yep, looks great.
Great.
We'll get started here in just a few more seconds.
Okay.
All right, greetings everyone, and welcome to day 6 of the FOSSASIA 2021 Summit. We've passed the halfway mark of our event already, if you can believe that, but we still have a very busy and exciting day ahead today. We're going to be focusing on security, privacy, digital sovereignty, Internet of Things, cloud, blockchain, and open source AI voice assistants. Very exciting keynote lined up today from Frank Karlachek at Nextcloud, coming up at 1400 Singapore time. But first, for many so-called selling points of free and open source software is the chance at increased privacy and control over your data. Now, if you've been following the news in recent months, you may have heard some interesting talk about third-party cookies and how browsers are working to start blocking trackers. Well, obviously this is very interesting news, and here to tell us more in a very short talk about a very big topic is one moment. We fix that, sorry about that. On a very short talk about a very big topic is Pulkit, who is a software engineer from Wingify and a FOSSASIA Code Heat finalist, and also a very big fan of JavaScript and music. So as a final reminder, if you've got any questions for any of our speakers, including Pulkit, please add them to the shared notes tab on the left side of your screen. And for now, please join me in welcoming Pulkit. Take it away, Pulkit.
Yeah, hi. So good morning, guys. So my name is Pulkit and I work at Wingify as a software engineer. So a little brief about what I do at Wingify. So I primarily work on the JavaScript libraries that power the A/B testing functionality of our product, of our A/B testing product, which is called as VW or Visual Website Optimizer. So in this particular session, I'll be talking about the increasing concern over privacy. And primarily, I would be talking about the Chrome same-site cookie policy that Chrome decided to roll out last year in 2020. So let's dive in. Yeah, but before diving straight away into what is Chrome same-site policy and what exactly it means, let's also discuss what actually led to Chrome coming out with this policy. Yeah. See, so user privacy has become a big concern these days because as people become more and more aware about users being tracked and they've been tracked across multiple domains. So people have really become aware about this topic, user privacy, and you might have seen people moving browsers like DuckDuckGo, which assure their users that they are not being tracked and their privacy is being respected and all that. And also, the mainstream browsers like Safari or Firefox, they have been at the forefront. They have worked out one or more ways to assure their users that they are not being tracked and their privacy is being respected and all that. So let's also discuss a few ways, in which users are tracked across domains. Yeah, so one very, very prominent way of tracking users is third-party cookies. So as a website owner, when would I actually need a third-party cookie? So let's suppose I have two domains, domain A and domain B. And so when you land on domain B, I want to show you the contents of domain B on the basis of your activity on domain A, so that you get a similar kind of experience. And you want to visit the website again so that you get a similar kind of experience. So what happens is, so now when you visit website A, as the website owner, what I can do is somehow I can form some third-party cookies based on your behavior on my website A. Now I form some third-party cookies, okay? And now when you go to website B, what happens is I somehow sync all those third-party cookies, and I show you the content based on your behavior on my website A. So this is how third-party cookies work, and this is a very hypothetical use case where you would need a third-party cookie. Yeah, so this is how third-party cookies work. And the second and also a very prominent way of tracking is tracking pixels. So for this example, when would I actually need a tracking pixel? So let's suppose I have a website which has a list of shoes, and you're going through the website, you're scrolling, and then you finally like some product, okay, and you click on that product, you go to the product page, and you see all the details, you add it to the cart, but you don't end up buying it. So as a website owner, what I can do it on the product page, I can also tracking pixel is nothing but a one into one pixel. One into one dimension image tag, and image tag with the source of any social media website. So let's suppose I've dropped a tracking pixel on the product page with the source of any social media website. So a get call would go to the server, right? So I can send a lot of information. Okay, so I might send that how many pixels did you scroll, what product page are you on, and what product actually you added to cart. So I can send all of that information, and then when you go to that social media website, what you actually see is the advertisement of the same product. And I'm pretty sure it has happened to most of us. Yeah. So, and also, tracking pixels leave a very negative impression in the minds of the user, because it's like you're viewing something and then you go to altogether a completely different website, and then you see the advertisement of the same product. So tracking pixels or maybe third-party cookies, they are like the proven methods of increasing conversion of a website. So people use it to increase conversion or maybe targeted marketing. And yeah, coming to targeted marketing, there's also a very important method or prominent method, is your user agent. So your user agent can actually give a lot of information about you. For example, what browser you're using, whether you're on Chrome, Safari, whether you're on Android or iOS. So as a website owner, if I know that you open my website a lot on an iPad, so what I can do is I can actually target you with Apple products. I can sell you my Apple products. I can increase my conversions. So these are like the proven methods of increasing conversions. Okay, and targeted marketing as well. So these are just a few methods of tracking people across websites, or maybe tracking users in general, but there are other methods. But for this session, I'll just give a brief about all these methods. Let's go ahead. Yeah, so as I already mentioned, that browsers like Safari or Firefox, they have been at the forefront when it comes to addressing the issue of privacy. They've been working on one or more ways to assure their users. So actually, yeah, Safari actually decided to introduce a 7-day expiration policy with ITP 2.1. So ITP, yeah. So ITP is Intelligent Tracking Prevention System. Safari's Intelligent Tracking Prevention System. But for this session, I won't be talking about the Intelligent Tracking Prevention System. I'll just give a brief about what it does and some of the key points. So Safari actually decided to introduce a 7-day expiration policy with ITP 2.1. Yeah. So what it means is, so let's suppose you visit a website a.com. So all the cookies found by a.com, all the a very important point that I just forgot to mention is this policy applies only to the cookies created through JavaScript, which means that the cookies that you create through document.cookie, this policy applies to them, this policy. Yeah. So if you visit a website a.com, and that a.com would create some cookies, it would set some cookies, and then it would access some cookies to perform its functionalities. So let's suppose it forms a cookie to detect whether you're logged in or not, and that cookie expiry is 30 days. So this rule says that cookie, because it's a first party cookie and it's created through JavaScript, it would automatically expire after 7 days. So you would automatically be logged out after 7 days. So all the first party cookies created through document.cookie would automatically expire after 7 days. And it does not matter whether the expiry is 90 days, 80 days. It completely doesn't matter now, because it is like hard capped to 7 days. So it would automatically expire after 7 days. And yeah, this is a very important point, the storage access API. So this rule specifically applies to the third-party embeds. So let's suppose there's a website and there is a social media plugin embed in that particular website, some kind of iframe. So what it says is, yeah, so also, Safari has something called as a machine learning classifier. So that machine learning classifier, so when you visit a website, that machine learning classifier is able to detect any known trackers. So I'll give you an example. So let's suppose you visit a website and then that website has some social media embed, and now the machine learning classifier detects that, okay, this is the known tracker, and this particular thing has cross-site tracking capabilities. So now what Chrome would do, now if the social media embed, if it wants to own cookies in third-party context, then it would have to use the storage SX API provided by Safari. Now, what this API says is, so if a known tracker or a third-party embed wants to form cookie in third-party context, then it would have to use the storage access API explicitly. And this API explicitly asks for will ask for your permission. It would actually ask for your consent that this particular social media embed or this particular domain would actually want to create cookies. So would you allow that or not? So a pop-up would show up on your screen. So if you allow that, it would allow creating cookies in third-party context for the social media embed. Otherwise, it won't. And also, it had, I think, Safari with the previous versions of ITB. It also had something called as partitioning of cookies. So Store Access API is like one step ahead of partitioning of cookies. So it's like protecting you from all the known trackers and social media embeds on the website. And this specifically, applies to the social media embeds, the Storage Access API. Yeah. So on the other hand, Firefox has something called as an enhanced tracking system. So unlike Safari, Firefox follows a list called as disconnect list. So this disconnect list has a list of all the known trackers. And so Safari, Firefox would follow this list. So if you visit a website and that website is using some library for analytics, it's using some analytics library, and that analytics library now falls in the disconnect list. Let's assume it falls in the disconnect list. So what Firefox would do is it would not allow that particular library, that analytics library, to create any cookies in third-party context, or maybe it would block the calls directly. So it works that way. And yeah, so I've left a link if you want to, learn more about the intelligent tracking prevention system. You can read more about it. I've left a link here. So it's actually pretty interesting how it went the entire journey of ITP. Yeah, so coming back to the focus of this talk. So as I also mentioned earlier, that I would be primarily talking about Chrome same-site cookie policy, which Chrome decided to roll out last year in 2020 after Chrome version 80. So this policy is like enforced after Chrome version 80. Although it's not a 100% rollout, I'm not sure what the percentage is, but yeah, it's not a 100% rollout as of now. And so coming back to the same site policy. So what the Chrome same site rule says is that if you want to access your cookies in third-party context, then your cookies have to be set with same site attribute none and secure. So if you want to access them in third-party context, you have to set them with same site attribute none and secure. And yeah, it says one more thing, that if you don't assign any value to this attribute same site, your cookies would automatically, would be set with an attribute known as lex. So when I explain all these attributes, I guess it would be clearer. Okay. Yeah. So I also sometimes feel that it is a very misunderstood topic, third-party cookies and all that stuff. So just to put you guys in context, there's nothing called as a third-party cookies or cookies. So there is only third-party context. Browser would only understand third-party context. So consider this example. So just assume that this is a web page, and on this web page, you've opened a website a.com. So this is a web page and with domain a.com. And this web page has an iframe. So this is an iframe with domain b.com. So a.com would set some cookies and would try to access some cookies for this to function normally. And similarly, b.com would try to set some cookies and access some cookies, to perform its functionalities. Now, this is the parent frame and this is the child frame. So what key a.com forms or accesses are set to be in first party context because the domain of the parent frame is a.com. But whatever cookies b.com tries to set or access, so they are in third party context simply because this is an iframe, this is the child frame rather, and the domain of the child frame, which is b.com, does not match the domain of the parent frame, which is a.com. So for the browser, this iframe or all the cookies set or accessed by this iframe b.com would be in third party context. So this is one example of third party context. Yeah, so here's another example of third party context. So again, this is the same example. This is the same web page with domain a.com. Again, and similarly, this a.com would try to access some cookies. It would try to set some cookies. It would be in first party context, since as I already explained that this is the parent frame and the domain of the parent frame is a.com. So when you try to access or form some cookie with a.com, they are in first party context. But now this web page sends a get request to b.com. When a get request is sent, all the cookies and it sends a get request to a domain known as b.com. So when a get request to b.com is sent, all the cookies of b.com would be sent along with that request. Now, see, it is again the same case. So this is the parent frame whose domain is a.com. And now this web page is sending a call to b.com, but the domain is different here. So this is b.com and this is a.com. So whatever cookies that are sent along with b.com, or would be set in the response of this b.com get request, they're set to be in third party context, and simply just the same reason again, because the domain of the parent frame does not match the domain of this request. So this is in third party context as well. So this is another example of what third party context means. So we covered two examples. One is the example with the iframe, and the other one is the example with the get call. Yeah. So now coming back to what is same site attribute exactly. So I guess we are familiar with this interface, aren't we? So this is Chrome's console with the application tab open. This is the name of the cookie, the value, the domain of the cookie, the path. We are familiar with these attributes, right? But the thing we are not really familiar with sometimes is this same site attribute and the secure attribute. And this is what Chrome is talking about exactly. So the same site thing you see, it has three possible values. Yeah, so it has three possible values: lex, strict, and none. So let's go through them one by one. Yeah, so for this particular example, so I'll be explaining what same site lex means. So for this particular example, let's just assume that all the cookies that are formed. Oh, wait, so this is a button. Okay, so again, this is a web page with domain a.com, and it has a button click here, which is nothing but an anchor tag with https://c.com. Okay, so now what same site policy, and yeah, so for this example, let's just assume that all the cookies found by a.com are using the same site attribute lex. So all the cookies found by a.com are using the same site attribute lex. They are same site lex, and also all the cookies found by c.com are also set with same site attribute lex. Let's just assume for this example. So since now, what does lex say? The same site rule lex says that cookies in third party context are only and only accessible uh, during top level navigation. So a.com would try to access its own cookies, right? And it would try to form some cookies that would be first party cookies, because this is the parent frame. Similarly, when you click on this button, this would navigate you to c.com. And since it's a get call, so the cookies of c.com would be sent along in the request. But since they are now formed using same site attribute lex, will they be accessible in third party context? Because this is an example of third party context. Yes, they would be accessible, because lex says that if you want to access cookies in third party context, it has to be top level navigation, and this is top level navigation. So when you click here, a get request is sent to c.com, you're navigated to c.com. All the cookies of c.com which are set with same site lex would be sent along with that request. Now consider another scenario. What if it
I'm
wasn't
sorry to interrupt. I think we're at our time, but what I would ask you, I'm curious if you'd be interested in continuing some more of these very interesting examples in our discussion room. We've got a Jitsi room available. This is obviously very interesting, and I think some people would like to probably continue the lesson here with you.
Can I just move to the same site slide, the last slide?
Sure, please go ahead.
Yeah, so what does the new same site rule say? So the same site rule says that the third party cookies have to be set with same site none and secure. Third party cookies must have both these labels to avoid being rejected. Okay, so Chrome simply says that your cookies have to be same site none and secure if you want to access them in third party context. But in case if you forget to assign a value to this same site attribute, they would automatically be set with same site attribute lex, which means that your third party cookies in third party context would only and only be accessible during top level navigation. In any other case, it won't be accessible. So I guess since we're out of time, so I'll just end it. And these are my social media link, guys. So would love to connect with you guys after this.
Thank you very much,
Thank you.
Pulkit. This is very insightful. I really appreciated the crash course, as I like to call it, and a very interesting topic. And I would really definitely encourage anyone who's interested in talking with Pulkit more about this, either visit over in the discussion room, which you can get to from the left side of your window. We've got a Jitsi room, and you can actually walk through things live in real time, or meet over in the chat. Anytime you can feel free to mention them, and I'm sure he'd be happy to talk with you more about that. So again, let's all give a virtual applause to Pulkit, and thank you for your time today.
Sure, sir. Would love to actually discuss more about this in the discussion room. All
right, we'll be beginning we will be beginning our next talk in just about a minute or so, and let our next speaker go ahead and get set up. And Hans, I think your video is looking good. Want to check your audio quickly as well? Looks like you're on mute.
Mute. Did that work right? You hear me?
Great. And yeah, I can hear you. And
Awesome.
there's a little bit of an echo, but that will stop as soon as I stop speaking.
Okay.
I'm going to mute you again just for a moment or two while I introduce you. So don't forget to unmute yourself. And I'll go ahead and give you presenter rights, so you feel free to upload your slides at this point. And we will get started in just about 20 seconds. So if anyone wants a quick step away for a quick drink or something, we'll be right back. And Hans, you should have access now to upload your slides at this point too. Okay, well, let's continue on, and welcome back to FOSSASIA Summit 2021. For those of you just joining us, we're continuing with our theme of security and privacy. And our next speaker is here for an in-depth look at personal online security and how we can better manage our privacy with several different approaches that we're going to dive into today. Now, password managers have been in the news the last few weeks with some new money-making schemes from proprietary vendors. And in fact, just this week, another tech giant is offering a so-called free as in charge password manager. And here to teach us about all of these things is Der Hans, who's a customer data engineer at ObjectRocket. Now, when he's not working at his day job, Hans stays very busy with open source as the chairman of the Phoenix Linux user group in the United States. He helps to organize and present at several different open source conferences around the world and has a very informative stream of insights on Mastodon I'd encourage you to subscribe to. So as a reminder, if you've got any questions during this talk for our speaker, you can add them over in the shared notes tab at the left of your screen, and Hans will do his best to answer them toward the end of our time together, time permitting. So with that, please join me now and welcome our next speaker, Der Hans. Over to you.
All right. Thank you very much. So first of all, I want to say thanks to the FOSSASIA crew for a great conference. I've really been enjoying it. Got to enjoy a couple of the Python classes, several of the presentations. In fact, I hope everyone got to enjoy Pulkit's presentation just now and his explanations for third-party cookies and context and cookies. That's relevant in my presentation when we get to the excellent Lightroom browser add-on. But before we get into all that, two really important things. The first off, happy St. Patrick's Day. I know it's not St. Patrick's Day there anymore and it's out of region, but for me, hey, it's a great day. So anyway, we'll start with that. I've got some, oops, I gotta put the mouse in the right place. I got some particulars for contacting me. So that URL at the top is also in the footer down below. The slides are already up there. They're also up on the FOSSASIA page for this talk, so you can go get the information there. I'll be talking at Liberate Planet this weekend for regular expressions. And let's see, plays to get a hold of me. Those are listed elsewhere as well. So first of all, another really important thing other than St. Patrick's Day is I am not a lawyer. And importantly, we're going to figure out how these work. Specifically, I am not your lawyer. So if you need legal review for any ideas from this talk, please talk to your lawyer. Don't just believe the funny long hair. Go talk to a lawyer and find out whether it works, especially when we have these multi-region and multi-country types of events. Local laws win, right? So, all right. So why do we need security? Why do we need to be concerned about taking security into our own hands when we're dealing with other websites? Well, Spectre meltdown again, right? That's going in everywhere. But look at also all these places that have been broken into in the last few years, some of them multiple times. LinkedIn, it took them a few times to learn that they should hash things and do a decent job of it. Who knows if they've been broken into since then again. We also have some kind of famous people. The first person is not quite so famous, Matt Honan. I'm going to talk a little bit about him though, because we've got some specifics for the break-in with him. So Matt Honan was a writer for Wired magazine, and at some point a couple of people, and apparently it was 2 people, decided to break into his Twitter account because he had a short handle, and they thought it would be fun to hijack that and spew some propaganda or whatever it is that they were doing. Now, in order to do that, they needed to break into his email account with a vendor. I'll leave it, you can read it in the article. And they were able to do that. And it occurred to him after the fact that once they had access to his email address or his account, they could have broken into everything of his. They could have gotten into his banking and financial services. They could have gotten into his other social media that he might have had. They could have used his email to go and socially engineer his friends and family. So he had a lot of liability, or exposure when they got in, but that wasn't the worst of it. The worst was something that the 2 guys supposedly hadn't planned, but one of them just decided to do because he could and it would be fun. They decided to use Matt's Apple account, which is the way they were getting to the mail, to delete all of his data. And as it turned out at the time, that also meant all the data off of his phone, his wife's phone, his laptop. So they could not only delete all of his data off the cloud, they could delete all of his data off of his personal devices, because I guess that's a feature. I don't know. So that would have included all of the pictures of his daughters. As a father, that would just be devastating if I lost all of the pictures of my kid, right? So there were a lot of things that he would have lost. Yes, the financial exposure and all that would have been horrible, but to lose those keepsakes, to lose those pictures, you don't lose the memories, but those pictures are also important. It's really awesome that we have all these cameras nowadays and we can take 10 million pictures of our kids, but we want to keep them all, or at least the ones we decided to keep, right? So those vendors that were broken into, and there were several in the case of Matt Honan, became exposure to him not only for what data he had in the cloud, but his own personal data as well. So that's part of the reason why we need to care about security and privacy on our side. Now, another thing, I was listening to, going to Ohio Linux Fest a year and a quarter ago before the pandemic struck, and listening to a Freakonomics podcast, and they mentioned that 90% of the data ever collected by humans had been collected in the last 2 years. Now, we've increased the data collection since then. So maybe at this point, all the data ever collected, or 90% of everything collected, or 95% was in the last 18 months. We are collecting so much data. And when I say we, I mean they, right? I'm not collecting 1 million points of data on me a day, but others might be doing that. And our privacy depends on how secure they keep that, and making sure that somebody can't leap from one place to another place. So that if they break into, I'm going to pick on LinkedIn again just because they were so horrible a couple times. If they break into LinkedIn, they can't then turn and use that same data to break into another cloud vendor that might impact me and also have lots of data on us. None of us have anything that's sitting there spying and storing data on us anywhere, right? So we need to be more concerned. So first thing, is for privacy and security, do the basics. Use only trusted software. Don't just download software from anywhere on the planet. Make sure you're certain of where you're getting it. The nice thing about us in the free software world is we have distributions, and we can be fairly certain in our distributions. They're not perfect, but they do a pretty good job. So if we stick with this software from our distributions, we can have fairly good confidence that that's safe. Definitely safer than some random website. And then also make sure you're installing your security updates. And that can be difficult. If you're interested in that, we can talk out of band. It's not really time here, but I've got a string that does that for Debian to just get the security updates. Red Hat actually makes it fairly easy, and I'm certain some of the other distributions do as well. It would be cool to collect all that in one place. So make sure you're getting those as you go. Then let me give an example. I'm going to talk a lot about encryption. I'm going to talk about random strings. I'm going to explain some of that. But it's good to have an example for encryption. So a basic example is like take a postcard. In this case, it's a post sticker. It's a sticker. And you can see the backside of it here. There's nothing there. But if I flip it around, you can read the sticker now. It happens to be for the Software Freedom Conservancy. Oops, I might have had something on there. Sorry. And then this one is for Nextcloud. So you can see the sticker and see what's on there, just like a postcard. As this goes through the mail, they can take pictures of it. Not only can they, but they do. That's part of the way they go through and do the deliveries, is they take pictures and do machine reading on data. So if I don't want them to see that I'm a fan of Nextcloud, because if the post office knew that, that would be dangerous for me, whatever, right? If I don't want them to see that, or anybody else that might be handling my mail, then I can go through and put that in an envelope. Now you can't see what it is. Now, this isn't a perfect example because there are ways of steaming this open and so forth, but that's kind of what encryption is doing. It's taking that clear text data and it's putting it inside of a container so that it's not generally readable. In fact, with our encryption today, for the most part, we can encrypt things that are not going to be hackable, crackable within our lifetimes, until somebody figures out a shortcut. That's the problem, is that those tend to come around. But that's kind of what encryption is. You're sticking it inside something so that people can't read it. They can still take a picture of the data as it goes by, but now they're getting the outer encrypted part. They're not getting the plain text version of it. And when we talk about tunnels, in my other presentations, I'll talk a lot about SSH and tunnels. What we're really talking about is a whole lot of different packets that are all encrypted going to the same place. And they kind of go together like rail cars. All right. So when should we use encryption? All the time, every time, right? So I keep hearing stuff about, oh, you were using an open Wi-Fi. I don't care. I'm using encryption on my data going across that. You know what? When I use my ISP here at home, I'm also using open Wi-Fi. My ISP has access to that. So if I'm not encrypting my data, my ISP and anybody my ISP is sending that data to can look at it. So I want to make sure that's encrypted when it leaves my network, when it leaves my device, and it stays encrypted to the device that I'm talking about. So you want to be encrypted all the time, every time. One thing that helps with that from a browser perspective, and that's a lot of what I'm going to talk about, you can use HTTPS Everywhere browser add-on from EFF. Great add-on, and it helps you stay with secure connections only, and will give you warnings if you start using, depending on how you configure it, will give you warnings if you start using unencrypted connections. Now, what to encrypt? Well, our login credentials, right? Your password, stuff like that. But also anything that you deem as personal information. Your name, your address, your medical information, your private photos, your shoe size. If that's really secret to you and you don't want people to know, make sure it's encrypted, right? So anything you don't want other people to be able to sniff. But be careful when you're setting up your accounts with different sites. If you use the same password, the same credentials, the same password at multiple sites, then when one gets broken into and they figured out what your password it was there, they can then use that to break into another site. So if you're using the same password for Mastodon as you do for your bank account, then if somebody breaks into Mastodon and is able to sniff your password, they can then use that to go take all your money out of your bank account, if you have any, right? If you don't, maybe they'll be nice and put some in for you. But the thing is, by using the same credentials, one compromise can expose your data to multiple sites. It's really easy to do a 4i link or loop to go through and hit a whole bunch of different sites. So it doesn't take them very long to test your credentials if they get them. Use different passwords for every single site. Now, I mentioned password and username. So together, those are credentials. So credentials are the combination of tokens that are used for authentication. Generally, it's a username and password for websites. That username might be email address nowadays. We're going to talk about some other options that come in there. But anything that we do are those credentials. Those are the things of proving that you are you, so you can authenticate. So as I said, username. Today, it's often an email address, and I'm going to talk about how to use unique email addresses for every site as well. Password, we've already been talking about that. Make sure that's unique at every site. You could also have security questions. So if you've forgotten your password, or if they need extra security, you can have security questions and answers. You might have a PIN. for different things, for credit cards or ATM cards or for your phone and so forth. Multi-factor authentication, we should be getting more and more of that because it's getting kind of useful. Body parts, right? Go use your fingerprints, your eye prints, go look at your facial recognition. Things are coming up. That last one is getting used to identify you with or without your permission, depending on where you are. We'll get into some examples with those. All right. So as I said, you want to have unique credentials for every site, but not just your password. Every part should be unique if you can. So make sure your username is unique. Don't use the same MFA token for every site, right? You set up different tokens for different sites. You have to kind of for that anyway, but make sure you do. Don't use the same security questions and answers for every site. Especially don't use ones that are guessable. Some restrictions may apply to this, right? You only have 10 fingers, or most of us only have 10 fingers, right? Limits to how many fingers you can use to do stuff. Most of us have one face. So you get some limits, especially with the what are you components of authentication. So for passwords and for the tokens I'm going to talk about, we want to use random strings as much as we can. The random string, for those of us that do some programming, we're kind of familiar with those. But for other people, it's a random sequence of text gibberish, right? To some extent, it's what happens when your cat walks across your keyboard or your baby gets a hold of it or something like that. You want something nonsensical if you can. The longer and the more random, the better, right? You can use letters, uppercase and lowercase, numbers, punctuations. Punctuation can sometimes be difficult, but nowadays we can use punctuation pretty freely. I do suggest being cautious of similar looking characters. We'll get to that in a little bit, but specifically the underline and dash, depending on the font you're using, they can look the same. And then also spaces and tabs. Horizontal space is not human readable. You don't know if it's a space, you don't know if it's tab. For the most part, it's not human readable, and that becomes a problem. The password system might actually handle it just fine, but it's difficult for you to see what it is, depending on what interface you're using. And then here's an example of a random string. But today we also have random word salads. And these are random sequence of related words. And that's one of the keys. That you hear a lot of things about use a line from your favorite song. Well, guess what?
Looks like we may have lost Hans. Maybe some technical difficulties. We apologize. And hopefully he'll be reconnecting in just a moment. In the meanwhile, I will add, while we're waiting on Hans, I will add a link to the XKCD example, which he has at the bottom of his slide, which is a comic, webcomic about password strength and why it's useful to or why it can be advantageous to use even a string of simple words can be just as good or better than a very confusing looking password. So check out that webcomic when you have a second. It looks like Hans is on his way back. I'm going to give him presenter rights, and he should be able to get his camera hopefully and microphone in just a moment. There's even, I didn't put a link, there's also a link to the XKCD password generator, if you want more examples of that.
Am I back?
Sounds like you're back.
All right. You know, I have to admit, this is a new experience. I've never been thrown out of my own presentation before.
Congratulations, first time for everything.
Yeah.
And your camera is off. I don't know if your camera is able to be restarted.
There we go. I was just waiting for it to come back up. Yeah, I got logged out. Speaking of authentication, I had to go log back in. All right, let me get back to where I was. Okay, still random word salad. Hopefully everybody pulled out their salad spinner while I was doing that and started spinning some word salad. Random sequence of unrelated words. Don't use song lyrics. Don't use something that other people know. You know, there are more than 3 people that like that Taylor Swift song or whatever it is you're listening to, right? I can't, you know, Psy is somebody I like actually. So things like that, right? Don't use something other people know. I am a fan of several unknown bands. they're still in Google, right? So don't use something like, make sure they're unrelated words, as unrelated as possible. Again, the longer and more random are both better. So longer being more words, right? So if you, the XKCD example that Michael brought up and that's in my slides, recommends 4 words. I recommend 6 or 8 words if you can. You know, on phones, it gets to, you know, for those of us that didn't grow up with them, it gets to be a bit much to type. But on a computer, it's really, if you're using a password manager, it doesn't matter. I don't know. I have never seen most of my passwords because I use copy and paste. I have never seen them. I just generate them and use them, right? So if it's 40 words, as long as the server is where I'm working with can handle it, that works, right? I don't usually do that many, but you know, you can. If you can, use multiple languages, right? So the words part is kind of open to dictionary tags. Well, if you make it to where they've got to import 50 dictionaries, you're starting to make it a lot more difficult for them. Also use declension, conjugation, instead of the infinitive of a verb and stuff like that. If you've got a language that does that, again, it's not showing up in the dictionary unto itself that way. So you're making it difficult. Add mid-word capital letters. Use randomized punctuation. Here's a couple of examples. We'll get to XKCD in a moment. All right. Checking time while here. Now, I'm saying all this, and you might say, but Hans, that's just too much to memorize, and not near as interesting as baseball stats. I mean, who would want to spend time memorizing something other than baseball stats? And that's where the password manager comes into play that I've mentioned. It allows you to securely store credential information, and it's easy to use for authentication. And that's on multiple devices. I use it on a computer, I use it on the phone, I use it on all kinds of different places, so that is simple to use. And as I say, by doing that, I've never even seen most of my passwords. And I have a different password for every site. I have a different account and different email address for almost all of my sites. We'll get into some that are kind of difficult to do that with. All right, to me, password servers, managers should have certain requirements. First of all, we're talking about security and privacy. It needs to be free software. If it's not free software, you can't really trust that it's secure. You can't really trust that it's been checked for privacy and that it's not stealing data. Now, just because it's free software doesn't mean it is secure, because there can be holes that are found, but we have a much better you can have a much better reason to believe that it is free, that it is secure. And other people looked at it. In fact, if it really matters to you, you can go look at the code, or you can hire somebody to go look at the code and see if it does seem to be really secure. Or a whole bunch of you can get together and hire somebody. Should do hidden password entries, so * * * instead of Hunter2, for those of you that get that joke. Locally encrypted operating system independent file. So if I'm encrypting it on the cloud, then whoever's running that cloud can read it. Right? If it's plain text up there and they're encrypting it, then they can go through and look at it. But if I encrypt it on my local computer or my local phone or my local whatever it is that I'm using, then it stays encrypted from me to wherever it is. If it's on the cloud, at least it's encrypted, transporting back and forth, and whoever's running the cloud can't read the plain text. But then you need operating in this system independent. I prefer a local file, but even if it's web-based, you want to make sure it's operating system independent, so you can use it on both Ubuntu and Red Hat, or BSD, or those other things that are out there, right? Data liberation, I think, is getting more and more important, especially for those of us that have thousands and thousands of passwords in here now. And that's the ability to export the data out of the tool into something else. This is really important for a cloud-based tool. We'll get to a couple in a second. That you can then suck your data back out if there starts to be some problem with that cloud. They change the terms of service, they go open core, etc. Right? And actually, Michael brought up a few of those instances before my talk started. Then you want automatic clipboard entry clearing. This was what kept me from using password managers for years. Was I did not know that there's a way to clear the clipboard automatically after a certain time, so 30 seconds or 60 seconds. And your password managers will do that, so your password doesn't end up staying in your clipboard for days and weeks to accidentally be pasted into IRC or into a commit log message or something like that, or a web search, right? A bad place to put your password. Configurable password manager, so that you can say, I want words, I want letters, I want random string or random word salad. So I can say, make it 20 characters long, make it 80 characters long, include punctuation, don't include punctuation, all those things. If you can make that configurable, you can do that. If your password manager doesn't do that, APG is a nice command line tool that will allow you to do that. Space for notes, so you can do things like, for instance, say that, hey, this site wants letters, but it doesn't handle capital letters for some reason, right? So you can put local notes for you to remind you when you get there next time, right? And then a way to organize it. It's an address book. You want a way to organize it so you can find things. If you can search through the entries, it's even that's also handy. And then there's some bonus features that I recommend. You want human readable password generation. We'll get to that in a few slides. Again, random word salad generation, so you can do multiple words. A pronunciation guide. We'll also get to that, so you can know how to pronounce certain random strings. And then be able to generate those random tokens, those random strings from anywhere in the UI. So there are places I use random strings that are not passwords. So it's nice to be able to get them somewhere else and then use them. And we'll get to that in, I think, a slide or two. Secondary key value storage. So this is where you could put like your security questions and answers. What question was it and what's the answer? Being able to copy paste from those key values. And then data export with sync. This is the piece I'm missing from KeePassX. We'll talk about KeePassX and KeePassXC. But say, okay, I want these 15 to be in this particular file that I keep on my phone. And then when I update them, I want to be able to automatically just change the ones that I updated. Right now I'm doing it all manually, which is kind of sucky. So it'd be nice if I could basically build an export filter and tell it to do syncs, and possibly be able to sync them back in as well if I changed it elsewhere. But that's, I don't know how to do that yet, other than some command line scripts I've done to do that. Now here I'm gonna have some praise for a proprietary tool that I usually have not so nice things to say about. But first of all, it's proprietary, so it doesn't meet that very first requirement that it be free software. They've also recently had some issues with some licensing and some data break-ins and some letting people taking some data, user data and stuff. But one of the things that a couple of good features that LastPass has, and I don't know of anybody else that does, is they can do some site safety verifications. When Heartbleed was announced, LastPass added a feature so that when you used a password out of LastPass, it would go check and see if that site had been fixed for Heartbleed or not. And if it hadn't, it would let you know and not let you go directly to it. You could still log in if you wanted to, but it would prevent the automated things. And I believe it also has an automated password changes thing where you can say, change all my passwords, and it will go out to all the different sites and change the passwords. The problem for me with that is now LastPass knows what your passwords are, but you don't. So I want it to be the other way around. But it is a really, really cool feature. So if you think that you've been compromised, you can go grab those really quick. All right. So my recommendations for the Unix world, GNU Linux, BSD, I recommend KeePassXC or KeePassX. Or their terminal versions, there's command line versions. So KeePassX was created a number of years ago, I think 10 plus years ago, as a clone of KeePass. We'll get to that in a second. And it's been an awesome tool, but it was basically one person, a half dozen people working on it, and it was getting slow progress and maintenance. Adding new features. So they added, for instance, a mechanism for SSH key organization and so forth. Also some piece. I've been keys or at least really hurt if you can install cloud, of course.
Folks, I'm sorry. I think at least some of us are having trouble hearing Hans with maybe some connection difficulties. Hans, can you double check your microphone settings? It doesn't look like you're on mute, but it looks like you may be not being heard. You may want to try to just reload the your browser, reload the page, and come back into the room, and we'll try one more time to get you.
All right, there we go again. All right.
Oh, I think you're back.
Yes, I'm going to keep driving. So, all right. Android, there's a bunch of different things in F-Droid. KeyPass, that's the one you use for other apps with Mac. That's the original. Thanks to the person who created that and created the file formats that we use. It's useful. I've never used it. It's available on Linux if you want mono. I don't. I love KeyPass XC and KeyPass X. All right. So you end up with one password to hold them all, right? Yeah, I have this one file that has all my passwords. I don't, because I use multiple files, but let's pretend right here we are. So when you go create a new database, you create a password. You want to be careful with that and make sure you keep it secret and keep it safe. Because if somebody gets that password and access to your file, they have everything, right? They have your entire life if they can break into that. So make sure you keep that safe. This is where I get to the XKCD example. I'm not going to leave time to read it, but the basics of this is you're using a passphrase, and that makes it easier to remember, right? Find something that's easy to remember, something that's fairly easy to type, even if it's kind of long, because you're going to need to keep that in your head in order to use the password manager, right? You need to know what your login is for your desktop. You need to know what the login is for your password manager, and maybe a couple other things, but minimally you need those two things, or your login for your phone and your password manager, depending on what kind of technology world you live in, right? So that's where the passphrases can come in really handy, because they're easier to keep in your head and learn, and yet still be secure. Now, for random strings, I suggest sometimes you need to use pronounceable strings, and those are like Dr. Seuss, but they make less sense, right? So they're useful for phone stuff. You keep in mind that sometimes you need to be able to talk. You say them, and somebody else might need to say them. Be nice. Give them something that might be pronounceable. So down here is an example with a pronunciation guide. This is coming from APG, Automatic Password Generator, that I mentioned earlier, which is a command line tool. And it gives us a pronunciation guide, Werk Biev of Edge Mu, right? So it might not look really pronounceable, but I can do it. And I've used it 3 times this week now, so it made it a little bit easier. But you can practice it a couple times if you really, really need to do it. And then identification is identifying that you are you. So how do we do that? There's 3 types of authentication data. What you know, your password, right? What you have, which might be your smartphone, your app, your physical ID when you go into the work. Oh, we don't do that anymore. But if you still did that, right? What you are, your fingerprint, your DNA, facial, all those things. Those are the 3 basic types of authentication for you to identify who you are. But there's a 4th element, and that's tokens. So cookies, your device ID in the US, our cell phones have a unique ID, and some carriers send that to every website you go to with your phone, so they can track who you are with that phone. If you change phones, it can change, but at least for that particular phone, that is the digital version of facial recognition that is exact for you when they do that. So there are ways for them to identify you, even if you're not doing that. So there's sorry, I don't know who put that in there. There's also a 5th element apparently. All right. So ID, username, random strings work well for bank shopping. So they don't, when you log in, okay, the bank needs to know who you are. That's kind of how banks work for the most part. But your user ID that you use to identify yourself to log in doesn't need to be something they recognize, right? So my username does not need to have Hans in it. It doesn't need to have Fluffy Kitty 02, whatever my preferred thing is. It can be a random string. And that's what I use for my utilities, for my banks, for any things like that. The biggest issue with them is that my usernames start looking like passwords, except for they're too short. But I'm using a password manager. So again, I don't actually see them other than when I paste it, usernames are plain text when it pastes into the website. So, it's easy for me to keep them straight because they're different fields, right? But some things you need to use public handles. So when I do my talks, if every time I propose to talk for a different conference, I add a different random string, like who's this guy or gal or whatever, right? They don't know. So I use the same ID everywhere. The email address they get is still unique. We'll get to that. But I tend to use the same name so they recognize me. So Lufthansa or Flux Advocate being for that. So email address. So this is the things. It is possible to have a unique email address using one email address for every site. Kind of. Or mostly, I should say, not kind of. It is definitely possible. So in many different vendors, and of course, if you run your own email address, you can do this. You can put a plus after the username part of your email address, and then some random string. Punctuation gets to be difficult, but basically, if you stick to letters and numbers, you'll be fine. Remember, it's not case sensitive. It's an email address. It's not or it shouldn't be case sensitive. Some places it is, shouldn't be. But then you can put a random string in your email address. It'll still get delivered to your account just like a normal email would, but now you've got this random string you can use to filter and do other identifications on. My recommendation is you have a token, and then so the plus token, which is a random string, a dash, and then something that's human readable for me. So eBay, I put eBay in here because eBay gets a lot of spam attempts and stuff like that, and this is a way for me to go through and filter it. So if it's coming to my eBay address, I know it's coming from eBay. Whereas if it says it's coming from eBay about something I bid on to one of my mailing lists, I know that's not me because I don't use my mailing list address to do eBay stuff. They're completely different identities, right? Much less the password. As I say, they're more difficult for social networks or places where humans are looking for you. You might need to use something that they can recognize. An example for using sub-addressing where I break that out. One thing is don't reuse that tokenized email address for anything else. Keep it. In order to be unique, it needs to be unique. Cookies. So there are third-party cookies. I guess I should learn from the previous talk, third-party context, where they can track you on multiple sites. If you've never played with Lightbeam plugin from Firefox, look at the Lightbeam plugin. It's actually not from Firefox anymore. They discontinued it, but one of their interns actually took it and started up again. That's hence the 3.0. Go look at that and some site that does a lot of tracking, and you will be amazed at how many connections you have from that site to other sites. Also, if you do, I also recommend Umatrix. Umatrix has an issue in that it's been end of life. The developer isn't working on it anymore. He's doing other great stuff like uBlock Origin and stuff. So I'm thanking him for what he did, but I haven't found something that replaces Umatrix for the way I do things. But if you use Umatrix, go to a site with it dialed down, not allowing anything, look at Lightbeam, then go disable Umatrix, reload, and look at Lightbeam again, and it'll be poof, huge, all kinds of stuff. So you can really see what the difference is. And for those of us that might have bad connections, I don't for this, but like on my phone or something like that, there's lots of places where I have bad connections where I live. This also reduces the traffic because it never asks for all those cookies or all those pixels or anything else, all the different trackers. I mentioned mobile devices, depending on your carrier and where you live, might have a device ID specific to you. For security examples, one, make sure you put the text markup in the right place so they don't drive over each other. Sorry, but anyway, you have the basic things. What is your grandma's name? My favorite down here is what is your grandma's pets, hairdresser's shoe size, right? They have these standard questions. What high school did you go to? Lie. Oops, I skipped ahead. The most important thing is to lie. All right. They don't need to know what high school you went to. They don't need to know what your mascot was. They don't need to know your grandma's pet's hairdresser shoe size. So when they ask, give them random data as much gibberish as possible. Remember, you might need to pronounce those, and people might need to recognize them, so that's where that pronunciation guide works. Now, the APG I know works for English and some other European languages. I actually don't know how it would do for non-European languages, so that you might need to find your own tools, or if they don't exist, band together and make them, or make patches to APG so they do. But they don't need to know that. And if you use your actual grandmother's maiden name, or your favorite pet, somebody might be able to figure that out and social engineer into your information. All right. So again, when I say lie there, I'm not your lawyer. If any of my suggestions today go against your local laws or requirements, please consider your legal liabilities, all right? I don't think I'm saying anything that's bad, but I don't know the laws everywhere in the world. All right. Security and questions and answers. As I say, not only random answers, but if you can, put random questions. And okay, I just hit time. Crap. All right. And let me, if I can, we had a couple skips. Multi-factor. This is what I recommend. Time-based multi-factor. Slip through this. One of the keys with this is that site does not need your phone number. It's time sync. They don't ever need a connection. And in my case, it's really important that they don't even need a network connection. And I can fly through those. You're missing some really horrible jokes. Here's a one-liner to create random birth dates if you're inclined to do so. I need to. Pins. Okay, so that's one last point if I can. Clouds are forever. So make regular backups, offsite backups. If my password file disappears, I can't get into lots of places. I don't even know what my email address is for them. So I need to make sure I have good backups. But if you put it up on the cloud, remember that can be there even after you tell them to delete. So if your file format gets compromised or somebody gets your password, it might not get deleted up on the cloud. So keep in mind that you might still have a liability and need to go through extra steps to make sure that old version of your file really, really goes away. All right. We'll call it good.
Well, Hans, this has been incredibly enlightening. Thank you so much. I want to look at the questions that we've got, and I'm going to put you on just mute for just a second for the echo. First of all, we have a break happening right now until the top of the hour at 1 p.m. Singapore time. So if people want to get up and take a break, feel free. I do want to ask just a couple more questions since we have a little bit of time. We'll kind of just take a little bit of our break for a follow-up or two. Jacob had asked a question about whether or not open source password managers like KeePass can really keep our passwords safe. Now, you talked about some of the ways that it does, but I'd like to push that just a little bit further. And are there certain types of risks in using tools like KeePass? Are there vulnerabilities that we need to be concerned about? Can people really use those with confidence? Any comment there? And again, I apologize because I put you on mute.
Yeah, I think they're secure. That's what I use. One of the big things with it is it does put the onus of the security of the file on you, right? Because you're the one controlling the file. It puts the onus of making sure you have backups that are safe and available, that you have it the places you need it. So in light of that, I think it's secure. The KeePass file format is used by a bunch of different applications. So you have lots of eyes on it in that there are lots of different developers working with it. And since it's a shared file format, if there's a problem, like if it turns out that KeePass XC is not secure, I can move back to KeePass X, or I can move to put it all on my phone and use Android or whatever, right? So I can use different tools if I'm suddenly uncertain about a particular application for some reason. It doesn't lock me out. And if I'm really, really paranoid, I can put my password manager and my file inside of a container and don't give it network access. So even if there is a compromise, it ain't going nowhere.
So it sounds like in theory, the file itself is encrypted. It's generally fairly safe if we were to store it on the cloud somewhere, as long as that's encrypted, because we're encrypting and decrypting on our local machine. So that takes a lot of the risk out. Very good. Mishari, I don't know if you're still with us. If you'd like to, you had an interesting comment about email forwarders. Do you want to, if you're with us, do you want to unmute and share that?
Hi. Yes. So I decided to take this just a little bit further. I have registered a domain, which sounds like a legitimate enterprise. And what I do is that I basically have service at domain.com that is that forwards to my primary email address. And it's a catch-all. So any email address there will go to my primary email address. This way I can keep track, because I find that the plus it will work if you have good intentions. But however, if you're a malicious actor, you can easily just filter that one out. But this way I remain anonymous, because what I do is I never use my real name with this domain. I generate a name using namefake.com and fake fake personas, and so I just remain semi-anonymous. People can't trace it back to me.
Cool. Thank you,
Yeah,
Mishari.
that's awesome.
That's very interesting. Yeah.
Yeah. So you can take this further. There, different mail providers will allow you to have multiple email addresses. So you can do, you can set up like 5 different main email addresses and then do your sub addresses. If you own your own domain, I own my own domain, so I actually have a whole bunch of top level email addresses that I use for different things. So like if you ever see me on a mailing list, you might see for Tyler at the beginning of it, that tells me I'm using a distribution list. So I keep those separate. So maybe I should do a more advanced version. I try to leave this thing for something people normally could use, so everybody can get an email address somewhere. But yeah, I should find a way to do a more advanced one and talk to people like you are doing other things. And okay, for those of us who know what we're doing, what are some of the cool things we're doing? That'd be cool. That'd be good.
Yeah, it definitely sounds like this is the kind of thing you can start with some very basics that can do a lot of good, and you can kind of keep hacking infinitely, probably, to keep improving your situation. And so that's a great resource. And another great resource are these slides from your talk, Hans. Just reminding everyone that you can actually download these from the session page, and all of the links that you've got there are embedded there into the slides. So a great place to start, as well as your contact information, so people can reach out to you, connect with you for further resources. I know you're kind of continually thinking about these topics.
Been doing this a while. And if I can add one thing I forgot, Mishari brought up the plus. So there are some sites that don't allow a plus in email address. And if you know the people who are working on the web there, remind them that they should allow that. That's perfectly legal. But if you own your own domain, then you can set up something else like a dot, a period as your separator for your sub-addressing, and nobody's gonna ban those because there's too many first dot last email addresses out there, right? So I wish I had realized that back when I first started. I would have used a dash myself, because that also works fairly well. I've been thinking about moving to another domain just for email, and then using a dot for my sub-addressing, but also, again, using multiple accounts like you're talking about.
Very good. Well, we are up against our time until our break, so we'll need to reset the room. But Hans, thank you so much. This has been really interesting and useful. It's a great start to our day about security and other topics. Coming up at the top of the hour, we've actually got a really cool panel presentation on Internet of Things and edge devices and all the security challenges related to that. So we've got a very exciting panel coming up, and they'll be speaking for an hour. And then after that, we've got Frank Karliczek from Nextcloud, talking about how you can use tools like Nextcloud to protect your privacy. So the theme continues throughout the day. Everyone feel free to hang out for a little while. You've got about 10 minutes until the next panel. So stretch your legs, hydrate, get some water, get some coffee, and we'll see you back here in about 10 minutes at the top of the hour. Again, put some virtual applause together for Hans. Thank you very much, and we'll see you again online soon. Take care.
Good afternoon, everyone, or good morning, or good evening, depending where you are. My name is Roland Turner. I'm a long-term member of the FOSSASIA Summit organising team, and I'll be emceeing for the next 4 or 5 hours. We'll start the next session in about 5 minutes. In the meantime, one of the presenters, perhaps Frederick, could turn on your microphone and camera.
Yes. Hello.
Hello, Frederick. Okay, so I understand you intend to present a pre-recorded session first?
Yeah, absolutely. It was a bit easier like that.
That's okay. We have no problem with it. It's been uploaded to YouTube or Vimeo?
We provided the URL a while back to the team, but I can resend it to you if you need it.
I'm happy to do it if you want to just paste it into the chat. I'll
Yeah, sure. Let me
play it from there.
find this for you.
Aha! I have been advised that the link is in the schedule spreadsheet, which is something that's internal to moderators, so I already have it. So I shall start it in due course. Meaning, don't worry about it. Just sort of stand by and be around for Q&A afterwards.
All right. Looking forward to it.
Frederick?
Yes.
Hi, this is Nicola.
Welcome everyone to this panel on edge device security. I'm your host, Frédéric Desbiens from the Edge Foundation.
No.
I'm program manager here for our goal today is to have a wide-ranging conversation about all the challenges and the potential solutions to edge device security. With me, I've got 4 fantastic guests in driving this conversation forward. So let's introduce them. First is, Dion.
Please stop. We haven't.
Hello. Hey, my name is Dan. I'm an engineer. I work as an engineer for Red Hat. I've been in the IoT space for the last I think 5 years or so.
Guys.
And I've grown into the edge computing in the last couple of years.
Excellent.
Oh, how embarrassing. I was playing the video and assumed that people were talking live. The video definitely works.
Yeah, well, those things happen.
It sounds very realistic.
It really sounds like me.
It's just like you're just here.
Can you hear me, Frederick? Hey, guys.
Hey, Nicola.
Hey,
Nicola, I can see that you're Crimson Gazelle. I understand you're having trouble with your Event account. Don't worry about it. We all know who you are. We will invite you to turn your camera on after the recorded session.
All right. So, but people are like writing in the chat. Does it mean anything? So,
I'm sorry. What's the question?
No, people are writing in the chat. Are they looking at the webinar or listen to what we are saying right now? Yeah, there are.
I don't understand your question. People.
Yeah, okay, that doesn't matter.
That's
It doesn't matter. So we are talking about there are people actually connected, and I don't know what they are listening to. So probably
listen to us.
Yeah, they listen to us.
This is the main conference hall. So at this point, I will ask you please to mute your mics because we're at the hour. I will start the session. So as this session actually has its own intros built into the recording, I will not do the introductions myself. I will simply start the video. It runs approximately 45 minutes, so we'll then have about 10 minutes for Q&A at the end of the session. Oh, you may need to press play in your browser to cause it to start playing.
Welcome everyone to this panel on edge guests in driving this conversation forward. So let's introduce them. First is Dion.
Hello. Hey, my name is Dan. I'm an engineer. I work as an engineer for Red Hat. I've been in the IoT space for the last I think 5 years or so, and being drawn into the edge computing in the last couple of years. Excellent. Next is Angelo.
Okay, thank you, Frederick. So Angelo Corsaro, CTO at AD-Link. Within Eclipse, I lead quite a few, let's say, projects in the context of Eclipse Edge Native and Eclipse IoT in between those. And I've been involved with Edge and fog computing since the very beginning. In fact, I was involved in some of the super early projects in this context. So it's a pleasure to be with you today.
Thank you, Angelo. Nicola?
Thank you, Frederick. I'm Nicola LaGloria from Kinetics. My company is members of the Eclipse Foundation, and I'm a member of the Edge working group. Our company is actually in the OS operating system, embedded device operating system space, and we are also contributors to a couple of projects inside the Eclipse Foundation.
Thank you. And last but not least is Ted.
Yeah, hi, my name is Ted Ross. I'm an engineer out of the Boston area. I'm actually freelancing now, working on some open source technologies around the Scupper project, Apache Qubit Dispatch Router project. And my interest is not so much IoT, but more cloud networking and edge computing and the networking involved in the edge computing.
Thank you very much. All right. So first segment, let's start talking in a general setting about the challenges of edge security. So Dion, what are the edge device security challenges, and in what way are they different from those of traditional IT?
Well, one of the big differences that we have when we talk about edge computing and differences between the cloud computing is that our hardware is much more geographically dispersed now, right? Being the clusters that are deployed outside of the data centers or just a single nodes of compute, we have devices that are not physically protected. So that stems a lot of questions about security, ranging from all the layers of security there. So starting with, can you trust that hardware is proper, right? Trusting the hardware layer, trusting the OS and firmware levels of those devices. And thinking about if someone tampered with the software on the hardware, and so going from the hardware to the firmware and operating systems all the way to the microservices and applications running on that hardware. So you can see on the applications level are we running the container images that are supposed to be run there? How are we sharing the secrets to those unprotected locations, and do we have mechanisms for those microservices to be restricted in their own so to say sandboxes and not interfere with each other?
And that makes sense. And at the same time, I mean, okay, there are many of the challenges that we just discussed that are specific to the device, but all of those devices ultimately will speak to the cloud at some point, right? Those are not self-contained systems. So what role could we say that the cloud plays in edge device security?
Yeah. So in my point of view, so one thing that I didn't mention at first is that there are also devices connecting to the edge infrastructure, right? That we are not even not considered part of the edge, and what we need to provide is like a single continuously experience for all that, and that's where the cloud play a massive role. So we need to have if you want to trust devices that are connected, we need to have a proper device management and device provisioning of those devices. If you want to handle properly operating system and firmware, we need to have a proper rollout of the firmware to a large number of external nodes. And of course, we need to have a trusted way to distribute our applications, microservices, container images, and secrets to those locations. So that's all the job of the cloud, to provide that infrastructure to basically manage all that in a scalable way.
And obviously at the Eclipse Foundation, we love open source. We work in open source all the time. So are there specific open source projects that address the challenges that you just told us about? Are there things that people can download straight away and start building a secure edge infrastructure with it?
Yeah. So there is, but my experience for the last X years doing IoT and edge, so there's hard to find a single solution to all the problems, right? So you have all these bits and pieces dispersed to different projects trying to solve different things. So, for example, Eclipse Holo contains a concept of device registry, right, and managing of credentials and for secure connectivity of devices to the cloud or to the edge infrastructure. Eclipse Hogbit is another project that deals with software rollouts, updates of firmware, and basically any kind of software. But we also have things outside of the Eclipse community as well. For example, the Harbor project is something that tries to provide a way to be able to have like a distributed container registry, which can have a really great place into the edge computing with Docker-based and container-based technologies.
Okay, that makes sense. And obviously our edge computing projects in the Edge Native Working Group have a deep concern about obviously security. So maybe Angelo, since you're involved in one of those, what's your perspective on this?
Well, so I think one of the aspects that we have to integrate when we talk about security in edge application is that in the end, yes, the cloud will have a role, but if you really want to scale, we need to make sure that in a way we have a change of paradigm, and I think in two respects. So if we focus for a moment on data, if you think about how we have secured data so far, usually what you do, you build security around it, right? So you make sure that you can't access data that you don't have the rights to access. That's easy on a cloud environment, easy between quotes. But if you think about taking that approach and moving it to the edge, in which all of a sudden you have data that is decentralized, well, it's much easier to tamper with devices. So that's not going to work. So all of a sudden, I think, and at least that's the direction we are taking also in some of our open source project at Eclipse, is that we have to change the paradigm and all of a sudden actually agree that devices are out there, people might get hold of the device, tamper the device and access the data. So the key point is that with that data, they shouldn't be able to do anything. Okay, so we are trying to change completely the paradigm for what concerns security, at least at the data level, and making sure that instead of assuming and making it hard for you to access, it's making it hard for you to do anything unless you have the right identity credential and so on and so forth. So that poses quite a few challenges, but again, I mean, up to when there will be interesting challenges, there will be interesting problems to solve, which is good. That poses challenges not just from the security perspective, but also from the encryption, which all of a sudden requires some support from hardware, and poses also challenges with respect to secret, being able to maintain secret in a secure manner, which, as we know, is supported by TPM and processor architecture like ARM and trust zones provide also some additional way to deal with it, especially if you look in combination with some interesting unikernel that are also coming out in the open source.
So absolutely. Yeah. And at the same time, this operating system aspect is important. And Nicola, you mentioned you are working on embedded OSs for edge devices. So taking on from Angelo there, what's your perspective on the edge security challenges?
Looking at from an embedded operating system standpoint, that is where my focus is. Basically, we have two really great technologies that kicked in the past 15, 20 years. One of course is virtualization, and another one is like related to containers. Both of them, from a security standpoint, they provide what today is one of the most important aspects, in my opinion, in an embedded device like an edge node. In the edge architecture, that is the isolation, the context of isolation, how we do isolate some different aspects that are running on an edge node. Virtual machines and containers are really different. Virtual machine is an abstraction of a complete computing platform, hardware and software. So I/O, processor, memory. A container is purely software, and it uses the same kernel of the host. Actually, a container is a child process of the daemon that launched it. So there are completely different technologies, but at the same time, they guarantee what the what isolation needs to be on a device level. The interesting thing about isolation is critical processes. So let's say that we have an edge device, edge node, and we have a camera that is attached to the edge node. This is a simple case, but again, we can see that these kind of use case into different ways. For instance, from a container perspective, we need we have of course the core OS that, and then we have a containerized OS, and the containerized OS, let's say, that is running a software for grabbing the camera frames and then do something with it and then transfer those information somewhere else. The thing is, we need how we do enable the container to access some devices, let's say the camera device, and then process and then do the job. Well, we can do that in a pretty fairly secure way without privileged mode, without having any container running in privileged mode, just because we know exactly which device we need to export from the core OS to the container. On the same time, if this is not really guaranteed, let's say that we have other devices that are managed by UDEV, and so we don't have a predicted way to tell which device is generated by the core OS and needs to be connected to the container, we may have some problem over there. And there are like several recipes to solve that problem, but they may violate the isolation principle. And also having privileged containers is not really a good practice. So it's about good practices. Virtual machine, on the other side, they provide like an extremely solid way to isolate critical application. Let's say that we have a edge device that is has some particular like important characteristics. Let's say that part of the system are in real time. Part of the system don't have any time constraints like regular operating system, or part of the system needs to be bare metal. How can we solve this problem? Containers are great in Edge because they provide a great deployment model. If you have microservices and some software that is purely software that needs to be deployed uniquely, atomically inside a device, and without like worrying about dependencies. But at the same time, how we do the same, how can we enable the same easy way of managing deployments when we have a lot of hardware that is critical hardware attached to the edge node? So in this case, probably virtualization. And when I say virtualization, because even Docker is virtualization, it's called lightweight virtualization, but there is something that is more like what I call is more appropriate for these use case, that is the regular virtualization or asymmetric multiprocessing, which guarantee the isolation of critical application, and at the same time they allow the edge node to do and to perform really critical aspects related to critical I/O and other critical devices attached to it.
That makes sense, and we will revisit obviously the topic of the devices virtualization container a bit later. And one thing I really understand is important from what you said, Nicola, is the fact is isolation is one critical thing to think about. Isolation of processors, resources, even hardware resources. And at the same time, edge nodes, edge infrastructure are connected devices, and networking is especially important in everything that we do at the edge. Whatever we're talking about, 5G, -7, LoRaWAN, etc. And so my question to you, Ted, since networking is really your bread and butter. So what role does the network play in edge device security?
Yeah, that's actually kind of a funny question, because one of the main roles that the network plays in security is to be the source of the problem, right? It's it's the thing that makes it, obviously the network is extremely critical and important for what you want to do, but it's also the channel through which abuse, through which intrusion, through which, illegal access can occur. So, so it's kind of an interesting thing. So the network is a double-edged sword. It's providing a lot of the problems with regard to security. So it's very important that the network be set up in such a way that you are making it as difficult as possible to exploit it in ways that you didn't anticipate.
All right, and now that's certainly a good starting point. At the same time, I was wondering, I'm not a networking expert, but I hear a lot about programmable networks, software-defined networks, and that kind of stuff. Are they really useful at the edge, all of those securities, or do they introduce more vulnerabilities? And if they are useful, why?
Okay, that's also an interesting question. I think because there's a lot of talk about software-defined networking. There's actually a lot of open source activity around SDN. In my opinion, SDN is highly complicated, and it addresses issues at a layer of abstraction that may not be as helpful as we want. Typically, SDN is really giving you software APIs that access things like MAC addresses, IP addresses, host addresses, ports, routing rules, etc. So what I actually think we need is, and this has been stated before, like a different paradigm, but I think we need better abstractions for networking in the edge, in edge computing, and in hybrid, and in basically cloud native computing in general.
Okay, and that in one way really not necessarily vindicates, but matches my expectation, in the sense that as a non-networking expert, I had a feeling from the outside that SDN and that kind of stuff can be useful, but yes, is something that still need maturing and still need to progress to be useful. And at the same time, I know that a few of our members are leveraging or involved in such projects like openness and open source Mano and ONAP and that kind of stuff. Now, if we take a step back, obviously, as I mentioned, open source is really important to us. So how can open source help improve edge network security? Yourself, Ted, you've been involved in such projects, and especially Scopper is a good example of that. So how can open source really help there?
Yeah, let me talk a little bit about that, because I mentioned before that we're looking for better abstractions, and let me talk a little bit about the weakness of some of the extractions that we use now. So anybody who's done any networking at all really knows that when you're talking about addressing things, you deal with a host address and a port. So the host address can be an IP address, but more commonly it's a name that maps to an IP address, which gets you to the host, and then the port tells you which process on that host you want to talk to. And of course, in the cloud native world, we're talking about things like serverless, or we're talking about edges where we may have many edges or many devices that we want to address as a class. The host really isn't that interesting. In fact, we don't want to be bothered with that notion. The other thing I should mention is that the internet as we know it now grew up with client-server computing. So client-server architecture is what the internet is designed for. So it's really built around literally hundreds of millions of private networks that then connect up into a single public network. So this vertical orientation of the network is very well proven, and it works very well, and it's very highly performant. But it doesn't lend itself very well to edge computing, where we really might want to have some horizontal connectivity. We might want different edges to be able to easily address each other, and that's not done very well at the IP host level. So there is quite a bit. In fact, I think almost all the really interesting work that's going on in this space is happening in the open source communities. So there's the Scupper.io project that I'm working on, It's actually also based on the Apache Cupid dispatch router. So Apache Cupid is a collection of projects, one of which is called Cupid Dispatch Router, which is a high-level networking router that works with the AMQP protocol and a whole different set of addressing. So instead of addressing hosts in a large network, you're addressing processes. And so instead of providing host access to a hacker, for example, you deny that access, but you can provide access to specific processes. And it allows you to do things like multicast load balancing in a wide area. But these are not necessarily security related, but it does have security aspects to it. I'll also mention that the Eclipse IO Fog project is also using the same basic technology to good effect as well, and their focus is a little bit more on small devices in the edge and connectivity involving those small devices on the edge.
That makes sense. So it's certainly really interesting what you mentioned, Ted, and one question I would have for you is, we discussed in our Edge Native working group community meetings, various scenarios for device quarantine, in the sense that a compromised device could self-quarantine, or maybe the network could quarantine the device. So in your opinion, is self-quarantine more useful than network quarantine, or the other, or both are useful strategies in your opinion?
Yeah, I'm not sure exactly how to answer that question. I think probably both. That you would need, if a device knows that it's compromised, it will also take itself out. If you know that the device is compromised, you'd like to take it out. So, yeah, I think both are important, and I think that somebody else might be more of an expert to answer that question than I.
That makes sense. And going with the same question to you, Dihan, since you mentioned several device management technologies that we have at Eclipse, and especially that's a concern for Eclipse Ono that you are working on. So what's your take on device quarantine there?
Well, from the perspective of Eclipse Ono, the device is outside of the cloud. So we are thinking about just the connectivity from the cloud. But if you take a look at the globally from the edge perspective, quarantining microservices definitely does make sense. So limit them in the amount of CPU they can use, or resources they can use. Then on the networking layer, what you mentioned is also making sure that they can't do any arbitrary outbound connections and dial-ins to different places. That's all, I think, very important aspects of running microservices at the edge.
Excellent, thank you. And now, in the interest of time, going forward with another topic, and this is something we started already discussing with Nicola, embedded devices, virtualization, containers, and we already established this, the different security roles that virtual machines and containers can play now. When we think about embedded and mobile devices, Nicola, they are increasingly seen as edge devices. And I know that some of our members at some point were playing with the idea, hey, I have someone in the factory, with its tablet, and maybe we can delegate some edge workloads to the tablet that the employee is having, that kind of stuff. But anyway, if we take a more global perspective about embedded and mobile devices as edge devices, what are the security challenges that you've seen in your work that you think are specific to them?
From an engineering perspective, I don't think there is any difference between a mobile device and an embedded device. My phone is an ARM64, and pretty much it shares many of the I/O of my embedded board I'm working on, doing an embedded custom operating system. So let's talk about, they almost are the same hardware, but there is something that makes a difference between the two of them, is what you want to attach to them. So in the case of a mobile phone, so let's say that in the future, in the industry 5.0, we have workers walking around a factory with their phone, with their tablet, that is an edge node. In that context, because I don't see those devices to be connected to a special machine or some special hardware, I guess that the container technology is what provides this extremely important way to deploy software in one shot. I remember Linus Torvalds say something really interesting about, package managing, and he said, like, if all the software was statically compiled, we don't have problems of dependencies anymore, and so we don't have to go through a lot of resolution issues, like when we wanted to transfer software to different devices. And so containers brought that concept on of course, I'm on a different context, but still they bring that value on, hey, let's deploy something that is consistent, and I can distribute those resources across multiple devices, and this is great. But again, in my opinion, in a real use case scenario inside a factory, we have some of those embedded devices that needs to command, instruct other machines in the pipeline, and this is where actually the technologies may be not anymore suitable for doing the same thing. So from a security perspective, again, for me, is how can I prevent a critical process that's control a special machine? That critical process needs to be protected, needs to be, again, isolated from the outside world. What if a microservices is doing something bad to the CPU? There is a DOS attack, so there is like a denial of service, there is some sort of overflow. How can I actually make the machine that is operating safe in that context and try to isolate and shut down whatever is going wrong in a particular partition of the system? And again, here, embedded systems are really complex, beasts, because we have multiple core. Every core can host an operating system. It's called, like, again, asymmetric multiprocessing. So if I have different cores that address, different OSs, I may have like a supervised or unsupervised architecture, but at the same time, in those two different scenarios, I have a complete control of which resources are allocated from an hardware perspective to the specific task. Well, at that point, I can play with virtual machines, and I can deploy containers in virtual machines, but at the same time, I'm guaranteeing that no processes are interfering with other processes. So in the case of a tablet, in the case of a phone, I guess we can pretty much be okay on a very effective deployment model with containers. And so I can really have a backplane, and this backplane decides what needs to be distributed on the edges, and that's cool. But at the same time, we need to keep an eye on which resources physically are addressed when something is computing on the machine, when something is going on the edge devices. And this is where we can play with both of them. We can create hybrid systems, so we can really do a lot of interesting things, really work with fantasy and of course with adherence to the reality. Of course, we cannot really invent weird stuff, but again, in that context, the open source is providing a lot of inputs. Again, it's more about best practices, in my opinion. But again, we have open source technologies for embedded computers, and ARM right now is now really important inside the virtualization context. Zen, that is probably the most important, like today, virtualization technology on ARM computers. ARM processors, architectures. It's an open source technology, and is, it works really well. Not everywhere, not in every platform, but of course it's a good baseline. Docker is, like, of course, the containerized technology that is working everywhere in the world. And there are other also technologies. I like exploring different other technologies about virtualization. I like monolithic virtualization. This is what I like the most, but it's very tied to the hardware. Xvisor is a beautiful project out there for doing monolithic custom hypervisors on embedded devices. So again, how you orchestrate this is driven by probably good sense and best practices, but out there are so many different things that you can play with to just invent your own architecture that make, you know, safe tablets and computer and regular like mobile devices, and also critical devices where something is really important needs to be preserved and taken care of.
And then we talked a lot about devices, and going back a bit on the networking team, I tended to ask all of you, let's say you have to deploy an edge, a solution that involves edge computing. So is it better to run that on the same network as everything else? Let's say you are in a factory, you have edge nodes, you have robots. So you connect all of that on a single network, you know, that is connected to the IT network of the organization, or in a separate one, or some hybrid model. What would be your topology of choice there to ensure that things are secure?
Well, I mean, first question is, what is your topology and technology of choice to make sure that things work, right? Mm-hmm. And if you're in a factory, our experience is that you can essentially forget Wi-Fi. So for anything that moves around or needs connectivity and for which you don't have already, you know, a dedicated network, the direction we have been taking in the past few years is obviously industrial 4G. And going forward, we just see one technology for all wireless, one dominant technology for wireless communication inside the factory, which is 5G. As you know, 5G was designed first and foremost for facilitating certain enterprise use cases, and that's where it will allow us to innovate the most. 5G will allow also, potentially properly configured and used by the higher level software, to do some millisecond real time, which is interesting for quite a few industrial applications, and will facilitate perhaps, you know, the connection between the portion of the, if you're on a factory floor, the machine that necessarily will have to run either on TSN when they get there, or as of today continue to run on field bus or similar technologies, and then the world of IT that will remain on more or less Ethernet-based solution. So as you know, the convergence that had been envisioned was really with TSN. The complexity that TSN poses is that you have to pass, you have to upgrade some of that hardware, and you have a wire. So what we are seeing actually on the market is that in several instances there is a preference toward converging toward 5G and retaining some of the field bus as they are, and then integrate the rest out of that.
Yeah. So the concept of a sort of gateway that exactly. Plays a role of a bridge between the whole stuff, the Modbus, the backnet that you've got on the floor versus the rest. Yes.
Then what I think is the most promising in terms of security and let's say electromagnetic interference or tolerance to electromagnetic interference is Li-Fi. So Li-Fi, maybe some of you know, is in heavy use in Hollywood. It has been so far too expensive to be used in industrial. But what is interesting is that you have no interference with a robot arm that moves. And in terms of security, as far as every wall, or if I close window, nothing gets out of it because it's based on light. So we are not there yet, but for me that's a super interesting future direction to follow closely. And we are experimenting with some of it. Yeah.
Certainly something to keep an eye on. And continuing with you, Angelo, so we talked a lot about networking, we talked a lot about devices. So what I would try to get a bit deeper about with you, hardware versus software, centralized versus decentralized. When we consider edge device security, we talked about some hardware aspects, some software aspects, but is it really more of a hardware or a software issue, in your opinion?
Well, from my perspective, it's actually both, right? Because, and in fact, there is hardware, software, and network. that's really the trick, because the hardware has to provide us with some basic capability, right? In some cases, in terms of proper either acceleration or computation capability for doing encryption, the ability of storing secrets securely and in such a way that it's tamper-proof. But then, once the hardware provides that, and we have solution for that today, the software has to leverage it, okay? And that's where sometimes we have issue today. The communication protocol we use, as it was mentioned by Ted before, there are lots of things that are not quite right for the use case we want to address. So he mentioned a few interesting problems, but the underlying problem, as he mentioned, is that we need to move from host centricity to named data. And as you know, we have also some very innovative project in Eclipse IoT and Edge, like Zeno, which is a named data networking protocol. And if you start reasoning about that, networks becomes important because the way in which you designed your protocol makes some attack harder, right? Makes load balancing easier, makes security easier, and makes the combination of decentralization and security easier. So I see really hardware as providing, some of the basic prerequisites that we need in order to be able to build security. But then we need to use those to properly implement security within the software that runs on it, right, at the various level and in the network. And one of the important, I would say, element that is not, it's a facilitator, but which we shouldn't underestimate, is also the programming language that we use. As you know, we've always been kind of orthodox with that, right? And but we see, for instance, the rise of Rust as a good example of programming language that provides you with a good set of, let's say, invariants that make it easier to build secure software. That was one of the reasons why also Mozilla introduced it, and I think that we have in a way, even in our development process, to start being a little bit more cautious of all the decisions we take down to the programming language that we use potentially.
And certainly that has a big impact. And at the same time, one important trend that we've seen in the last few years is the emergence of open source hardware, as a driver for innovation. So at the Eclipse Foundation, we work with the Open Hardware Group that essentially takes the open source RISC-V instruction set and makes open source processor designs, and they are built in the open by various partners and all of that. So at AD-Link, Angelo, you do hardware. So how does open source hardware factor in your vision for edge device security?
Yeah, so I think open source hardware has helped a lot in terms of accelerating innovation. Let me give an example, right? I have an example of open source hardware here. Not sure if all of you are familiar with this card.
Yeah, absolutely. I've got one.
Right. So that's a super cool example of co-design, right? Because they've designed this board in a hackathon. It uses ARM processor, and it's designed for Zephyr, right? Which is one of the OS we use. So, for me, open source hardware, it's interesting because it allows us to do some level of co-design with software and to get, in a way, platform that all of a sudden are very accessible and allow people to experiment. And then we can leverage further experience to eventually produce then hardware that maybe is not open source or not necessarily, and can address the more extreme use cases where you need either extended temperature or some specific certification, which are required either for security or for safety on some environment. Imagine, edge server that control high-speed lines in trains, right? But I think overall, as it was done for software, open source hardware has helped innovation, but as a consequence of the fact that more people get a chance to review it, test it, it helps with security for sure. But I think first and foremost, where it has helped is in accelerating innovation and the level at which people can experiment with integrated platforms, like for instance what I just showed you.
Yes,
there are I think that an interesting thing that Angelo said is about driving innovation. Today, when we look at chip manufacturer, there is a lot of proprietary things that are going on in there, and many of the things that may be possible are not possible because the chip manufacturer is not ready yet for something. So when you have to adopt, let's say, a microprocessor on a product, you got to also understand what the manufacturer is giving you with to support that processor. So let's say that you, for instance, you choose like a provider, and you have a basic BSP. That basic BSP where there is a lot of code and a lot of things that the manufacturer did develop because he has the IP on the processor that he does manufacture. It binds you from the beginning to something that may be okay, but maybe not. So I think that RISC-V and the open hardware community is just breaking that barrier. Finally, we may have like a system that is fully transparent since the inception. So from a security perspective, let's say that, let's talk about the ARM Trust Zone. So today, Trust Zone is a really nice way to save secrets inside an embedded system. But again, the implementation, the really raw and low-level implementation of the ARM Trust Zone in a real product, when I buy a SOM module, is driven by the chip manufacturer. If I don't have a reference implementation of Trust Zone in that particular context, I cannot use Trust Zone. So again, open hardware is, I really enjoy so much following what's going on in that space, because finally there is more democracy. Like in software has been like for 30 years. Now, it's time for that same democracy to be on a hardware level, providing like a great transparency and a great innovation. And I agree with Angelo. This is absolutely groundbreaking for that space.
And we see this open hardware and open source model even in the networking space, I think, although that's not a space I follow a lot, but I know there are open source designs for network switches and specialized open source OSs that you can run on that. So the potential for improvement, obviously, and openness is still increasing as we go forward as an industry. Unfortunately, that's all the time that we have. But really, it's been, I think, an enlightening conversation, and certainly one that I hope that we will be able to continue in further panels and further discussions, over time. So, Angelo, Dihan, Nicola, Ted, thank you so much for being with us today and discussing this. And you all in the audience, if you liked what you heard and like to exchange with our panelists today, well, please join us in our community meetings for the Edge Native Working Group. We are an open community welcoming to, everyone really willing to exchange ideas and discuss the state of the industry and drive innovation in open source. So please join us, and we'll be happy to, continue to discuss everything that we discussed today and even more with you. So thank you for being with us today. My name is Frédéric Desbiens, Program Manager for IoT and Edge Computing at the Eclipse Foundation. And this was our panel on Edge Device Security. So everyone, thank you again, and I hope to talk to you soon.
Well, thank you, panelists. That was a most interesting session. May I invite the panelists to turn on your cameras and mics at this time for Q&A. And everybody else, if you have questions, please enter them in the shared notes section.
Yeah, I know that at least Nicola's there, so hopefully he'll be with us very soon.
His name may have changed again.
Yeah, is known tonight, or this afternoon in the case of Singapore time, as a psychedelic shrew.
Ah, that is him? Okay, I figured it might be.
Yes, he had some trouble with his account.
Oh, fair enough. So technology is here to make our lives more efficient, easier, less error prone. Usual stuff. So this is a whole area of stuff that I have paid some attention to. A number of years ago in Singapore, we had an issue with transporter haze, with farmers in neighboring countries burning sort of millions of tons of peat to clear land in order to plant palm trees. And so it was politically touchy. I built a network of sensors to monitor haze movement in real time. And so some of these issues came up. It's like, how do I ensure that the people aren't tampering with my devices, the devices aren't sending contaminated data or distributing malware, all that kind of stuff. So it's an area of some interest. And I'm also a amateur radio operator, and so the spectrum thing is interesting. Question that I've never had a good answer on, and I wonder if either of you might be in a position to answer it. Again and again and again, in the rationale for 5G, we hear about proposed industrial applications that rely upon millisecond range timing. I've never yet seen one described. Can you describe a sort of representative case? And further, are implementations available in open source?
Wow, that's quite the vast question. So for those people, maybe
one example, please.
yeah, exactly. But for those people in the audience first that are maybe less familiar with 5G technology, the question refers to millisecond, range of applications, because essentially that's one of the promises of 5G. The latency would be so low that you can get 1 millisecond or lower latency on the connectivity, and this is supposed, at least from when you talk to those who are selling such technology, this is something that's supposed to transform the industry. The jury is still out on that, but what we've seen in our community being discussed is the fact that essentially right now, when you want to have real-time monitoring or operation of robots on a factory floor, for example, okay, typically you will plug those robots over an Ethernet network with even deterministic networking features, right, in order to have very predictable latency, because in those industrial processes, I mean, you have to be very precise about, let's say, the duration of a weld, of a welding operation or something like that. Or if you think about nuclear power plants, you need, once again, very, very precise manipulation of things. So in theory, the fact that 5G gives you millisecond and sub-millisecond latency enables you to be more flexible in the way that you simply design the factory floor, and then you don't have to rely on all of those cable networks. So it's easier to move robots around to make up for a new process or a new product and that kind of stuff. Then the other thing that we've saw are around autonomous vehicles, and in a factory context, it's really important because you will see more and more of those autonomous forklifts and other support vehicles, that will collaborate, sometimes even with humans on the factory floor. And once again, the fact that 5G would be there means that you don't have to deploy lots of specialized, networks on frequencies that won't be affected by welding equipment or electrical arcs and that kind of stuff. So once again, that's a promise. Now, some of our members experiment with that with more or less success, given the lack of maturity of the technology. So to me, and Nicola, tell me if I'm wrong, but I think the key there is really when you design a solution, when literally you are in the design phase, it's essential to have a look at a wide variety of connectivity options, and really pick for maybe one. For each aspect of your solution, you will pick whatever is the best suited to the use case. So this could be 5G, but this could be LoRaWAN if you all you need, for example, the example that you were giving us, Roland, about monitoring air quality and that kind of stuff. Maybe that's just, you know, a few bytes every minute that you're sending. So LoRaWAN, given that it covers a wide area with a lower number of base stations and that kind of stuff, is a good pick for that. And then there's Dash 7, which uses an open modulation. And anyway, it's
I feel we need to move, because this is an area I could talk about for an hour, but we have two problems. One, other questions have started to appear, and two, we have 3 minutes. So,
all right.
I will actually just ask the 3 or 4 questions, and perhaps invite Nicola to comment first, given time. Can you tell us more about open hardware projects related to your work? What else is the Eclipse Foundation involved in Asia, apart from the dev environment? And how can people become involved? Who are the members in Asia, in particular in Vietnam? And any comments on the possibility of software-defined radio for the open source movement? Interesting. Nicola. Apologies, we have 2 minutes remaining.
Right. Well, what I can say about the hardware that Angelo was showing, I don't know exactly what it was made on a hackathon. I don't really know the specification of that hardware. What is really interesting about that is the hardware is running Zephyr. And Zephyr is the new frontier of the operating system for real-time computing. So we were talking about latency before, and yeah, latency in network is absolutely important in edge computing. And again, networking locality, so embedded devices as edge nodes, and the cloud and the data is probably the three big issues and the 3 big areas. Again, real-time operating system has been for ages constrained to our OpenRTOS, that is an open source real-time operating system, or bare metal software, but it's very difficult sometimes to write software for it. Zephyr is lowering that barrier, giving you an operating system that is layered as not really like a Linux operating system, but it shares most of those interesting API that allows people to write software in a way that is more less old-fashioned than what it was back in the days. And so every open project right now, especially related to MCU, to microcontrollers, so not microprocessors, is using Zephyr as the baseline operating system. It is absolutely groundbreaking. So this is one of the, the great thing about open hardware and open software finally get together and providing a super transparency layer for doing the next generation of product. That was actually another question about the Eclipse dev environment. Probably people knows about Eclipse. This is something that actually Frederick may be like more the right person to answer. But I started coding with Eclipse back in the 90s, and I believe me as well that the Eclipse was the Eclipse IDE. That is so popular in different flavors from C++ to Java, Java Enterprise, everything, Python. Right now, you can support several languages. No, Eclipse Foundation is much more. And Eclipse Foundation has different umbrellas. The edge computing is one of those. IoT is another. There are different projects under those umbrellas. And you may probably don't know, but you may use a product that is coming from the Eclipse community actually in your product today. You don't know. So I want to challenge people to go and find where that open project comes from. And probably Eclipse Foundation is one of the possible sources that software is coming from. And Frederick, if you want to add something, because we are members. I'm using Eclipse software since decades. So
before you do, I have some surprising news. We actually have just been granted an additional 5 minutes while we attempt to locate our next speaker. So carry on.
Nice, nice. So yeah, I put in the chat, since I expected to lack the time, there were questions about what kind of members we have in Asia. And here it depends on which working group we are talking about. So in my case, I take care of IoT and Edge, which is my main focus. So we've got in names that are well known, Huawei, AD-Link, O-Ring, and a few others in the IoT and Edge environment that are based in Asia or have a significant presence in Asia. But obviously, the whole point of us being there is that we need to be more visible in that part of the world, because that's a place that we neglected a bit, to be quite honest. And I'm trying to change things by being here. So I certainly will show up at the next face-to-face edition of this conference. An important thing to keep in mind about what we do, however, and the nature of the Eclipse Foundation, is that we just recently moved to Europe, which is a competitive advantage for us, because well, we had a large number of European members, and there were some concerns with the geopolitical situation, the US versus China, and I won't get into politics there, but some of our members felt that being in Europe was, a good middle of the road solution between being purely dependent on what could happen in the US and obviously having a presence in different parts of the world. So for us, that's something that we are really proud of. The fact that we are now based in Brussels as an international nonprofit association there. And obviously, the next step after this move is really to be more visible in Asia. In other working groups, we've got several well-known Asian companies that are involved. So for example, Jakarta EE is another working group that we have. That's the new name for Java Enterprise Edition, but in the open source world. And there we have Fujitsu, NEC, and several Chinese members recently that joined and that are producing Java app servers that are compatible with Jakarta EE as a specification. Unfortunately, I don't know the name by heart, but certainly they are most of them have joined in the last few months, and we see a growing interest in that technology stack in the Asian market. And certainly looking forward to do the same for IoT and Edge, and have more people from all of the great Asian countries in the space join us and drive innovation and open source for IoT and Edge.
I guess also question number 6, Frederick, we talk about that internship. If you remember a couple of meetings ago about the Eclipse Foundation as a contributors of open source project. For instance, my company, we have to delegate a lot of time from customers and project that brings money to the company to contribute to open projects. Kinetics, my company, is one of the maintainers of the project Hara, that is for an open source embedded client for Ockbit OTA updates, so over-the-air updates. There was a discussion, an open discussion, Frederick, and you were talking about that. The Eclipse Foundation may have resources to offer companies, right, to support documentation, some code writing, some sort of help, to help companies to keep up with the open source work by providing a sort of internship from for students to actually join those open source projects.
Yeah.
Right?
So we are expanding in that space. We don't have anything like Google Summer of Code or anything like that, but you can expect developments for sure. And please get in touch with me on Twitter or LinkedIn or whatever suits your fancy if you want to know more about what we do.
Guys, thank you very much. We absolutely need another hour, but the schedule does not allow. So this has been wonderful. And yes, I look forward to seeing either or both of you in person next year, COVID permitting. Aha, our next speaker has now appeared. So
right.
Frederick and Nicola, could you please turn off your cameras and
absolutely. Thank you for the opportunity.
My pleasure. Good afternoon or good evening. No, good morning. Good morning, Frank.
Exactly. Good morning. Yeah. Thanks a lot for having me.
Before I introduce you, quickly, are you presenting slides and are you presenting video?
I would like to do a screen sharing.
Does your screen share include video or just slides?
No video, just slides.
Fantastic. Slides on a screen share are fine. We've had real trouble with video by screen share. Okay.
Yeah, sure.
So give me a moment and I'll introduce you and then hand you the. Actually, I'll hand you the presenter right now, but
I can
you are setting that up. There you are. Okay, fabulous. So Frank is the CEO of Nextcloud. In fact, he founded the OwnCloud project in 2010 to put home users and enterprise back in control of their data, to bring file sync and share technology to the next level and better align to the needs of users and consumers. Sorry, I've missed a break. To bring file share and sync technology to the next level and to better align the needs of users and customers, he founded Nextcloud in 2016, and he's been tirelessly working to realize his vision ever since. And he will talk. This track was envisaged as the privacy and security track, that being my particular interest in what I do with FOSSASIA, what I do for a living. But in fact, as I believe Frank is going to point out, the same strengths that open source brings to privacy and security also have direct and positive effects on sovereignty. So I'm really looking forward to this talk. Frank, please take it away.
Thanks a lot. Thanks a lot for having me. FOSSASIA is one of my favorite conferences and events. I've been there several times, so far in person, which is a whole better experience, obviously. Yeah, it is what it is now as a remote event, and I hope we can all meet together next year again in Singapore or somewhere else. So it's really good to be here again and be part of this great event. So topic of my talk is a bit more philosophical as usual. Most of my other talks I speak about concrete things. I speak about Nextcloud, obviously, which is my main project at the moment, and it's other concrete things. But now I want to talk a little bit about open source in general, and what free software and open source tried to achieve when it was founded, and how this fits into the current world, and together with the current challenges that we have in the world, which it's all a bit different than when it was in the 80s when Richard Stallman founded the free software movement. Now I still will talk about some concrete things. For example, the Gaia X project that is happening in Europe at the moment. I don't know how well known it is in Asia, but I find it's an interesting thing to try and shape the infrastructure that we have on the internet at the moment. I was already introduced. I'm German, as you can hear. My accent is strong. I'm a free software developer and contributor for many years, for over 20 years actually, in all kinds of projects. For example, in the KDE community, where I was a core person and a board member for many years, founded different initiatives, invited expert at the W3C at MIT in Boston, where I helped to work on internet standards. A fellow of Open Forum Europe, which is a lobby organization where we try to lobby for open standards, for open source. As mentioned, founder of OwnCloud and Nextcloud, the successor, and I'm also an advisor to the United Nations regarding the open source strategy. So I want to talk a little bit about the cloud. The cloud is obviously a big trend. That's something that's going on for many years, which is central to our internet infrastructure at the moment. Then the term digital sovereignty, which is very popular, and how this is connected to open source and free software. Gaia X, as I mentioned, as an example, and at the end, hopefully, we still have time for questions. So let's talk a little bit about the cloud. As you all know, the cloud is one of the big trends of the last few years, or 10 years, 20 years, depending how you count. Actually, you can go back to 30, 40 years, because at the end, the cloud just means that some applications and some data and some infrastructure is running on a central place, and you have like clients around it. So in a way, it's actually very similar to client-server computing or the mainframe computing that happened in the 60s and 70s. But it's obviously a big trend. But there are also some concerns around it. Organizations, companies, governments, home users, they have also some trouble with the trend of the cloud. So there is a lot of research, a lot of reports about that. One of the main concerns is, of course, security. So what happens with my data? Who is in control of the data? Is my data protected properly? And there are plenty of reports who talk about that. Also, here's another one, again, security, but also vendor login is mentioned here. Vendor login means how much dependency is there to one vendor. And is this a problem for me if I basically commit to work with one cloud vendor, one cloud company, and I can never migrate to anyone else because of the strong login that exists? Here's some other survey data, survey numbers, where again, security compliance is one of the big concerns. Also practical things like networking and performance, but also cost and other concerns, reputation, and so on. And this is actually, these concerns are ongoing. There are also legal concerns. It's something that's going on, especially in Europe. So this is something I found just a few weeks ago. It seems that in December last year, just like a few months ago, for the first time, an organization in Europe, in this case, it's a university in Sweden, actually had to pay a significant fine, a significant penalty, 50,000 euros, just because they uploaded some private data into American clouds. In this case, they use Box.com, American cloud company, and they uploaded private data to this cloud company and nothing else. And of course, US clouds are, from a European perspective, not GDPR compliant, so they're actually not legal, because the framework that made it legal was actually cancelled last summer by the highest European court. So using this cloud service in the US is not allowed for considering from the European law perspective. And now for the first time, companies and universities and governments have to pay significant fees for doing that. So these are all interesting trends that are going on in IT at the moment. So the big trend to the cloud is not so easy. This also created or helped to create the term digital sovereignty. That's something that is talked a lot all over the internet. I hear this a lot from politicians in France, the European Commission, and German government, and other European governments that I talk to. But I also hear this from people in Asia or from other areas, like Brazil, for example, and other places. There's a lot of discussions about sovereignty and what sovereignty means in a digital world. Of course, sovereignty typically comes from a perspective about is a country or a company or even a home user, are they really free to do what they want, or do they depend on some external things, some supply of electricity or water or some other goods, food, water, that I can't control, that is controlled by someone else. And then if this is the case, maybe they're not sovereign anymore. And digital sovereignty means, okay, what does it mean in the digital world? So in our world, how much dependency to others are okay, and what is too much dependency? That's the whole term of digital sovereignty. There's a definition of it. There's an official definition of the term. You can find this on different websites or on Wikipedia and other places. So one of the shortest and best definitions is this one. Digital sovereignty or cyber sovereignty is the degree of control an individual, organization, or government has over the data that generate and work with at local or online platforms. Basically, you have some data, and it's your personal data of your organization or you personally. And how much control do I have over that, and how much control do other organizations like cloud providers over that? So that's the question, and this is like the key thing that needs to be considered here. Of course, if other organizations have a lot of control over your data and your applications and your infrastructure and everything, then this creates some risks, some strategic risks. So here are some risks I collected again from different articles all over the internet. The first strategic risk is loss of control over data represents a strategic risk for our society. Individuals, businesses, or governments are surveilled and the data is monetized by foreign corporations. Okay, so if basically someone else has control over that, then this is a risk for our society. And if the data, if individuals, businesses, governments are basically then stored and controlled and processed by someone else, and in some cases even monetized, that's especially interesting, because the only thing I want to do is just work with my data. Maybe I just want to read my mail at on Gmail, or just want to store my data in Dropbox, or use, I don't know, Facebook for talking with my family, exchanging like whatever cat pictures or other fun things. And suddenly there's this other organization, this cloud provider, who is monetizing that by advertising, or in other words, my data is then monetized by others. That's a bit strange. The next strategic risk is that one, when societal debates take place on platforms owned by corporations and hosted in countries with a vested interest, how can we trust the results? So this is obviously something that we saw like in real world, like in the US happening the last few years, where also other countries, by the way, but the US, of course, most popular, where you have like social media, and social media is used to build up opinions and about politicians and about other things, and we see conspiracy theories, for example, popping up about politicians, and this can be controlled by other parties, and sometimes like companies or other countries have an opinion about that. And that this is interesting, because this kind of debates and this kind of interaction, this kind of social communication in the past happened like only with like local newspapers and local media, but suddenly because of the internet, this is like a global thing, and suddenly people who are not really part of the country are part of the conversation. Next strategic risk is when nearly all commerce flows through a few selected platforms. These platforms control the price and capture most value. That's something that we see here in the COVID-19 times, that a lot of people have to use e-commerce. They order things online. And ordering, I mean, in Europe, for example, most people order from Amazon, which means really Amazon is growing a lot, is growing like crazy, while other local shops, they really have trouble. They're closed. They're not even allowed to do business. And this is, of course, a big problem, because if then like centralized platforms like Amazon become become basically the place who controls the e-commerce, the prices, the products that are offered, who are they offered for, how the recommendation engine works, to who does the analysis and so on. So they basically put themselves into a huge power position to basically control complete commerce in the future. It's again another risk. And the last one is, of course, about innovation, right? So if basically companies and startups and open source communities want to do innovation, for example, in the area of machine learning or big data or other things, then if the only way to do that, the only way to do real machine learning or big data analysis or do other innovative things is to use this kind of cloud services, then at the end, this cloud service also have control of your innovation. Right? We have to realize that maybe you do some interesting things around, like, I don't know, self-driving cars as an example, but you can only do this using like some machine learning infrastructure provided by, I don't know, Google. Then of course Google can switch off your innovation by switching off the infrastructure below your innovation. That's a big risk again. Of course, this is all seen by politicians nowadays. I mean, here are some examples of politicians in, as I said, in Europe, but also the case in Asia and other places, where they really see this challenge for our society of this big dependency to some proprietary centralized services, which threaten the digital sovereignty of all of us. Of course, from an open source and free software perspective, this is a bit funny or interesting to watch because the whole discussion is not new, right? Because the whole discussion actually is a lot older, of course, with different words. So this guy, of course, most of you might know him, that's Richard Stallman. That's the person who created the free software and also open source movement in the 80s. So, of course, the 80s was a different time than nowadays. There was no cloud computing, but the overall idea was actually, the overall threat was very, very similar. So he postulated the 4 freedoms, which are the 4 things that every computer user, developer, or end user should have to be in control of your data. The first freedom is that you should be able to run any program as you wish for any purpose. Right? So, and running a program, of course, at a time means running the program on your computer and not running it in the cloud, obviously. So you should be able to run it yourself anywhere as you wish for any purpose. The second is the freedom to study how the program works and change it and adapt it. That's of course also very, very important to learn how other applications program works and change it and improve on it. That's again something that's nowadays really difficult because the program really runs in the cloud and you just use it as a service. And usually there is no way to run like the cloud application locally to study it, to change it, to improve it, to make it better, because it's just a service you use. The third one is the freedom to redistribute copies so you can help your neighbor. That's of course a bit funny, right? Because at the time, distributing software means usually distributing software on floppy disks. And the idea was you can give applications on floppy disks to your neighbor. Yeah, nowadays we have the internet and everybody is our neighbor. But yeah, the idea is to have the freedom to give your applications to everybody. And the fourth one is then also very important that you also have the freedom to distribute your modified version. So this is one of the key principles of open source and free software, because you should be able to change and adapt the software and improve it and then distribute the improved version. So this is how we can all build on top of each other. This is how we can all like innovate and do interesting things. So again, this all came from a time that was simpler. You had a computer. I mean, here as a picture of an old IBM PC, and the computer, of course, was like sitting on your desk or under your desk, but it was like your hardware. Then you have open source free software running on it. And then both things together, you basically achieve digital sovereignty, because you complete control about everything. It's your computer, it's your software. And because of that, also the data is also stored on your computer, on a floppy or on a hard disk, and you're in complete control. Of course, nowadays, it's a bit more complicated because there might be more pieces needed for digital sovereignty. So the first one here is that's needed is data, because nowadays it's not necessarily the case that the data is stored on your hard disk, because the data is stored like, I don't know, in the cloud or somewhere else. So Richard Stallman could safely assume that your data is safe once you have free software. But that's nowadays not necessarily the case, because as I said, someone else is hosting the whole system and the software. This led to a few things. The first is the user data manifesto. That's something that I, together with some other colleagues and friends from other projects, created a few years ago. This is basically the idea that we should postulate basic rights that people should have over their data. They should have the control where the data is stored and who has access to it. So it should be my decision if it's used for advertising or not. I know it, how it's stored, which also means I have control over the software. I know which software is processing the data. And I also have the freedom to choose a platform, which means if I don't like one cloud provider anymore, then I should have the right to move to a different one. So these are basic rights. And this is, of course, like a little bit missing from the 4 freedoms or from the open source definition, because as I said, it came from a world where data is usually local somehow, somewhere. Then there's another thing, which is the whole area of machine learning, which, as you might know, machine learning is completely useless if you don't have data to learn. So that's also interesting. So if you want to have an application, a machine learning, artificial AI application, you need different things. You need hardware to run it on. You need the software, but the hardware, the software alone is really completely useless. You need the training data. You need to access to the training data. Otherwise, your self-driving car cannot drive. And that's another thing that is needed nowadays. But of course, there might be more. I mean, there is this other thing called the cloud. We really need to have control over the cloud. As I said earlier, that's something that's really missing in the digital to achieve digital sovereignty, because yeah, not everything is local. Now to talk a little bit about the cloud, what it actually means. That's something I did some research at some point, where the term cloud actually comes from. I mean, I have here in the picture, I have this nice cloudy artwork here, right, with a question mark in it. I don't know how many of you actually wondered where this term is coming from, where the cloud is coming from. And I did some research, and I think I found an answer, because in the 90s we had like this kind of diagrams. I mean, the people who are as old as I am might remember some of these old diagrams. You can see you have like a computer with an ISDN card, and you have a fax machine, right? You have a telephone, and you have all kinds of communication and computer devices all connected to a network. And then on the left-hand side, you see this cloud thing. You see this cloudy symbol, and that was a symbol that was used by a lot of people. Was part of the clip art collection of PowerPoint. This is why I think a lot of people use this picture, this cloud. And what I wanted to say with this symbol was, okay, the network goes on here. Here, the red line, the network is still connected to other things. There are more things connected to my devices. Of course, telephone in this picture only makes sense if people can call me, right? And also, obviously, there are other telephones somehow that can call my telephone, but that's not part of this picture. That's not really my concern. That's done by other people. That's outside my area. So this is what this cloud thing wanted to say. Another picture is that one. It talks about database servers and switches and all kinds of components with network cables and all kinds of infrastructure. And on top, there's also this cloud. So it's this cloud, which means there is more. There's more. That's not my responsibility, but it's still happening. It's still somewhere. Of course, nowadays, it's really changed. So the cloud is now huge, and my applications are tiny. Right? So basically, what I have here at home or in my office is I just have a laptop and a phone, and that's it. And both devices are relatively useless nowadays if they're not connected to the cloud, because this is all where the data and the applications and the other people are that I'm communicating with. So this is the cloud nowadays. There is this initiative from the Free Software Foundation. They have to sell these stickers. There is no cloud. It's just someone else's computer. That's of course very true. A lot of people might not realize that, end users, that the cloud is just other people's computers. So it's basically the computers of some big corporations that you rent. So you rent some infrastructure, some services, some compute, some storage, some payment service, some kind of services from these cloud companies. But at the end, you're just like using someone else's computer for that. Also someone else's software, by the way, most of the time. People think that the cloud is something that is like somehow magically happens in the sky. But yeah, it's owned by others. So I did some research. I wanted to say, okay, where is this cloud? Where is this? I mean, this is here the world map, and where is this cloud? I mean, it must be somewhere. It's not in the sky, definitely not. It's computers. There must be somewhere. And I did a lot of research, but I was very fast, because the answer in most cases is the cloud is there. So this is the star here that marks Silicon Valley area around San Francisco in the US and the West Coast. This is where most IT big cloud companies are actually hosted, or a little bit north, the Seattle area, where you see Amazon and Microsoft, but that's basically the area where the cloud is. So it's very, very centralized. It's not very, I don't know, not clear. It's very concrete and it's owned by some very big companies. And the cloud might be a misleading term here a bit. Okay, but going back to digital sovereignty, I ask a lot of questions now. Let's go to some answers, some things that we need to improve the current situation. So what do we actually need to achieve digital sovereignty? And now I try to get some, give you some answers, and in some cases also some concrete examples, but maybe this is also inspiration for some of you to help in other areas. So the first is, I think we need a rich and decentralized infrastructure. So it's a good thing that there are cloud providers. I just think that there should be more than 2 or 3 big ones. I think there should be thousands of cloud providers that are competing with each other, and they follow like open standards, and you can switch between them as you like. And there should be cloud providers in every area in the world. I mean, this here is FOSSASIA, right? I mean, I think that China is doing a lot of things here, obviously, but I think there should be cloud providers in every country. This, as I said earlier, this is just important for our future, for our privacy, our security, our innovation, and a lot of other things. So we need decentralized infrastructure all over the world. Right? Lots and lots and lots of providers who help here. In Europe, this is something that politicians try to solve with the Gaia-X project. Gaia-X project is an initiative by the German government, French government, and many other governments. And the idea is to build up alternatives to cloud services from the US. We have over 200 members already. I think this number is actually outdated. There are a lot more now. And the idea is to have a decentralized cloud infrastructure that you can use and switch between them. And this all should be done with open standards. So that's I don't want to advertise this initiative too much because it is still ongoing and still not clear if it works out. But I'm happy that politicians understand that you want to have this free market of alternative cloud services all over the world, in this case in Europe. Let's see how it works and if it works. Open standards, obviously, and open source free software is key for that. The second is, I think everybody should have the choice to run applications on-premise or off-premise. On-premise means like on my servers, on my infrastructure that I control, which is sometimes just better, maybe cheaper, maybe faster, maybe better to have direct access to everything. Or if I choose to go into the cloud, that's also fine. Again, as I said earlier, with the right choices. So, but that's something that everybody should have as a choice. It should be, we don't want to have a situation where you can certain things like machine learning, for example, only by giving your data away to someone else. The next one is free software, open source. So obviously the applications that are running in the cloud should be free software. Why? Because I want to study it, I want to see how it works, I want to change it, I want to make sure that there are no backdoors in it, I want to innovate on it, all the benefits I described earlier. So we need to have free software, open source alternatives to all these cloud services. This is where I also quickly want to pitch Nextcloud. Obviously, this talk is not about Nextcloud itself, but with Nextcloud, we try to solve one part of this problem, while Nextcloud is software that's providing like files you can share, chat, video conferencing, groupware, Office pieces, Office document editing components, which can be run as you want, wherever you want. So that's something that is piece of it. But of course, there are many, many more pieces from Linux kernel, from virtualization, storage databases, all kinds of things that need to be available as free software so you can really do what you want on-premise or off-premise. The next thing that's needed is many implementations. You really want to have alternatives. It's really bad if there's only one cloud provider and one application and one standard and one company and everything is very centralized and monopolistic. You want to have many implementations, alternatives to everything. And these many implementations are not a problem if they all use open standards, because it's open standards is guaranteed that you can mix and match them together. You can say, okay, maybe I want to use different virtualization system. Maybe you want to use different database or different storage, different collaboration software as Nextcloud. Maybe you want to switch to something else, and so on and so on. And this is all possible if we all use the same standards and we can migrate between them, and we don't have the vendor login. And then last but not least, I also think that we need a little bit of help from the politicians, that we need certain rules how data is handled. Like the GDPR in Europe, which basically guarantees, or basically by law, has this mandatory requirement, guarantees that data should be portable. So it should be possible to switch from one provider to another. Only this really guarantees privacy and security and innovation around that. Okay, so now I'm at the end of my presentation. I'm coming to the summary. I think digital sovereignty is mandatory for a free and open society. So if basically if our data and our applications are locked into like a centralized like system, then we can't have a free and open society anymore. That's mandatory. So I think we can and we have to shape the future of IT and of our data and of our applications. It's important, otherwise we might go into a very dark direction. And we are the right people to do that. I mean, this is a technology event here, that's a technology conference. We are free software people, open source friends, developers, contributors. So we are the people who can shape this future to make sure that it goes into the right direction. The internet and the cloud is built by engineers, so which means engineers can also change it. So the internet or smartphones or social network or the cloud, this is all not done by nature. Right? This is not like trees and rivers and hills and stuff. These are all done, they're all built by humans, which means humans can also change it. We should change it. If we see problems with the way social networking works or privacy works or the advertising market works, then we can also change it. And that's something that we should try and that we should do. I think free software and open source is the key to digital sovereignty. And yeah, this is why I'm really happy to talk about this topic here at the Free Software conference today. So thanks a lot. These were my presentation. I don't know if you still have time for some questions.
Absolutely, yes.
Oh, awesome. Thanks a
lot. Thank you, Frank. That's you're sort of singing very much my own tune there. I would sort of offer an observation that sovereignty is important, but it's at least at a nation state level. I would argue that it's important for an additional reason, and it's one that the EU in particular excels at. And that is that sovereignty has been used as the basis upon which to build a framework of human rights that is unparalleled anywhere in the world and anywhere in human history. And so it's different societies deal with this differently. The US is very proud of their Bill of Rights, despite the fact that things have changed in 2 centuries. They have not quite updated it. But different societies will do it in different ways. But I view sovereignty as important, not merely because it allows, as we are currently seeing in a neighboring country, a military junta to project power, but that when sensibly governed, it actually provides the basis, and so far as I can tell, the only basis for an effective human rights mechanism, and indeed GDPR is explicitly stated in terms of the European Declaration of Human Rights. It explicitly creates 8 named human rights. The whole of, I think it's section 3 is actually data subject rights that are created by the regulation. And I'd add, I spoke, I think 2 years ago on the sort of overlap between free software and GDPR. In effect, it's the same thing. They're both about, it's not so much that Stallman forgot about data, although you're quite right, it was not relevant at the time. It's rather that software and personal data have slightly different characteristics, and to establish the integrity, if not the literal sovereignty of an individual, a degree of awareness and control by individuals is necessary for both. In the case of the devices around us, that we control the software that's on them, and the case of data about us that's possessed by others, how it's used. And so to the extent that we can strengthen that by technical means, and indeed as a counterbalance to the Californian companies running away with it by technical means, yes, I strongly agree.
You said it better than me. Thanks a lot. And isn't it funny that the whole free software and open source movement, which started from a very nerdy technical way, right? It's about like really software. Most people, it's not really important for society. Who cares? And also like and then it became interesting for lawyers who really discussed like license text, again, boring, right? But nowadays it becomes clear that it's so important for our society, right? It's not just like what developers do or what lawyers like to create like license text. No, this is so key for our society going forward.
So I continue to be active in FOSSASIA, particularly for the F rather than the O. And I'm really thrilled to be introducing speakers who are addressing this particular side of the problem, quite apart from the fact that you've found a flattering photo of Richard Stallman. Congratulations. There are some questions. I have one, but I'll ask the audience ones first. In no particular order, most of the cloud providers in my country, Vietnam, are government-owned companies, FPT, VTL, VNG. Do you have any advice on how we can convince them on the importance of open source and get them to offer open source cloud? You said in the beginning your talk about open source, in the beginning of your talk, that open source is gaining traction in China. Any thoughts on that?
So I first have to say that I'm not particular, that I have a lot of information how the cloud market works in Vietnam at the moment. So I can't comment a lot about that. In general, it's of course a challenge to convince cloud providers to use more open source. Yeah, it's the thing is, it is needed, but they might not see the need for themselves to open up. Of course, the good news is that a lot of them are actually using open source components, because no one, even the big ones, even Amazon or Google, can't like write everything from scratch. That they use a lot of open source components, which hopefully enables like everybody else to replicate it and host it themselves. There is a huge fight going on about the right license. So this is a topic of another complete talk. So I don't want to go too deep into
I had an entire panel on this topic on Saturday.
Oh,
so.
Excellent!
Because it was a throwaway line in a discussion with Mario a few months ago. He's like, "Hey, you should do a thing about that." I go, "Okay." And then when I thought about it, and it's not necessarily obvious. It's sort of
super interesting. There might be ways to. Yeah, there might be ways to force them to basically open up and to publish their software with licenses. But as I don't want to go into that. It's a whole nother. We need hours to talk about it. And it's great to hear that there was already a panel about it. It's a great event. Yeah.
Indeed.
So,
Norbert, can I ask you to turn your camera off, please? Sorry, we had to be an intruder. An enthusiastic upcoming speaker. There was one there. There was a question about orchestration, which seems to have disappeared. Okay, never mind. What steps should we take next? Hassle politicians, build awareness, start our own services? Paul is asking this question.
I try to give some hints in the second half of my talk. I think there are lots of different things. I mean, we need governance from government, like laws, like the GDPR thing. I actually know that the GDPR inspired similar laws in other areas. I think that's a good thing. That's needed from a political level. Then from a economic level, I hope that there are more cloud companies. I hope that it's possible, because there are so many free software components nowadays, that it's, well, maybe not easy to start a cloud company, but hopefully not super hard, because you can use existing components. You can use, like, I don't know, OpenStack, Kubernetes, lots of other components, Nextcloud, for example, too. You can use all these components and relatively quickly build up an offering that is attractive for your market. So yeah, I hope that a lot of people do that, so that there are alternatives to the big US cloud services. And from a developer perspective, free software perspective, yeah, I hope that we all together still keep on writing nice, great, competitive software that's using open standards, using open licenses, to make our community more powerful. I think these are some things that could be done.
Strong support here. Two related questions on Nextcloud. One was simply, could you tell us a little bit about your roadmap, perhaps what you're doing, your priorities in the next year or two? The second, a little more provocative, maybe there are limits for the future due to the advantages of PHP. Do you plan to change the technology stack?
Yeah. So I don't really want to talk too much about like concrete features. I'm a big fan of announcing features before they're done. So I'm not a big fan of like vaporware and pre-announcement. We basically never do this at Nextcloud. So when we talk about a new feature, then it's there and working. Just to don't disappoint anyone. I think it's a good thing, and also because Nextcloud is an open source community, so we have thousands of volunteers working on Nextcloud in all areas. I mean, we have 2,000 volunteers alone helping with code, right, in our GitHub repositories, which means I myself don't even know what's happening next. I mean, there are some things that there are some core people working on, but I mean, everybody here is happy to contribute and to improve it and contribute a feature, and then this feature will be in Nextcloud, the next version. So I can't really answer that. It's also a decision of the community together. And then talk about the technology. So Nextcloud is actually using lots of different technologies. It's true that a big part at the moment is PHP on the server, but there are also components. For example, the high performance backend for Torque is Go. So we have another Go daemon, Go service that can be used for improved scalability. Then actually the last release just 4 weeks ago or 3 weeks ago, when we launched Nextcloud Hub 21, we introduced another component written in Rust, also on the server, that improves communication with the desktop clients, makes them a lot faster, more scalable. So we are improving in the architecture and technology in lots of different areas. It's no longer only PHP. We use like the right technology for the job. But one thing we are not going to do, I can 100% guarantee that, is to throw everything away and start from scratch. I'm just not a big fan of like rewrites of software and then years later expect that it's better. That's never, if you know anything about the history of IT, that's never going to work. So we are improving constantly. We have more like an agile process where we improve. It's better than start from scratch.
Not everyone has yet gotten the memo about iteration. Now, many good questions appearing. I wanted to ask an economic one, but actually there's quite a profound one that I would be interested to hear you address. And this applies not just to the big guys, but also to the sort of the thousands of mid-sized and smaller sized cloud providers. How can we trust the people running a cloud service? How do you establish that? What are the limits? How do you choose?
okay, that's another philosophical question. At the end of the day, I mean, if you basically your cloud provider is someone you pay for to do something for you. The same way you trust a cook in a restaurant where you eat to give you good food, or as a taxi driver, you trust a taxi driver to drive you properly and do not crash the car. Yeah, of course, you also trust the cloud provider to give you some certain services. That's just in the nature of like outsourcing something to someone else. And I think it's fine. We can trust other people, but but if someone basically is violating this trust, then we should have the freedom to go somewhere else. And we should also have if there's only one taxi driver in the world, and that's a problem. It's the same with cloud providers. If you can go someone else, that's fine. Then some cloud providers doing a good job, some other cloud providers doing a bad job. If you have the choice, that's fine. And if they use free software, then we can actually also see what they're doing. Right? If they're running some proprietary software, then we don't even know what they're doing with the data. Free software helps there to check that. And GDPR and other legislation enforces certain basic rules where every cloud provider has to follow. So like same as a taxi driver, right? The taxi driver also needs to have a license and other things to be able to be a taxi driver. So I think it's a combination of like right legislation and transparency, and then also the choice to go somewhere else. But some basic level of trust is of course needed if you get a service from someone else.
Certainly the healthy competitive markets are critical and are a really important element of trustworthiness, because they make it possible, they take away the opportunity to abuse monopoly power. We still have a few more minutes, and of course questions continue to come in. One should always ask, do you have job/internship opportunities for students from
100%? We
Where do they go?
talked about it. Nextcloud.com/jobs. There you can. There are some jobs listed, but if the right job for you is not listed, no worries. Just still send us some information, so your CV, what your background is, what you like to do, and we can definitely do interns and all kinds of things. Yes, definitely.
We've got a couple of questions here on slightly out of scope. What open source software apart from Nextcloud should we run? I think that's probably a bit open-ended. And can we integrate Nextcloud into Eventia, which I suspect is a question from Mario. But more than one person has put a thumb up on that one, so it's clearly popular. And I agree that we have some gaps that we've been sort of pushing people into Google Docs and other places like
right.
We have perhaps where we should be looking at this ourselves.
I wanted to point out that the Nextcloud conference that we also do once a year, we also use Eventia. So we already have there's already some overlap, and integrating our software with each other is definitely a good thing. We should do that.
Very much. Finally, and yes, my question has now been overlapped by somebody else. The question that's been asked is, how do you see the social lock-in effect? A cloud service may be more localized, personal business decision, but others are more complicated, especially when it's a social community product or tool. Things like sort of large-scale social networks. And related to my own question, at the infrastructure end, which is things like CDNs and edge hosting capabilities, and we're now talking 5G edges, which are Amazon and others providing the ability to push your code out to within 1 millisecond latency of the end device. I think I would ask, similar to the social network effects that have a sort of monopolizing effect, the same problem arises there. The economies of scale are so enormous, as with, say, and the networking effects, like for, say, power distribution, that they end up being natural monopolies, and indeed that they're planetary in scale. Is there anything other than legislation to get in the way of, firstly, do these economic effects exist? And secondly, are there controls other than legislation that allow us to mitigate them?
So that's again a very big question. Also, like touching hardware and social networks and lots of different things. So from a social network perspective, I think there are people who try to solve that, the lock-in effect. that you have on the social side. Everybody knows what it is, right? Because the thing is, if let's say Facebook would release all their software as GPL software tomorrow, then the free software community would be very happy. So finally we won. Facebook is open source. Of course, this would not really help anyone, because if I would then set up my own Facebook server at home, it would be very lonely there. There are not a lot of people like using my server to watch my cat videos because I'm the only user there. So what's needed additionally to free software are open standards and especially federated APIs. So you can basically connect different social networks together, which might run the same software or different software, but they can act as one thing. And there's a good example for that. There's the Mastodon social network. Some of you might know it. I would encourage everybody to use it. It's basically at this moment an alternative to Twitter, Mastodon, and it's using an open API called ActivityPub. That's actually one of the APIs where I contributed a little bit at a W3C to this standard. And this is this open API. And it basically means that there can be many servers also run by different organizations, but they're still all together one big social network. And also, by the way, Nextcloud, we also implemented the ActivityPub API. So a Nextcloud server can also part of this distributed social network. So this is something that can be done from a social networking perspective. The challenge is that we still need to make it like so much easier, right? If you just go to your phone app store and you download TikTok or whatever, and you can just start, right? But if you use like this decentralized system, then you first need to decide which server you use. Maybe you use then the, I don't know, the Vietnam TikTok server, and you can still watch videos from other servers, but they're distributed. So it becomes unfortunately a little more difficult for the end user, which might prevent this like trend. But I think this is how we should move forward. About the hardware side, the 5G thing, economy of scale, that's a whole nother discussion. It's of course a challenge. We have this economy of scale thing that I mentioned, the cloud software area. We also have this hardware. I'm not a hardware specialist. How we can overcome this de facto monopolies. I know that here the FOSSASIA community, there's a big trend around open hardware. Maybe this is a solution, but I'm just not very qualified about in the hardware space. Sorry for that.
I'll offer a hypothesis on both but we then need to wrap. On the social network one, also the federation one, yes. I mean, it's email. I'm an email guy who's gotten into privacy, but email works perfectly well in this federated world.
Yep. Exactly. An email is not owned by a company, right? No one owns email.
As Marlon Spock, the Signal guy, points out, it's a bit difficult to federate when things are moving quickly, but as things stabilize, which they have to as you get to billions of users, then it becomes possible to point to sort of good ways of doing it. And I would suggest that from a legal perspective, it's really an elaboration of the data portability right, but in the e-privacy tier, the communication law, which is basically, I would suggest, if you've got 10 million or more users, then you are obliged to make federation interfaces available to all comers, including competitors. I think there's a regulatory solution there. At the 5G edge, I suspect we have to have working technical solutions, as with the federation. Until it's working, there's nothing regulators can do. But assuming we get there, I suspect that part of the answer is similar to former monopoly, like state-owned telcos, where countries have wanted to set up competitive markets, obliging the old monopoly to make space in exchanges and phone towers available to competitors. I think the same, that 5G licensees, yes, you get to use this valuable spectrum, but you must also allow other parties to co-locate equipment at the same light speed distance from the radios, so that you don't have a sort of adjacent monopoly on hosting.
Yeah.
Anyway, for your thinking, we are out of time. Thank you so much. This has been most enjoyable. Next up, Norbert, please turn your camera back on. Ah, oh, and Frank, please turn your camera off. Hey, you cannot turn your camera on and then walk away. You're muted. You're still muted. You're still muted.
Yes.
Yeah. Okay, fabulous. Hello. Okay, so I'll introduce you in a few minutes and then invite you to start your presentation. Right now, the question is: are you presenting slides? Are you presenting a video?
I just uploaded my slides already 2 times to the system. I'm not sure if they are available now.
No, the way it works, sadly, and this is perhaps a follow-on from the question that was just asked about integrating Nextcloud into Eventia.
Okay,
unfortunately,
right.
each of the rooms is separate. So I've just made you a presenter. If you click on the...
Okay, I have to upload it again.
You have to upload it to this room, yeah.
Yes. Okay, no problem.
Please do that and
smart speaker.
But in the meantime,
no problem. Yeah.
3 minutes, I'll wait for you.
3 minutes should be working in time. Okay, there we are.
Oh, wonderful. All right. I forgot to invite Frank and those wishing to continue the discussion to head into the discussion room. Never mind.
Might do it automatically.
But Frank may prefer to stay and watch your talk.
So I think we wait 2 more minutes, right?
Yeah, we'll just do it on the clock.
Yeah.
So I'll enter you and then ask you to start. Frank, if you are still in the room, there's a question in the shared notes about a dedicated forum to discuss similar topics. If you'd like to perhaps put an answer into the shared notes under the question, that might be of interest to the person who asked it. Okay, so welcome once again. We're at the next speaker for the privacy, security, and sovereignty track. Next up is Norbert Feining. Is that the correct way to pronounce? Wonderful.
Perfect.
He's a researcher at Fujitsu Research Labs, a mathematician and logician by education, now working for Fujitsu on machine learning and open source. His core interests are mathematical logic, computer science, machine learning, AI, security, software verification, and specification. Now, if I recall correctly, you've been around FOSSASIA a number of times, yes? Excellent.
Yes.
The returning speakers. All right, well, Norbert, please take it away.
Yes, thanks for the introduction and welcome everyone to this talk. It's about smart speakers. No, that doesn't work. Pitch down doesn't work. So I guess my guess is that quite a lot of people have one of these beasts standing around in their wherever, living room, kitchen, sleeping room, whatever, sometimes in the kids' rooms. So they are quite common. What I want to report about is, I mean, I have also a few of them, and I want to but those are the devices most people know. I mean, this is Google and Alexa and GLP or Apple Home, I think. Oh, no, that doesn't work. And there's one more. There's what we call SUSE AI. It is something we developed within FOSSASIA. It's a project about developing, well, a personal assistant, privacy-aware personal assistant, and smart also smart speaker, all in one. And today, what I want to do is I want to look at the big two, like Alexa and Google Home, and compare it to SUSE AI. And that will be the first part. And the second part will be about introducing a bit more about SUSE AI and the current status. Okay, so just around what is the setup, in what surroundings I'm talking about. So in my house, there are quite a lot of devices. So I have it started long time ago with Alexa, Amazon Echo, because that was somehow here in Japan quite cheap on sale. So I thought I'd try it out. And then at some point the Google Home joined, and because I also was a Google Music subscriber, I got in Japan, there is a lot of offers. I got a Google Mini for free. And then there are some Fire TV sticks, and since recently Chromecast with Google TV. And so there are, I think in total, like 4 or 5 devices from Google and Amazon. And then there's SUSE AI. As I said, if you see also my video, I have this smart speaker. There's a standing around on my working table. And I have it also installed on my desktop. And yeah, anyway, we will have tonight, later on, we have an installation workshop if you're interested. Okay, so that's the setup. A bit more on the setup, family setup. So that's my better half. She's rather uninterested in technical gadgets. She uses them without any problems as long as they are easy to use, but she doesn't want to play with them. That is something I know. Then my daughter recently became 5. I can only recommend not giving her any of these devices in hand because they will not work afterwards, most surely. And then there's me. I have a table full of cute gadgets or devices, just to give you an idea of a few things that hanging around here on my place. So we have a SUSE AI smart speaker here. We have a PS Lab from OpenTech here. There are quite a lot of talks about. Another Raspberry Pi, a small rock chip. This is an NVIDIA Jetson with a friend printed for me the case. And that is like a smart plug from Amazon that you can also use. So all in all, I would say a rather normal standard family, right? They have someone who is just really freaking for this gadget. Then about language setup, this is also like the default family language here. What we are speaking daily is Japanese. With my daughter, I speak Japanese and German. And because we also want to try to get my daughter a bit into English. So we have all the movies and TVs and what we normally watch in English. So we have quite a mixture of languages. And also that is, I would say, a rather normal family for the standard. So now, how do we use these devices? Okay, I'm speaking about the smart speakers now, not about the Fire TV stick. I mean, that's somehow obvious. You just watch movies or something. No, so asking the weather forecast, no, I think I've never, not even once asked the weather forecast. Because if I ask what the weather is now, I can look out of the window, right? Home automation, I have this smart plug. But till now, I haven't found a device I could connect to it, where it would make sense. For example, the heaters and most of the stuff have an they cannot be turned off by just sending electricity to them. So they would stay off unless you actually press a button. So that doesn't help. Recipes and this kind of stuff for cooking, I cook a lot, but I think I usually use the web to browse for, because anyway, I mean, if I get it read out by one of the smart speakers, I cannot follow that fast. So also that I'm not doing. So there's a lot more. So what leaves is music, right? Listening to music. Actually, this is nothing surprising. So from statistics, there's around 70% of the users only use smart speakers for listening to music. I would say I'm more or less fit into this category. Of course, because we are developing the SUSE, I try to ask a lot of stupid questions to SUSE, to Alexa, to Google, to whoever, and try to stumble them. But actually, for actual use, especially with my family, also my daughter, it's music, like play this and that. So that's very common. So again, I would say this is a rather normal family, considering that about 70%, sorry, 70% are doing just music. So to give you my overall summary of these devices is that Google is deaf, Amazon is dumb, and SUSE AI is, well, in development. So this is a rather blunt and brutal statement. I will come to the 3 points of that in a minute, but this short characterization came to me quite some time ago, and I somehow liked it. So let's look at a few of the features, what we expect from a smart speaker. Voice recognition quality. So there, Google Home has an excellent recognition if, and that's a big if you can this beast get triggered. And that is my biggest problem. It is silent in the room. I stand in front of the device in 1.5 meter and say, hey, Google, or okay, Google, and it doesn't respond. It's just, it's my German accent or whatever. I come later about Japanese language. Anyway, it's completely hopeless, I have to say. I mean, it's like you get angry, and like our SUSE AI has a button where you can at least press the button and trigger it. With Google, you cannot do anything if you cannot activate it. Amazon Alexa is, on the other hand, excellent. I mean, I have to say that is spectacular, even in very difficult situations. And we often have very difficult situations, right? The Alexa is standing in the living room kitchen. So kitchen is making noises. The kid is running around and crying. The family talks, everything is going on, and still Alexa manages, while playing music, to correctly get triggered. So that's impressive. And then even the recognition is very is excellent. SUSE AI, I have to say, is bad. The recognition is, let's put it this way, on the device, on the SUSE AI smart speaker is quite bad. This is something we are currently improving. We just yesterday had a meeting with the head developer, with one of the main developers of VOCT, and modern on-device speech recognition system. This is the one thing. So this, from the software part, we are using by now Snowboy, which is not excellent, I have to say, and Deep Speech. I come to this later. So triggering is really, I mean, it's either too easy or too fast. There is also another part, is the hardware setup. We have not a bad receipt, two microphone head speaker, which is hardware-wise a good device, but also probably to my incapability to configure this hardware device. I mean, how to do all this mixer stuff for good recognition. Recognition is not very good. On the desktop, it works reasonable. I would say not as good as Amazon and Google, but it works quite good. So on the desktop, if I tell something, recognition is quite good. It's also triggering works quite nice. So that's good, but something we have to improve. So answer generation and quality. Well, how does it work? Basically, it's always the same. Yeah, try to recognize the voice, convert it to text, then do some magic, whatever, I don't go into details, to find the meaning of the sentence, like it's basic natural language processing. If some meaning is found, right, understanding of what was the question, then use a local database or just the knowledge base that is available to the system. And if the meaning cannot be determined, ask external sources. There are a lot of sources, so different devices ask different sources. Wikipedia is quite common, but normally, as it's hard to say. I didn't really check what internet connection are built up, but I guess at the same time, several services are curate for answers. And if not, all of that doesn't work, well, then give up and say, I cannot help you, or please ask later, or sorry to disappoint you. So that is very similar. This is the same, I think, for all of the systems we are talking about. So Amazon and Google are very, very similar in the sense. I mean, they use slightly different services, but otherwise works. SUSE AI is weak on NLP, so our inclusion of natural language processing, so the step of thinking about recognizing the meaning of the sentence is quite weak. Later today in the workshop, I will come to the skill development where we can discuss this a bit further on. But there is work going on, and the question is how fast we will continue, but it's okay. And it's FOSSASIA is quite good, also okay with API queries, that works normally. If nowadays all web services are based on, you have a backend server with some JSON API open and then a front end that asks. So if you have access to this API normally, that's quite easy. Language support, as I said, we have a few languages floating around in our family. So Amazon is a pain. Amazon, you have one language in which you can set up your device, and our Amazon device is set to English. One reason is that my daughter cannot control it completely, but unfortunately she already realized how to say the things she wants to say in English to the device. And so asking anything that contains word from a different language is absolute no-go. I mean, this is just speech recognition, does not work. But if you ask something like, who wrote Die Unendliche Geschichte? Die Unendliche Geschichte is a novel written in German. The original title is in German. That is a disaster. And it's quite common with all the others. Google has a slight improvement on this. In Google, you can at least set up 2 different languages that are recognized. So I have set it up in ours that is recognizes English and Japanese. And that works quite nice. So you can either speak in Japanese or in English. Mixing the languages again in the same sentence or something, this is still quite hard, understandably, I have to say. So what's the status with FOSSASIA? In principle, we can switch languages on the fly. So you can tell SUSI switch to a different language. The problem is that we don't have enough language models for the speech recognition. The infrastructure is here. What we are missing are the language models to actually switching. So we hope with the switch to FOCT, if this works out, that we can at least support like 15 languages out of the box, because the models files are also really small. So that's the status with language support. An interesting question, because this is maybe after music, the only thing I also use sometimes, this is timers or alarms. Set an alarm for blah, blah, or whatever. So both Amazon and Google since quite recently, as far as I remember, or at least recently, deferred action quite recently, have excellent support. So you can have multiple timers, you can query, you can delete them, you can give them names, or in others, you just say at what time, which timer you want to delete. So that works quite nicely, and yeah, it's quite convenient for stuff. So that is probably after music the only thing I'm using. FOSSASIA has basic support. Unfortunately, deletion is by now not possible. The reason is quite simple. We still do not completely control the hot word detection and the speech recognition interaction. And that means we have a hard time doing dialogue support. That, like, you ask, hey, Susie, what are the timers or what alarms are running? It gives the answer, and then you can answer in this immediately onto this question. This is what's called dialogue. This is something we want to get. Just also in the last days, we have discussed with colleagues about that we just drop all of this stuff by switching to FOCT and write our own hot word detection, which would allow sets of words and no hot word at all, just really. Okay, then the big thing, why are these devices in our homes, right? Yeah, 70% are listening for music. And if you ask, quite a lot of people will tell you, those who have insight, that the devices are sold far below the actual price. And the reason is, well, they want you to get into music streaming subscriptions. That's quite obvious, right? So how it looks like, so Amazon has, I'm currently using the free plan. I don't have any subscription to Amazon, the Amazon Music. There is a special Amazon Music blah plan with I don't know how million songs. The music selection is, well, selective. It's okay, but yeah. With music playing, I think Alexa is really stupid. If you say AI or something, they're not even the 100th times you skip the same song. And if you ask to play whatever music songs from this group or this player, then you get as first the song you skipped all for previous time. So it's really dumb, unfortunately. But well, that is something, I don't know. Maybe that would be better if you have a subscription. I'm not sure they do this on purpose. I don't know. I haven't tried other music streaming service on the Amazon, so I don't know whether they work better. And they have no local music playback, so you have no way to use your own music. Local is or your own music, right? That's the other. Then for Google, I'm currently YouTube Music subscription. I have from long time ago a Google Play Music. Was recently force transferred to the YouTube Music. The music selection is okay. It's not bad. It's still not standard. So my favorites, singer-songwriter, normally are not existent. And it seems to remember songs I dislike a bit better than Alexa. Again, there's no local music playback, but you can at least upload your own music to YouTube Music or previous Google Play Music. That was good because I have a lot of music that is definitely not available on any streaming service, right? It's Japanese music that not even most Japanese ever have heard. So I'm quite happy to have this, yeah. But it's not integrated nicely anymore. And SUSE AI, well, we have local music playback via USB. You can plug in USB devices or on the computer, whatever. That is scanned. You can play from also artists, songs. You can prepare also playlists. So that's local music playbacks works. We don't have any intelligent search for local music, so just play some, I don't know, mixture of songs or so. That is something might be for the future interesting. And we have by now no integration with streaming service. I'm not sure even whether this would be easily possible. So before I go to SUSE AI, also my time is running out. So if you want a recommendation, I would say if you're a normal household like us, like mostly music and not doing, if you have a subscription somewhere, then use the respective device, right? So if you have if you don't have a subscription, but you want to upload your music library, go with Google, because that's the only place where you can do it. Otherwise, go with Amazon, because for me, the recognition is definitely much better. Well, but there's a big but. And I think, I mean, you know that why is it in the security and talk is, well, there is a problem with all these devices. Why is the recognition so good? Yeah. The point is that these devices are listening permanently to everything you say, everything what's going on. All these hot words and trigger words, they are only a fake. I mean, they're not a fake. Yeah? They are only here to start reacting to stuff that comes afterwards. But the devices are currently permanently listening and currently permanently transcribing. So all this kind of stuff ends up on a server at Google or at Amazon offices. And there have been quite a lot of issues with things that were not deleted, were translated, were used without permission, this kind of stuff. So this is, if you are somehow interested in your privacy at home, if you what people are talking, not sending to these devices, well, you have to do something. You cannot just trust them. And this is somehow our idea, what we are aiming at SUSE AI. Our aim is here to provide a privacy-aware system, something that works in the future, not by now, but we're on the way, in the same way as well, the big players here. So what is SUSE AI? So it's a personal smart assistant. It is privacy-aware. All the stuff will never be sent, if you want to, will never be sent to any server outside your device or your home or whatever you will set up. It has offline capabilities. So we want that this device works on the moon, on the Mars, wherever without any internet connection. We want to have a skill language. We want to make it easy for users to to develop their own skills. So support and new features. So that's currently quite difficult. And it should be an open source ecosystem, open source and open ecosystem. So we want contribution from everyone. So nothing closed here. Yeah, well, that's not important. Some community involvement. So we had several Google Summer of Code-ins. We have workshops at all kind of events, code hit contest, a lot of GitHub channels where we discuss. So what are the components? So there are basically 3 components to the SUSE AI system. There's the brain, it's the SUSE server, it's written in Java. Well, it's a server that's giving you the answers or doing the intelligent stuff. The point is you can deploy this server at home on your device, actually on the smart speaker, on this Raspberry. It is deployed on this Raspberry. Then there are front ends. We have front ends, as you said, for the smart speaker, for the device, but also for the mobile, for web, for desktop, for the archive, for all. And we have the skills, which is somehow a wiki style, where you can develop your own features, community development, to improve the abilities of SUSE AI. So the brain is, well, the SUSE server, it's an interpreter of the skill language, does a bit of NLP, reflection, introspection, user device management. The point is you can deploy it on your local computer in your house where you have only one, and this is the central SUSE server. It is deployed also on the web here, hsuse.ai. If you want to test it there, that's also possible. The skills are, like, as mentioned before, wiki-style editing. Tonight in the workshop, I will show a bit. So this is the skills page. You can search for different skills and look at them. So I'm running out of time, so I'm going a bit faster here. So this is a typical Android front end. There's a desktop where you can talk to the desktop application or just type your answers. There's a web application that works from SUSE AI. So what I want is privacy aware, because that's somehow important for me. So our aim is to have everything on the device. So speech to text is, we are using currently deep speech on the device. We hopefully will switch to FOSS in the future because it provides better support and better quality translation and faster and lighter models, all this kind. There are alternatives. If you want, you can use Google Bing Watson for your transcriptions, for your speech to text. That gives you much better recognition rates, but your stuff is sent there, like from Alexa. Text to speech, we use F-Lite. This is again on device. Again, you can use web services if you want. And API usage and all this kind of stuff, it depends. If you don't use, of course, if you query every second day, whatever, Wolfram, then, well, you query it. But it's your decision. It's not the decision of SUSE AI. Okay, I skip this here. So the smart speaker I was talking about here, this is this device. You have seen a few photos. So is Raspberry Pi based since Raspberry 2. Nowadays we use 4. It has the receipt head for microphone, a bit of 3D casing, and runs all the components. So the server, the Linux front, and the voice recognition, and the web front, and everything runs on this little device. And still there's enough space. And, well, also has timer functionality, something not so important. So what is the roadmap for our SUSE development? Of course, one SUSE AI per household. Yes?
No, but you have about 60 seconds.
Yes, thanks. It's fine. So SUSE AI per every household, that's somehow our aim. It's far away. So what we want is development device RPi, so that our Raspberry model is a bit better. Desktop integration, this is what we are currently working on. And so we have a desktop service, but we want to integrate it with the desktop. Skill management, that's a bit better, that gets better. Server mesh that you have, because you have the server on your smart speaker and maybe your home server, that you can make a mesh there. And the more steady development, because nowadays it is currently only when one of the developers has free time. So if you want to contact us here, so there are a lot of channels on GitHub. If you search the SUSE AI, everything with SUSE, you will find us there. You can email me here, and thanks for your attention. And we are open for questions. And I think perfectly 25 minutes.
That is 25 minutes. Unfortunately, that included time for questions. So
sorry.
Those. What I will suggest, I mean, like, as a privacy guy, yes, control is important. As a security guy, a deliberately open mic on a network-connected device, and where the device, by design, uploads snippets of what it hears, freaks me out. So I love the idea of this service being available in open source, where it's a device I own, it's in my house, and it's not connected to the internet.
Yes.
For those who would like to ask questions, and clearly there are, right? There's at least 3 or 4 questions in the public chat. Sorry, in the shared notes. What I'd suggest is the following. We do have a separate room called a discussion room. If you open the left bar up the top there, just between public chat and shared notes, there's a little gray rectangle with an arrow. Open that and scroll down. There's a video room called discussion. So I suggest, Norbert, if you want to go and hang there for a few minutes and the people that ask questions, you might want to go and visit there and put your questions to Norbert directly.
Yes, so there are quite a few in the shared notes. I have copied the shared note questions so that I can, and I will
yes.
and yeah. Well, so that I can ask them when I go to the discussion room. Okay.
And
so
thanks, Norbert.
Thanks a lot.
Italo, can you turn on your microphone and your microphone and camera, please?
I'm okay. Morning.
Good
or
morning.
good afternoon for people in Singapore.
And good evening for people somewhere.
Yeah.
This is our first ever, really quite a global conference, and it's an interesting experience. As for other speakers, what I'll do is start your intro on the half hour. It's about 3 minutes from now, and then ask you to invite you to present thereafter. Before that, let's sort out presentation materials. Are you presenting a slide deck that you want to upload? Are you presenting a video? Do you wish to do a screen share? What's your,
No, I will share my screen and talk over my slides.
Fantastic. Is there any video embedded?
No.
Excellent. Okay, that's perfectly fine. Let me give you the presenter right. So you should now be able to press the red circle with a plus on it. And, oh, no, beg your pardon. A button should have appeared at the bottom right, which is a screen share button.
You should see my slides now.
Aha. Very good. All right. That's brilliant.
Yeah.
Let's just now stand by for about 2 minutes. And
sure, no problem.
To present. By the way, can you remind me, please, how to pronounce your name? Is it Italo?
It's Italo.
Italo, thank you.
Yeah. But I'm used to be called Italo by English-speaking people and Italo by French-speaking ones. So I'm used to, I have 3 vowels, so the accent can go on any of the 3.
Land somewhere. Brilliant.
Yeah, exactly.
All right, well, hello everyone. Next up we have Italo Vignoli from the Document Foundation, of which he is in fact a founding member. He's the Chairman Emeritus of the Associazione Libertalia, I've got that wrong, Libertalia.
Associazione Libertalia.
Thank you very much. An open source initiative board member and co-chair of the ODF Advocacy Oasis Open Project. He co-leads LibreOffice marketing, PR and market relations, co-chairs the certification program, and is a spokesman for the project. Italo, take it away.
Thank you. Again, thanks for being here at this time for Europe. It's rather early, and would like to be in Singapore again. Hopefully in the future this will happen. So talking about free open source software and open standards for digital sovereignty. What is digital sovereignty? Basically, is our right of decide about the content that we develop and share and own. The problem, unfortunately, is that with cloud platform, the threshold between what we do and we share has become very, very thin. And in some cases, we are sharing contents even if we are not aware that we are sharing them, and we share, the risk is that we share private data. There are companies, and the GAFAM is the way that they are recognized at the moment. There are other companies in Asia growing and with the same attitude. The issue of this company is that they own our data, and if we are not aware when we share the stuff, they can own almost everything we do, and they control almost everything we do. I have data for Europe on the next slide, but I think that this data can apply to every continent. So I have data for Europe because I'm based in Europe. So these companies are spending a lot of money in lobby, and they're focused on maybe on different areas, like for instance, Google and Facebook was more on copyright law. But the fact is that when there are meetings with politicians in Europe, they cover corporate interest more than they cover the civil society. So we citizens, and when I say citizen, I'm a citizen of the world, I'm a citizen of Europe, I'm a citizen of Italy, and each one of us is a citizen of a continent, of a state, and of course of the global community. And this is worrying. This is worrying because it shows that the interest that politicians that are elected by the civil society, by people, the reality is that they are more after corporate interest than civil society interest. And this reflects, unfortunately, in areas where this shouldn't happen at all. For instance, the human genes have been renamed because Excel was not able to handle them. This is just incredible. Microsoft refused to solve the bug, and therefore the scientific society had to change the name of human genes because Microsoft didn't want to change them, the software. So we are subservient to Microsoft. This is incredibly bad for humanity. The company decides even the names of our personal human genes. And this is something that I find totally wrong in general. Which is the situation of digital sovereignty in Europe? You are free to help me in understanding more about the digital sovereignty in your countries for Asia, for Asian citizens. So the problem is that the concern about companies, American technology companies deciding for European policy is increasing. And the problem is that, unfortunately, politicians are not aware that technology, and especially free open source software and open standards, can solve this issue. And they look in a different area. They look at raising fines to these companies, but not changing the law or the approach. So just by mandating free open source software and open standards, they would probably solve 90% of digital sovereignty issues. And unfortunately, because of what happens with the lobby or the influence that companies have on politicians, this is not happening. So the current situation is basically that we produce the data and companies own these data, control these data. We should be able to control what we want to share, what we share, when we share it, and how we share it. And this at the moment is extremely difficult. Yes, there are platforms like Nextcloud, where we have a better control of the data we put on these platforms. But the unfortunate reality is that the majority of users that are not technology savvy are trusting platforms that shouldn't be trusted at all, like Office 365 and the Microsoft Cloud, the Google applications, and in some cases, the Amazon cloud as well. This is something that needs a lot of education with politicians, because the situation at the moment doesn't seem to be heading to any positive outlook. So the proprietary software protects the user by obfuscating everything, while free software protects the user with transparency. So we know that we should really avoid, and we should educate people to avoid using proprietary software for desktop productivity and for the storage of their data, because this doesn't allow them to use to own the freedom of their data. And there is a recent sentence by the Court of Justice in Europe that says that in Europe the US cloud platform shouldn't be used, but the reality is that no one in public administration knows that sentence. And so the SEC means standard contractual clauses. And the problem is that the reassessing these contract clauses has a very high cost, and this is what the company leverage. They say to go back or to reach a point where you control everything, you would have to stand a huge cost. The value is that with the free open source software, we would control our data, the citizen data. We could manage them according to the level of confidentiality, and we would gain a lot in having a better interoperability. Seems a no-brainer, but the reality is that politicians are following the wrong path, because they follow the companies instead of following the citizens that have elected them. There is also an additional issue which is related to the weakness, the security weaknesses of proprietary software, and especially of proprietary document format. If we look at the FOSS vulnerability, so free open source vulnerability, as you see, the fixes are coming quickly. For some proprietary software, fixes are not coming even after 40 years or even more. The leap year bug in Excel is almost 50 years old. And there's no intention by Microsoft of solving that bug that makes Excel incompatible with the Gregorian calendar. Seems an incredible thing to say, but this is the reality. every date in an Excel file, and of course every date in an Excel file produced by a free open source software like LibreOffice has to include an error, because Excel as an error is not able to handle data in the correct way. And this is, again, is incredible. Because of this, the complexity of the files and the vulnerabilities that are inside, the majority of the document used for malware attacks is our proprietary format. You can see this was a Symantec research in 2011, and the situation is even worse in 2018. This is Kaspersky Lab in end of 2018. 70% of all malware attacks were done by using Office documents as a carrier of the attack. And there is a Free Software Foundation Europe project, which should all support, is that if we use public money, we should have public code. So the software used by public administration should be public and should be then open source. How can we re-enable these data commons? How can we decide whom and how to share our contents? The answer is in standards. Lego is not a free standard, of course, is not an open standard, of course, but gives you the idea of interoperability. I was playing with Lego bricks 60 years ago, and today my nephew can work with the same bricks because the interoperability of this brick has not changed over 60 years. And this is what happens if we are using open source software. This is what happens when we are using open standards. We discovered the importance of open standards when HTML was created, and luckily it was protected from the attack of companies like Microsoft that try to make HTML proprietary. Everyone probably remembers, or the younger people remember, what happened with Internet Explorer 6 that was handling a completely different HTML from the standard. But the fact that there was a W3C behind the standard, this was protected, and this should happen also with the document format. So the documents are one of the most important objects that move around from citizens to government to citizen, and also between government, citizen, companies, and so on. So the problem is that when the documents are governed by a pseudo standard, you don't control these documents, and you are locked into a platform, or you are locked into clones of that platform, which means that at the end of the company that decides is always the same, is always one. So government should decide for being platform independent, and because pseudo standards can be tweaked in a way that is not visible to the users. So there is an open document format which is neutral, independent, and perennial, because it has been developed and built by thinking at the user. So ODF is solid, is consistent. If you use ODF on a Linux machine, on a Windows machine, or on a Macintosh, the result is always the same, which means that you can exchange a file without having any issue. While, if, for instance, if you use Microsoft Office, the format of the file, what the user doesn't see, but the reality is completely different. And in some cases, they don't even support the same version of the files. So at the end, what happens is that to have interoperability, if you are using Microsoft Office format, you default to the lowest to the lower level, which is exactly what Microsoft wants. Microsoft wants to go back to their proprietary, completely proprietary and obscure format. So a digital document can be used by those who have access to the decoder. So if the software is open source and the standard is open, then you have access, everyone has access to the decoder. This is what happens. You have different software who support the same format. With Office OpenXML, even in 2020, the default is the transitional and proprietary document format. It is actually proprietary according to ISO, although Microsoft plays on the fact that the same document is describing the proprietary standard and the open standard. The open standard is called Office OpenXML Strict, but if you look at Office, is the last option is the last provided option if you choose Save As, is not close to the proprietary Save As option. So what it means is 100% of all the Office OpenXML files, so docx, XLSX, and PPTX files we are referring are proprietary. In addition, the support is not uniform, and although the promise of Microsoft was that this would have been standard since 2010, we are in 2021, the situation has not changed. So the ODF philosophy was to design a vendor-neutral format, while Microsoft designed a format that was good for their software, but not for the users. So the difference is that ODF was designed for the next 20 to 50 years, and while the Microsoft format was designed to propagate the last 20 to 50 years in today's document, and this to the detriment of users and interoperability. And of course, XML brings a lot of advantages, but the problem is that although Microsoft claims to be the largest software company in the world, it looks like they don't know XML. And they have an XML which is terribly bad, even to the eyes of someone that has no high technical skills like myself. So ODF naming is based on the XML. ODF files are human readable. Office OpenXML files are not human readable. Actually, they are human obfuscated. And I challenge any one of you to recover a broken Microsoft file from the underlying OpenXML while recovering a broken ODF file, which, by the way, having a broken ODF file is really a challenge. They never break. You can recover the content in a matter of minutes. So the naive deduction of all of this is that all LibreOffice developers are geniuses and all Microsoft Office developers are just idiots. But the reality is that Microsoft is just protecting a $25 billion market by obfuscating the contents and preventing the digital sovereignty of users. We are for simplicity, so the document have to be simple, human readable, because the less things are visible, the more are given for granted, and when you give a lot for granted, actually you are giving to the company the control of what you're doing. I have finished. Thank you for listening. I hope it was clear. If it was not clear, you're free to ask me any kind of question.
That was excellent. Thank you, Nicola. We do have a few minutes for questions. So, and in fact, we have some questions, which is excellent. The first is, are you in discussion with Microsoft to support the open formats from LibreOffice in their Office suite? Microsoft is a supporter of many open source projects. So this is sort of different to asking the same question 10 years ago, right? They now own GitHub. What do you think? Is there
they claim they support ODF, but they are very smart. Microsoft is the company in the world that employs more lawyers, and they really squeeze very good content out of those lawyers. So what happens? They support ODF, but there is a clause. I don't want to go into technical details, but there is a clause, there is a call which is incompatible, is an XML call. So is a manifest that is incompatible with the way that Office is developed. So because of this tiny clause, they default back to a non-standard version of ODF. So they say, yeah, we support ODF, fantastic, we are compatible. But then unfortunately, there is that manifest that we are not compatible. We should rewrite everything to be compatible or give up our lousy format to be compatible. And unfortunately, we cannot write ODF in a proper way. Sorry, but this is a fault of XML. It's not a fault of Microsoft. And here came the 48 lawyers.
I recall in the 70s and 80s that IBM employed more lawyers than anybody else.
No, now it's Microsoft, but
it's like the same evolution.
Yeah, it's a returning issue.
So, well, I get. I might ask you to address just one more question, which was the support for Asian typography, and in particular interoperability with Microsoft documents with Japanese content is rather bad, to be polite. Is there any activity with respect to better support of Asian typography and interoperability? Before you answer it, Raymond, can you please turn on your camera and microphone, and I'll give you the presenter right. Go ahead.
So we are working to improve that, but let's say that the answer, that the question, it's totally understandable from a user. So the problem is that to support Asian typography, Microsoft is using binary contents. It's not using XML. So the problem is that all the files that Microsoft is writing and supporting the right to left writing and up to down writing are totally binary blobs. So what you can do is either you clone, which is something that, for instance, WPS Office, which is developed in China, is doing, or you reverse engineer, which is not the ideal solution. So the problem is that we because we stick to the standards. We create our Japanese files are XML based, although this asks for a lot of effort by developers, but we stick to the standard. The problem is that when you open one of the files from Microsoft Office, you are really opening something that is completely obscure. It's like you are reading into a piece of paper which is obscurated behind dark glass, and you try to guess what is around the paper, but that is what you can do. Is actually we are working with the Taiwanese government.
I think we should wrap at this point.
Sure.
I appreciate this is going to be complicated, and what I was expecting was, yes, a further example of not quite supporting the open spec, which is more or less as expected. Thank you very much.
I can go to the other room if people want to ask me questions.
I was going to encourage that exact thing, because there's at least one more question there. So if you'd like to go and spend at least a couple of minutes in the discussion room, and the others who had questions to follow, please do likewise. In the meantime, Raymond, could you please? Thank you, Italo. Raymond, could you please turn on your camera and mic? Okay. Now, hi, Raymond. How are you doing?
Hey, good. All right.
We'll start in a few minutes, but need to sort out your presentation material first. Are you using slides? Are you using a video?
Let me just start sharing my screen. How does this work? All right, seeing my screen?
That's brilliant. Is there video in what you're sharing?
Sorry?
Is there video in what you are sharing?
No, there's no video, so we are good.
That's okay. We've been having real trouble with video through screen share.
Oh, no worries.
Okay, in that case, please stand by for about 2 minutes. I will then introduce you and invite you to give your presentation. I would remind you it will be for 40 minutes, including Q&A. All right. Hello, everybody, and welcome back. So our next speaker, in fact, works for Singapore's government technology body, GovTech. His name is Raymond Ye. He is a software engineer who is passionate in privacy-enhancing technologies. He's worked on various projects, like the first nationwide digital education credential, OpenCerts, the nationwide goods distribution app, Supply Ally, and the framework for transferable records on the blockchain, Trade Trust. He currently holds fellowship positions at Radical Exchange and SUSS.
Yes.
He's an expert on UN CFACT working groups. He is currently invested in a zero-knowledge proof-powered infrastructure for anonymous goods distribution. He also writes at geek.sg on various subjects ranging from product management, decentralized technologies, and finance. Raymond, please go ahead.
All right, hi everyone. Really great to be here. So today's topic is a lot on not just zero knowledge proof, but how can we apply zero knowledge proof to identity infrastructure. So it's a glimpse into the future of how identity infrastructure could look like, right? So just a quick introduction. So I think we have already covered this. I'm an author at this blog, a software developer, fellow at this Radical Exchange, where I actually present this idea as well. So a lot of this research on zero knowledge proof in identity infrastructure can be found in the literatures with Radical Exchange as well. So beside that, these are some of the interests that I have, and I write on these subjects from time to time. So today's agenda is 25 minutes, all split into 5 minutes block, right? 5 minutes into introduction, building apps, this specific gadget called Semaphore, the use case of it, and then an implementation of a demo that uses this gadget called Semaphore. Followed by that, we will have 15 minutes of Q&A. So without further ado, this is the start of it. I understand that some of us might not know zero knowledge proof, and we just think of like zero knowledge proof as things like blockchain, crypto, and that sort of things. So I hope that this introduction actually gets to clear your understanding of what zero knowledge proof is. Right. So this is a classic example. We are looking at two persons P and V. P as in Peggy, the prover, right? V as in Victor, the verifier. Right. So this is a story of a cave. Right. So this cave has two tunnels, tunnel A and path A and path B. All right, and then in between the path there is actually a magic door where if you say a secret phrase, the magic door actually opens and gets you across from A to B and B to A. All right, so this is what happened. Peggy wants to prove to Victor that Peggy actually knows the secret phrase. So what can Peggy do is that Peggy could tell Victor the secret phrase, but then Victor will now have access to the magic door, right? So this is what zero knowledge proof try to solve, right? I want try to prove to you that I know something, but I don't really want to tell you what is, right? It's not like in math class where you say, okay, I know the answer to 5 + 5, and then you'd say that the answer is 10, right? Very often in the case of zero knowledge proof, the person who requires your proof may not even know the answer itself, right? So in this case, Peggy could go into the tunnel and then she secretly goes into path A or path B, right? And then Victor will come by and then stands at the entrance of the tunnel and shout into both the path and say, all right, Peggy, if you know the secret phrase, I would like you to exit from path B, right? So if Peggy was at path A, right? Let's say she's here, right? She could say the secret phrase and then get through the magic door and then exit from path B so that Victor could see that Peggy exited from path B, right? But then if we only run this experiment once, we only know that Peggy would have 50% chance of getting it right, right? So in zero knowledge proof, we are kind of like repeating this experiment multiple times, right? She could get it right the first time, but if we were to repeat 10 times, she got to be really, really lucky to get that right. Right, so this is a brief example of how zero knowledge proof are like, because when we prove something, it's kind of like probabilistic, right? But at the same time, it constructs as the argument of knowledge rather than the proof of knowledge, right? So very often when we talk about zero knowledge proof, we are actually talking about this thing called ZK snark, right? It's one of the more popular types of zero knowledge proof. So what it stands for, right? ZK stands for zero knowledge, right? In which a statement does not reveal information beyond the validity of the statement itself, right? And then my proof are actually small and verified quickly, even for very, very, very huge programs that requires a lot of constraints to be held. It is also non-interactive. So in this case, between Peggy and Victor, right? Peggy only needs to send a single message to Victor, and then Victor will be able to validate the proof. That means there's no exchange of information between Peggy and Victor, right? And then it is finally an argument of knowledge. There's a slight difference between the proof of knowledge versus the argument of knowledge. So in this case, we are arguing that we know something, right? So in this case, when we repeat the experiment of the cave thing, right, where Peggy kind of exit through the magic door or don't exit through the magic door and walks out anyway, right? Multiple times, it is only an argument that she knows that she knows the secret, right? She could be just real lucky. All right. So now that we know, a brief overview of what zero knowledge proof is, let's look at how we can build apps with zero knowledge proof. Right? If you want to summarize that, we talk about constraints, right? It's used to exercise constraints. So when we talk about zero knowledge proof, right, we are going to think about building what you can know as circuits, right? Just like in physics class, you have light bulbs and input output circuit and all NAND gates, that sort of things, right? So in zero knowledge proof, we actually make use of circuits, right, in which we have some private inputs that we refuse to share. And then there are some public inputs that we would like to share, because if you don't share these public inputs, right, you are not able to get the shared context. And then there is a black box where it represents a function, and then there's an output. So let's say, let's apply a simple use case to this, right? Can we design an identity card, right, an ID card, to prove that one is above a certain age without revealing the actual age? So in this case, in Singapore, we are talking about 18 years old to enter a bar, right? And I don't want to show whether I'm 18 or I'm 25 or I'm like a 200-year-old demon, right? All I wanted to do is to enter the bar without telling people my age, right? Assuming that people can't figure it out through my looks, right? So a circuit could look like that, right? So the public input is that we want to reference something that is known. In this case, it's in the year of 2021, and then my legal age is 18. So I take 2021 minus 18, and that's 2003, right? So I'm comparing my private input, in which is my birth year, right? Say 2000. And if it is bigger than 2003, or less than 2003, my output will actually be true, right? So this will allow me to keep my input private, and then with the public input, the bouncer can actually verify, oh, I'm actually verifying against 203. And if this circuit gives you an output of true, I can admit this guy. But then there's a big flaw in this circuit, in which it actually tests only the knowledge of an age that is legal to buy alcohol in Singapore, right? That I know that the right input is 2000. It doesn't tie the fact that I am born in the year 2000, all right? So how can we improve this, right? This is a lot more complex, right? Because if you think about age, who can attest to that? That is your government. Your government issue your birth cert, your identity card. So you need something that is published by the government, right? And let's say this government had a big list of, let's say, hashes, right? And this hash is a function of, let's say, my birth year, as well as a secret that is only known by me, right? So someone else will not be able to know this secret, right? So in this case, my private input will then be my birth year, as well as this secret that is only known by myself, right? While at the let's say at the bouncer at the bar, right, he can verify that I'm testing against the year 2003, and that the public input is actually by the government, and it is a function of these two things. And while I may not know what is the input of the function, if this whole thing validates to be true, then I am certain that this guy knows the secret that is supposedly only known to him, right? Proving that he is a citizen of Singapore, and then his age is above 18. So you can see, like, this is how you can use a zero knowledge proof circuit to build an application, all right? So with that, we will go into one of the gadgets of a gadget is like kind of like a circuit. In circuit, we may not always want to know into the black box. because like there's a lot of wires and a lot of constraints, that sort of things, right? So semaphore is one of this gadgets in which it is already a circuit that is built into it, right? If you like to look into what semaphore really is, here's the link, right? And just by the way, if you like access to this, like the URL is here, right? So what is semaphore? Semaphore is actually this thing, right? It's a zero-knowledge gadget that allows a user to prove their membership of a set that previously joined without revealing original identity, right? That user can prove the membership of a set. Users can actually sign endorsement of an arbitrary string, right? That means I can say that I support a certain string like Raymond is great, right? And there's a mechanism to prevent double signaling or double spending. Then, so why is this gadget important, right? So let's put it into action, right? Let's say we have a group of people. We call them, let's say, US citizens, right? In this group of people of US citizens, we have 3 users, user 1, 2, and 3, right? And right now we are in the year 2000, and then the big thing in 2000 is US elections, right? So we can use this gadget for something like an election. Why? Because now I can generate this message that says that I am voting for Donald Trump. So this is the support for a message, right? It could be generated by user 1, right? And then he wants to vote for Donald Trump. Now, what this semaphore circuit allows us to do is that, number 1, right? It does not. It allows only the people within this group to generate this topic. So in this case, someone who is user 4, let's say a citizen of Singapore, will not be able to generate a valid vote, right, for Donald Trump. The second thing is that the identity of the users are actually being hidden, right? In the sense that we know definitely that this thing comes from one of these 3 users, but we don't actually know which of the users are they, all right? The third constraint that it upholds is that given a user and a topic, they can only generate one valid message of such, right? That means to say, right, like any other vote, user 1 cannot vote for Donald Trump twice, right? He can only vote for it once, right? Or not at all, right? He can choose not to generate such message and publish it. So how is it being achieved, right? Internally, the state of semaphore actually makes use of this thing called identity commitment tree, right? Basically, in the case of like user 1, 2, 3, right, we actually put them up into a tree. And when we are generating the proof, right, we are generating that user 1 exists within the set. And then there's this thing called a nullifier map. Basically, it is a list of just identifiers of unique vouchers like that, right? So every user topic pair, right, will result in a unique nullifier. So the circuit goes like that, right? So it's largely simplified. So basically, I have a lot of things like, let's say, the hash of the message. This is like, I support Donald Trump. And then like there's the external nullifier, which that is the topic. In this case, it's US election 2020. And then there is the thing like the Merkle root of the the tree for the identity commitment, and then like the nullifier hash, which is the unique number that is a function of like the user ID as well as the topic, right? And then there's the secret signals of all the secret things that people don't want to share. So the circuit checks for a few things like whether the identity commitment is correct. That means this is a function of one another. Whether the identity commitment is within the identity commitment tree. In simple speak, I am a US citizen. Nullifier hash integrity to check whether this number here is actually a unique function of like the user as well as the topic, and then the whether this person has a secret key to actually to actually sign on this message. So that's for the authorizations of it. All right. If you like more information on this, there is actually additional reading materials towards the end, right? But this is just a very quick and brief example of what is going on in the internals of a zero knowledge proof applications, right? You are not expected to be a master at it. So now that you know that there's such gadget, right? You've seen this, right? Let's look at what are some of the use case of this semaphore, right? Voting is one, we've seen it, right? So one of it is that, let's say, a government could say that I'm not really round up, but I have a list of people who are under financial assistance, right? And then basically, I can put them in a group. Now, these people could be eligible for, let's say, food distributions, right? There are several NGOs that distribute food, every day, right? And what this allows you to do is to coordinate the efforts between different organizations, right? Remember that given a user and a topic, I cannot generate more than one of this message. So what this means is that someone who is impoverished, who is food insecure, could actually approach one of these organizations and generate a message in exchange for, let's say, a packed lunch, right? And then it prevents them from going to another organizations and generating a similar message but for another organization, right? So basically, we are able to share information across many different NGOs using the identity infrastructure from the government, right? But actually, you notice that the government is not really sharing information or identifiable information to any of these NGOs, right? So I cannot discriminate any of these users, even though like my identity infrastructure is actually public, right? So similarly, let's say we open up the identity group to as huge as the nation, right? So we have like this group of people who are in this group called Singapore citizens, a couple of millions of people in there, right? So what this allows you to do is that you can do things like, okay, I distribute like surgical masks, right? So Singapore has been distributing surgical masks, and at first it was just the government doing it, and then there is another entity like Temasek that is actually doing it. But one thing to note is that Temasek isn't really a government entity, so it doesn't make sense for government to actually share an updated registry list of all the valid citizens to a private entity altogether, right? So in this case, it makes sense for, say, the government create such infrastructure, and then a private entity like Temasek can actually make use of this to make sure that a citizen is definitely a Singapore citizen. He does not collect the mask twice, given a single distribution, and then you can have several annotation to determine like which vending machine or which location is distributing this mask. So similarly, using the same infrastructure that is open, right, I can use it to prevent fraud. So let's say there's a peer-to-peer marketplace in Singapore that's called Carousel, right? Typically, we are using like things like a national digital identity infrastructure to authenticate like my national identifier and tie it to my username in Carousel. But then this actually leaks out the information of like my personal identifiable information to a private entity. Instead, if you were to use this infrastructure, you can make sure that number one, only Singapore citizens can get an account on this platform, and number two, you can only get one account. And the third thing is very cool. If I ban your account, you'll never be able to create it again. So this prevents fraud in the long time, right? Because we are able to eliminate fraud each time and take out all these fraudsters. Now, similarly, we can use it for voting within a company. So we can like internally best dress, best manager, and then we can put who we wanted to vote for. Similarly, for whistleblowing, right? We can say that, okay, I've seen some super shady stuff within my company, and I would like to whistleblow anonymously. But the problem right now with current platform is that the user does not have proof that the company is unable to trace back to who the whistleblowing like messages come from. And if they do, it is fully anonymous, and someone else who is outside the company could actually submit something like that, right? Similarly, we can use it for membership cards benefits, right? One typical example I like to use is app. We have this credit card for miles, right? But then every time we bring it to the lounge access, right, they also know that, oh, we have all this information about you. You are, Raymond Ye, and then whatever not. That sort of things, right? You are revealing more information than you should when you go for a lounge access. And this is not just for airport lounge, but also for like other partners. So in this case, I can use this to generate a lounge access pass without sharing more information that I am a Air Miles credit card holder, and of course that's with the bank, right? And maybe I can use this credit, like which lounge should the bank be paying like money to. Similarly, I can use it for student benefits, right? Right now I can, there's things like GitHub student developer packs, but then like if you have multiple email address or God knows what, you can claim it multiple times. But then if let's say my university generates like this identity group, I can actually prove to people that I am part of this like university, and I can at most claim the benefits once, right? And this GitHub does not need to have access to like does not need to request for explicit access to this identity group by NUS, because they don't reveal more information about who the individuals are, right? So now that you have seen a lot of things from a very theoretical point of view, right? I'd like to show you example of proof of concept that I've been working on in Radical Exchange, right? Just to prove to you like how this can work, right? So the application that I built is called View OS, View as in hidden, right? And OS as in operating systems. All right, so in this case, I have two screens on the left and right. The left screen is actually the operator. So in this case, let's say we represent a food distribution application. So in this case, remember we said we need to put a few parameters. Number one is the identity group. So this identity group has already been provisioned, right? There's like 100 people inside, and then we need to use a topic. So in this case, let's say we are doing food distribution, and today's date is let's say 18, right? 18 of March 2021, and let's say this is Raymond Private Limited, right? That is giving out this food. Okay, so there you have, right? Anyone can make use of any identity infrastructure, any identity group that is public, and in this case, it is a public identity group, right? So let's just imagine these are as people who are food insecure, right? So this one could be placed on the counter of like, let's say the McDonald's cashier's counter, where people can actually scan this code. So on the other end, we have the beneficiary. These are the people who are in need of the food, who are food insecure. So they have an identity card that is already registered with the government agency that is maintaining this registry, right? And all they need to do is like click on Access app and then like turn on the camera, and then that's me, and then basically scan the QR code from the other side. Right, so as you can see, basically the same information is just being populated, and then I can click on confirm, right? So this is the stage where we are using zero knowledge proof to generate a proof of receipt to show that first I am part of the identity group, and that I have not generated such voucher before, and that I am authorized to actually sign on this message. So remember that it takes a while for zero knowledge proof to be generated. So it's generated, and demo God had mercy on me. This is the voucher, right? So from the perspective of the person who is running, let's say the soup kitchen, right? I can see, hey, okay, I have this icon and you have this icon. Okay, you just generated a claim right in front of me. Here's your packed food for the day. There you go, right? So next thing we want to see is that what's inside the voucher, right? This is everything that is inside the voucher, right? It shows that, okay, there's the topic, which is food distribution, which is today. All right, and then there are the proof. So as you can see in the proof, it's all just mathematical points, points on curve and so on and so forth. And then there is nothing else, right? There's nothing else that is revealing my identity. So my identity actually starts with 182. This is the one that I register with the government, right? It's not in here. So in this way, I cannot I cannot say generate the voucher twice, right? So I'm going to share an example, and then we will quickly jump to Q&A. So very quickly, let's try, to cheat the system, right? Let's say I'm already done with here, and then like I want to go KFC and then get fried chicken too, right? So this is what it will look like. I will be able to, fetch all the metadata, right? I'll be able to generate a claim, but then when I try to submit, you'll see that the server will be able to detect that this person has claimed before, although I don't know who is this person, right? But I'm rejecting it. So there you go, it's just submitting, and then you'll see an error shortly. So you cannot resubmit claim under the same topic, but then I can resubmit it again tomorrow, right? So if let's say tomorrow come by, there you go, tomorrow come by, and then like it's for 19th of March, blah, blah, right? Yep, then I will be able to generate for tomorrow's food, right? And that is if they are distributing for tomorrow, then they will be able to see like the voucher being submitted. All right. Let me just show that, if I go on to tomorrow, then I will be able to see like the list. So I'm just going to cut 5 minutes into like the Q&A just to show some other things, right? There you go. You can see that it's successfully generated. So I'm just going to head back to one of the dates previously, right? Now, what this thing allows you to do.
Raymond, just for clarity, you have 18 minutes, including Q&A.
Yeah.
Okay.
Right. So very quickly now, what this thing allows you to do is that these organizations are able to use these vouchers as proof as well, because you know that they cannot generate this voucher themselves, right? So now they are able to bring these vouchers to donors, to let's say government for tax relief, right? And the governments and the donors can actually trust these organizations that they did not cheat on the numbers of food that they have distributed as well. So it actually gives rise to a lot of ways that you can play around with things, right? Actually, that is my last slide, and we are right now heading to Q&A. All right. Oops.
Fantastic, thank you. That's an elegant and concise description of application of zero-knowledge proofs to actual problems. I have lots of questions, but I am pleased to say there are several questions that have already been asked. So let's start there. The first is how to handle zero identity in places with bad internet connection. What are the solutions here?
All right, so it depends on what you are trying to prove each time. So in this case, this application requires you to do a check, right, with the registry that certain things has not happened before. And without access to this registry, you are not able to generate such, you are not able to perform this check, right? It is, however, possible that you are still able to do a set membership proof, right? That you are still able to prove that I am, say, a Singapore citizen, right? That I'm here to claim, let's say, a surgical mask, but I can't prove that I have not claimed this surgical mask before, right? So that's the drawback. Another thing is that, let's say, given that we have a national registry for, let's say, identity card for entering bar, right? I can still do the age check without internet connection, provided that there is something like a local route that is historical, that the bartender already had, the bar bouncer already had. So yeah, that's
so the difficulty is that it's the same basic problem as, say, blockchains. It's the double spend. The weakness is double spend protection, that you must have communication, which that makes sense. Second, interesting approach. Which open source systems are using this approach already, and how much can this be set up? How much can this be set up out of the box? This is Thomas.
Right. So I'm just going to share my screen again, because the next page is additional resources. Some of the things that you want to check out is number 1, semaphore. So this is the gadget that I'm talking about. Number 2, circom, IGAN3, right? So this is the circuit compiler for zero knowledge NUCs if you are building your own circuit. This is already this circuit that is built in. right? And if you are interested in like my application, I think I will add the link into like the source code for Velos right after. Yep.
Thank you. We have a question from Tingse, and I think I'll ask a connected question from myself at the same time. Tingse asks, are there immediate use cases that you foresee that this can be applied to? And my related question is id.gov.sg. Are you in communication with that group, and are they using a similar approach?
Okay. That's a lot of questions. So I'll answer the last one first. No, I'm not in what.gov.sg, but I'm doing this.
id.gov.sg.
RD, no.
ID.
id.gov.sg. No, I'm not part of them.
Okay.
We are part of GovTech, but we are not in the same team. No. The question before that, sorry.
Are there immediate use cases that you foresee that this can be applied to?
All right. So the very immediate one, I think food distribution is one of them, right? It's cool to be able to synchronize. Even more immediate is actually voting, right? There's actually no way that you can prove as a voter that your government does not know who you vote for. Never in history we are able to prove that. Because if we are authenticating ourselves as, let's say, a Singapore citizens using the traditional national identity gateway, we have already typed ourselves to that identity, and we cannot say vote for some person and then there's a proof way for me to prove that I'm not linked to the vote, right? But with this itself, I'm able to create an infrastructure that I don't even need that gateway. I can generate my votes offline and submit this to any relayer, and I can be certain that the government does not know who I vote for.
Where would the app come from in this case?
Oh, it could come from the government, but then it can still be verifiable when it's open source.
Right. Okay. That's an interesting application.
Yeah.
I fear electronic voting systems because of malware, but that's a good starting point. Next question from Michael. What happens when a big government-supported actor attacks the digital infrastructure of a country or of a large organization? What backups or incident response practices can be put in place?
What kind of incident response practices could they put in place? Is it?
Oh, sorry, the front half of the question was, what happens when a big government-supported actor, meaning presumably a foreign government, attacks the digital infrastructure of a country or a large organization?
Right. So in this case, this is, well, in theory, right? It's not going to be put into practice right away. But basically, it is the same as any infrastructure. You can still have all the protection that you need, right? On the part where I'm actually registering people for to be part of this list, right? And that this list can be a read-only endpoint somewhere. So it actually does not deviate from the standard practice of like I have kind of things like intranet and traditional storage of data within secure facilities, right? And then having read-only access to only certain parts of the program. So I don't see any problems with that. Yeah.
Nothing special about this. Okay, which is fair enough. Oh, beg your pardon, there wasn't a fifth one. Right. Are there any other questions from the audience? No? All right, I think I had at least one more. One moment. Oh, we've covered FOSSASIA. Yeah, okay, so that was mine too. That's brilliant. All right, last call for questions from the audience. We seem to have exhausted them. All right, well, thank you very much, Raymond.
Thank you.
Of how the bits fit together. Have a great day. Please turn off your camera. Okay, so I believe our next speaker, Francesco, stuck his nose in a little earlier, so I assume he's around. I will ask Francesco to set up in about 5 minutes, and we'll resume in about 10. Given that we have a vacant conference hall for a few minutes, are there any burning questions from the audience on issues other than zero knowledge proofs? Francesco, if you are still in the room, please unmute your microphone and turn on your camera. Francesco, are you around?
Hello, yes, I'm here.
Hello. Would you like to start your camera?
Sure. Here we are.
Brilliant. Hi there. So you're in about 4 minutes. Couple of things. One is scheduled for 15 minutes, including Q&A. So I'll be as tight as I can be to make sure you've got as much screen time as possible. Two, are you presenting with slides? Are you presenting a video?
No, no video, just slides. I have both available as Google Docs presentation or a PDF. Not sure which one fits better.
We're getting screen share is working pretty well. So you're perfectly welcome to do that. You should now have at the bottom right corner of your screen a button to perform a screen share. Maybe you can try that now.
Yes, I can see it. Okay. Can you see it?
It's loading. Brilliant. Okay, you're there. All right. Yeah. So please stand by for about 3 minutes. I will introduce you, and then I will invite you to speak.
Thank you very much.
Francesco, is your family name Chirico?
Yeah, I think it's okay if you pronounce it.
Tell me how you would pronounce it.
Chirico.
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 Yeah, strong C. Yeah.
Okay, everyone, welcome back. Our next speaker is Francesco Chirico. Hopefully I got it this time. He is the CEO of open source company Terrasa, which aims to speed up the development and adoption of Apache Syncope, which is itself an identity management system. He is, however, deeply involved in the Apache ecosystem, a member of the foundation and chair and participant in multiple Apache bodies. Received a master's in computer science in 2001, worked for Nokia for a bit, but about a decade ago, it appears, set up Terrasa. So with that, I'll hand over to you.
Thank you very much, Roland. Thanks for the introduction. So welcome, everyone. We'll try to spend a few words to report our experience in building open source identity infrastructures. Pretty much myself and the company we founded, I started working on this field with first commercial tools that were available and were the major reference until 10 years ago. Then something in the open source area started rolling even for identity and access management. And that's where Tiraso started entering into business. And we, as a company and personally, were involved in this process. So first of all, let's try to share some common vocabulary to be sure we talk about the same things and give the same name. So we'll be talking about identities. So an identity is what we know about a person, but this information is often split into several data records that are often known as accounts, because computer systems work with accounts. So each account knows a fraction of the total identity information, and when we talk instead about identity, we have to recollect and associate all these sparse information together. But this is possibly the most important concept to accept in this area. We're talking about digital identity. So we're talking about every one of us. Technically, we have two distinct practices and tools that are related to identities. One is identity management that is set to keep all the available data as much synchronized as possible, and has to do with different repositories, data formats, models, processes, workflows, and etc. Because it has to reconstruct an image of an identity out of the chaos that's normally living in our IT departments. From the other side, we have access management. Access management instead is a set of well-known systems, protocols, and technologies that are supporting user authentication and authorization, and is normally made of well-known protocols, very established implementations, and so far. These two techniques, these two approaches are very often complementary. So this is what we are going to show in the rest of this presentation. So from a high-level point of view, this is the problem we are attempting to solve. So we have, from one side, different technologies. From the other side, in the top of the slide, we have different actors. In the middle, in the center of the slide, we have very different ways to handle this complexity. When we try to apply our solutions, this is the target, the situation we want to achieve. We have a centralized IAM system, identity and access management systems, that is ruling them all, and more especially takes care of everything, all the aspects of the problem, including the fact that former employees are not allowed to interact with the system anymore. From a general point of view, this is our reference scenario. We have on the left side the supporting and technical users of our IAM platform, so that they could place their requirements from a business point of view, from a system administration point of view, from help desk. On the right side, we have final users, the ones that are accessing our platform through mobile, through websites, by using well-known and established protocols, are SAML, O2, or OpenID Connect. In the middle, we have our main components. So the access manager that is managing access, so authentication and authorization to our systems, to our applications, and the provisioning engine that it's trying, so the identity manager that is trying to keep some the data as much synchronized as possible across all the available identity stores, to let the applications be prepared to manage user access and to report when configured, to address privacy concerns, to address compliance, to make reporting, and so on and so forth. So this is the techniques and the definitions we have been presenting so far apply equally to commercial and open source IAM tools. So, but we're talking about open source, right? So let's see, let's report what happens when you try to sell your beautiful open source IAM tools to organizations, so to private company, large organization, public government agency, and so on. First of all, this is the golden rule. We are always applying to it. And because we had to learn it over the years, given the fact that there will always be a vendor that is more established, more strong, more present than you could ever be. And I've used IBM here, but possibly the most referenced company could have been Oracle here, or Sun Microsystems at the time I started working on this field. But this is very important. So the first objection you got every time you try to propose an open source IAM tooling to someone, a platform to someone, this is the very first objection, because who are you? This question is actually hiding a more important question, which is, who are you? How can you compare to IBM or to other vendors? From the other side, open source IAM has very much to offer, of course, not mentioning the price. No, the price could be hundreds of thousands of euros or dollars or whatever, far from a vendor proposal. But this is not the most important thing here, right? What we are talking about is the other advantages that open source IAM can offer. And most of all, the first and foremost one being the flexibility. Open source tools and IAM in particular are born to be flexible, to adapt in situations they were not initially thought for. So this means that especially for identity management that needs to be installed inside an organization and rule the data flows over there, this is extremely important. So flexibility. Second, vendor lock-in. Tirasa, my company, is a small company. So when you buy an open source IAM platform I'm proposing, you're not only buying Tirasa, you are buying the support of communities behind the open source projects we are referring to, and possibly even bigger companies that are behind it. So when I was starting selling things back 10 years ago, people said that they couldn't get fired because they bought Sun Microsystems, but then Sun Microsystems got acquired and their tools simply disappeared. So what's the advantage of lock-in? This is. Then security. I'm not debating here about open source security, which is a strong topic, but here for this area, for this domain especially, is much stronger. And involvement. There is no comparison on what a customer can feel involved in their while rolling their own IAM platform. They could be involved in the designing. They can be involved in the community that's behind the project itself. They can even contribute back to the community something that you as a company were mandated to develop on their behalf. So these are all things that are pretty much unique for this. What's our identity stack? So what's our reference? Is Apache Syncope for identity management, provisioning, and governance, and Aperiocast that would be the subject of the presentation right after this one, talking about authentication and authorization. So I'll spend just a few minutes here to present, to summarize a few cases of ours that we have as a company delivered to companies, to large organizations, or university for educational or healthcare organizations all around the world. So first one, this is in Italy, the same country as I live in, about the University of Florence. These are the numbers. We had to integrate the platform with a national authentication system that we call SPEED, based on SAML2. So all applications are now in single sign-on, and with this system, we are managing 150K users, which is quite a large number, not extremely big, but still considerable for a number of identities to manage. We provided them with a self-service application, responsive, working also for mobile, so that students can manage and self-manage their profiles, can open user requests, and so on. In this case, we've been also pulling and provisioning users from different data sources, databases, Active Directory, LDAP, and still with a set of rules and workflows that we have implemented. Second case is a cruise line in North America, where the challenge were of slight difference. We had cloud resources to provision, so Azure Active Directory, Google Suite, Workday. So we had to integrate with these pre-existing and cloud technologies. And a particular aspect of this project was the need to orchestrate the identity flows across shore and their different ships. So this is something that we're handling manually before, and we solved by using identity orchestration. Finally, we had to deal with several access management well-known standards as OpenID Connect and SAML2, and we also had the chance to use Google Auth for two-factor authentication. This deployment was one of the ones, besides the rest, for which we've been using Kubernetes self-hosted. Another case from North America, 400K users, which is quite a lot of users. What we built is essentially an entitlement manager that's provisioning and performing single sign-on with Okta. So instead of using, in this case, instead of using CAS for access management, we had to integrate with a pre-existing vendor solution like Okta. So we developed a connector that we also were allowed to release back to the community thanks to our customer. So now the community has an additional connector. And this deployment was part of a continuous deployment pipeline to GCP. But one important characteristic was the extreme customization. We had to apply here not only look and feel for UI, but we had to extend the data model, change the authorization pattern, and whatever. So the customer in this case had recognized our extreme flexibility regarding the deployment. So they were also keen to recognize that there could have not been any vendor tool capable of such a flexibility.
60 seconds. 60 seconds.
Thank you. So just finishing. So we have, this is another case of an Italian healthcare organization. You can read about the details, and thank you very much.
Okay, thank you, Francesco. I hadn't realized you were quite that close. We are right on time, but I'll certainly either allow or ask one question. Anyone in the audience wish to ask before I leap in with my own? Yeah, just more a comment to the question. That I've recently had reason to implement SAML2 as a service provider. So it's purely delegating single sign-on in our application to our customers' identity provision software, which is, as you would have guessed, IBM's. My comment is only that was surprisingly difficult, and certainly Apache stuff didn't come up at all when I went looking for open source solutions, which is, I think, a bit unfortunate. Is that have you spent any time on the service provider side of SAML2?
Oh, sure. The reason why you haven't found much on the Apache side for SAML2 at all, it's because there is actually not much in this area because we're talking about access management. No, so for this, our reference tool is Apereo CAS. which is widespread adopted, especially in North America and for higher education and institutions. And that takes some part of the shibboleth libraries to build up an independent service that could work even as service provider and an identity provider. So we have several deployments in place by using CAS integrated with Syncope to build up solutions like this. So
that's brilliant. I therefore look forward with particular interest to the next talk. On that, Ms. Aug, if you're in the room, please turn on your camera and microphone. And in the meantime, Francesco, thank you very much. Appreciate your help today.
Thank you, everyone.
Ms. Aug, are you in the room? Aha!
Good afternoon. Yes. Hello.
Let me give you the presenter right. So, are you using slides? Are you using a video? What are you presenting to us?
I am using slides. I think I can share my screen to use the media.
Screen share is working fine. The only problem we've had is people trying to do videos by screen share, which works poorly.
I understand.
For slides, you'll be fine. What I'll ask is, please just verify that that works.
Yes, absolutely. So here.
No, there should be a button down in the bottom right-hand corner.
Yep, it should be coming up shortly.
Okay, that's brilliant. Probably more of the decoration there than you want to show. Do you want to go into presenter mode? Hey, it's fine if you don't. It's up to you.
Yeah, I guess I could do that. Sure, why not? Let me actually just share the application. I think that's probably.
If that's an option, yes, sure.
Actually, it only shows the browser, so that's odd. Okay, never mind. We'll just do the entire screen, and somehow it doesn't pick the actual app. So here we go. And I think that's all I have. Yeah, whenever you're ready, we can kick it off.
Right now, we're looking at a very sort of there we go. Brilliant. All right.
There we go.
So let's stand by for about 2 minutes. I will then introduce you, and you'll then have. I've got a little bit of overshoot, about 15 minutes, including Q&A, but actually there's a little bit of room for overshoot there. So, but stand by for 2 minutes.
Sounds good. Thank you.
Am I pronouncing correctly, Mr. Myed?
That's perfect. Yeah, the easiest thing is to just ignore the GH in the end. So just Misa makes it very simple.
Mr. Myed. Okay.
Yes, sir. Are you out of Singapore, or are you somewhere else in Europe, or somewhere else?
I'm in Singapore, and yes, not in Europe.
Wow, excellent. So I understand it's 5 o'clock there. So I guess we're right on the hour.
Yes. Your schedule slot is 5 minutes after. I think we got a bit of schedule packing on this particular occasion.
Well, they always say it's 5 o'clock somewhere. I'm glad I actually witnessed it in the real.
I have failed to provision a suitable beverage for that. Maybe I should. All right, everybody. Well, welcome back. Next speaker is Misa Myed. He is an IAM consultant at Fornews Consulting. He has a primary focus on analysis, specification, and development of open source software solutions in the field of identity and access management. Specializes in dealing with identity management, federated authentication, provisioning, access management, single sign-on, etc. That whole, those who do IAM for a living, it's all that stuff. Been working as a software engineer since 2002, with open source since 2008. Excellent. And an active contributor and frequent committer to various IAM solutions, such as Apereo CAS, Pack4j, Apache Syncope, etc. Misa, please take it away.
Thank you, Roland, and greetings to everybody, and a special good afternoon to folks in Singapore. Thank you for having me. It's first time speaker at FOSSASIA, so I hope I shall not disappoint. And this is a presentation that sort of is an extension of what Francesco was describing in terms of identity and access management, and specifically focuses on the Apereo CAS software. And this is a technology whose core mission is to provide single sign-on for all Earthlings and beyond. And I've been told that the subtitle of the presentation can be somewhat controversial, given that it insinuates that if there's ever intelligent life found on other planets, they might have single sign-on needs, and whether or not the solution might be able to accommodate that. But I think it's safe to say we can ignore that topic for now and just focus on the core problem at hand. So following up on the lovely introduction from Roland, as was mentioned, my name is Misa Moyet. I am a open source developer, contributor, committer by day and by night, and I've been involved with open source for over a decade. And I primarily work in the open source identity and access management ecosystem, and I'm a member of the Apache Software Foundation, the Apereo Foundation, and generally deal with matters of authentication and authorization and access management and such. And so this is my profile information and my contact information if you ever needed to get in touch with me or somehow ask follow-up questions after the session is over. I'm happy to respond. And I feel like I should clarify, although video is on, that I am not the cat, I am the person in the picture here. So without further delay, since this is a 15-minute short and sweet presentation, I thought I'd begin rather simply by describing the landscape and the problem statement and the issues that single sign-on and authentication and such wish to address. And then I'll follow up with a candidate solution, which would be the Apereo CAS software, that I'll go into some brief introductions on what it is and what it does and how it can address said problems. And finally, certainly we'll talk a little bit about avenues for support and resources and ways you can get more information out of the system and from the project, and how it might effectively benefit you, and vice versa from your involvement and your participation. So to the problem at hand, what we generally see commonly on the web today, although it's more or less transitioning to a better experience, is a scenario called multi-sign-on. And this is a scenario where you have a selected number of applications. Each of these applications has its own sort of logging channel or strategy. They present some type of a different experience to the user and ask for credentials. And most commonly, these credentials that identify the end user are username and password. So in this multi-sign-on scenario, if you want to log into 3 applications, you have to actually present your credentials vis-a-vis username and password 3 times. And sometimes these usernames and passwords are the same. Sometimes they're in fact different. And it sort of implies that each application manages some sort of a user store, at least in this particular first pass scenario, where each application not only has access to the user's password, but they're managing the user's credentials, username, password, etc., differently, and they have control over that. So this is certainly less than ideal. You can imagine the proliferation of identities and management and various issues that might come up should an adversary compromise a given application and get to that account store and basically compromise user security in this scenario. Not to mention certainly that the user experience is different across each application. You not only force the user to interact differently with the application, but you might actually put them through different experiences that might be sort of not exactly welcome or consistent as compared to other applications. So this multi-sign-on scenario can be somewhat improved by saying that we still keep the individual log
inside what is called an identity provider. This is a system, a trusted sheriff, a trusted entity that is the only entity that can interact with the user to accept and validate credentials. It's generally the only entity that is connected to that centralized store to locate user records and verify said credentials. And finally, the identity provider, once having, after having confirmed the user's credentials, communicates the appropriate information and user attributes and user profiles and basically personally identifiable data back to the application through standard, well-recognized authentication protocols, channels, mechanisms, such as SAML2, OpenID Connect, CAS, etc. And so in this regard, not only the problem of multi-sign-on is largely addressed, but also we're extending the security and improving on it quite well, because we can then decide what each application might receive from this centralized user store, right? If first application does not need the user's last name or address or something, it doesn't make sense for the application to be able to reach out and grab that information. And the identity provider, the central identity provider here, is that trusted sheriff that decides who you are and what you can get out of the trusted user store. So that's the core mission and the core premise of having a single sign-on solution. A project in this space that begins to deliver on these promises is the Apereo CAS software. CAS is short for Central Authentication Service. And as you might have guessed, this is an identity provider that is that trusted sheriff that can interact with a variety of user stores and communicate and convey user profile information back to the client application using standard channels such as SAML2, OpenID Connect, etc., etc. CAS is a project that is under the tutelage and sponsorship of the Apereo Foundation, which is very similar to the Apache Software Foundation. Apereo more or less focuses on higher education, and CAS is a project that initially spun out of the higher education community in North America, but it has since then has graduated above and beyond education, is widely deployed all over the world. In fact, it's a very widely deployed solution. Certainly, we're in FOSSASIA, so CAS is a free and open source software solution. It's licensed under the Apache 2 license, and it has been in existence for quite some time, since 2003, which by many interpretations might be seen as legacy software. But I guess another way of looking at it is that it has been in production since 2003 and continues to grow and evolve on GitHub with a large number of contributors and developers, and generally lots of healthy activity around the project. So this is a very quick overview of what the system is able to offer, and I think is sort of also might address Roland's question from Francisco in the last session, and that is that the CAS software is a web application server. It's an identity provider, certainly as a server that is based on the Java stack. At this point, the requirement is Java 11. It's based on the Spring Boot sort of family of technologies. It supports a wide variety of authentication protocols, SAML2, OpenID Connect, etc. Has support for a large selection menu of user stores. This is where you keep the user accounts, LDAPs and databases, cloud systems, etc. And can also be a service provider or a proxy where you can basically hand off the authentication task to an external identity provider and allow CAS to basically interact with that identity provider via, again, SAML2, OpenID Connect, and with providers such as Facebook and Twitter and Yahoo and various other providers. Certainly, especially more important nowadays, there is support for a wide range of multi-factor authentication technologies, such as Google Authenticator and FIDO2 and other types of passwordless experiences, when you, touch a key fob or a USB stick or something, and you are sort of granted access to the application without really providing a password. That's the premise of a passwordless experience. And there are some additional, I guess, on the sideline, as it were, capabilities where users are given the ability, should they be using a password to do things, the system allows them to set up password management, I guess, workflows, and execute and enforce password policies as accounts begin to expire, or if they're forced to update their password, etc.
these types of things certainly are possible with the CAS solution. And as I say, there's a very large selection of things the system can do. It's been around for a very long time. It's impractical and unreasonable to go through all of them, so I won't bore you with all the nitty details, but I would recommend that you take a look at the link on the slide, which is the main website for the CAS project, and that would probably get you a lot more information in terms of what the system can do in the first place. So the deployment of the software is fairly simple. This is based on the Java stack. So you issue one command with curl in my example that says, I want to generate a CAS installation script that contains certain extensions or plugins or capabilities, if you like, that in this example would be ability to support OpenID Connect and SAML2. And I want my CAS solution to act as an OpenID Connect OP or a SAML2 IDP, etc. And so this script or this command should get you an installation script, which you can then build using the Gradle build tool. Again, remember that the CAS software is based on the JDK stack, and this one command down below allows one to build that installation script and generate a web application that can then be deployed and run anywhere in things like Apache Tomcat and Jetty and various other types of solutions like that. So to learn more information about what the system is and what it can do, I very much recommend that you take a look at the CAS website. This is the main reference for all things CAS, where you find release notes and resources to figure out how to get involved with the project and what the participation level might be, and basically wikis and how-tos and such. And certainly there are a number of other blogs that you might be interested to take a look at and peruse at your pleasure that describe, again, walkthroughs and tutorials and basically ramblings on of myself and various other folks in the community that describe how to do X with the CAS software, or they might just rant on about other things that would be of interest. So I very much recommend that you take a look at these links and certainly figure out if the software is a match for your institution, for your company, for your deployment. And if you wish to get involved with the project, these links would be an excellent resource for you to evaluate your participation level as you would with free and open source software. Finally, I want to draw your attention to the fact that much like many other open source projects, the development activity that happens with and around the CAS software is largely, almost exclusively, is based on volunteer effort. And so there are no contracts, commitments, employees, nothing like that. It's, as I say, it's very similar to the Apache Software Foundation. Apereo is the sponsoring foundation for CAS. And so if this is something that you think at the end is worth your while and you wish to deploy it and run it and have it up and running for some time, this link here on this slide and this tweet by the Apereo Foundation outlines some number of good reasons in terms of why you should begin to support the project more concretely, more, I guess, practically and financially, so that the development and its sustenance can live on for as long as possible. And I think I should be right on time. Thank you very much for the opportunity. And if there are any questions, I'm happy to answer, or later on hang out in the discussion chat room and figure out what needs to answer. Thank you.
I will suggest that the signal to noise ratio was in fact impressively high. Thank you very much. No questions seem to have appeared. Yeah, I think I perhaps didn't express my question clearly, because Apereo CAS is clearly the opposite end of what I was after. In SAML, the service provider role is the relying party. And so I need a library that can do exactly two things. Load the IDP's metadata and generate a redirect for my user, and load the IDP's metadata and the returned token and validate it. And I could not find anything that did just that. Everything wanted me to add a server, which is clearly ridiculous. It's just a library. Or it was a library solution that was built to do 10 other things. And of course, SAML was a poorly documented special case. It's like, well, okay. So
I know, I'm happy to expand on that a little bit. So the
at least in the SAML space, the two libraries, if you as an application developer owner directly wanted to interact with a SAML2 identity provider, at least in the Java space that I mainly exist in, there are two libraries that allow you to do so that I'm aware of. One is a project by Spring Security and the Spring suite of applications. This is called Spring Security SAML. And the other one is actually the one that I've sort of listed on my Twitter profile, which is Pack4j. And Pack4j is a library that allows interactions with a variety of identity providers, one of which would be SAML. So there is an extension module here called Pack4j SAML that does exactly what you described, loads the identity metadata and sends the request over to the IDP. And then when it gets something back from the IDP, it begins to validate it and passes that information back to the application out of that SAML2 response. So those are the two that I know of. And certainly CAS itself can be that if you wanted to. It could be a service provider as well as the identity provider. But if as an application you wanted to directly interact with the identity provider, you do need some sort of an SDK, which would be, at least in the Java ecosystem, would be either Pack4j or the Spring Security project.
Brilliant, thank you. Excellent. We do have a question, and we do have about 2 minutes, so I'll ask you to be brief. The question was, can you give some more examples and details where the solution has been implemented, and what were the challenges you faced? This question from Thomas.
Yeah, absolutely. So CAS is widely deployed in higher education communities. So almost, if you were to pick out 10 universities in North America, at least 8 of them have CAS deployed. So examples like Harvard and UC Berkeley and UC California Irvine and various other schools, as well as companies like, I remember at some point Air Malaysia had deployed CAS, or various gambling companies in the UK or publishing houses in the UK had deployed CAS. So you have small deployments from a college to a university where you have 60 to 100,000 types of accounts, all the way to the likes of a gambling company, a gaming company that has hundreds of thousands of users log in every time trying to basically win money. The challenge with open source SSO, I guess with open source access management generally is, if you recall my slide, is the consolidation of accounts. Because if you have this type of traditional legacy environment where you have 50 applications and every application has some kind of a database and every user has a different record in each of these databases, it can be quite challenging to put all that together, or at least attempt to not do that and somehow come up with a solution that might be a stopgap in the process. That is extremely challenging, but not necessarily challenging for the software itself, because it can handle all of that. It's challenging for the institution to renew those discussions and conversations and say, oh, look, we did this 10 years ago because it made sense at the time, but now that we want to become more modern effectively, this is not quite as easy as it would be, and it creates all sorts of other problems. That's probably the biggest challenge.
And worse than that, the people who built it are no longer working for us, and we don't understand.
They're no longer there, exactly. They're on Hawaii, drinking stuff, and yeah.
So thank you very much. This has been most interesting, and look forward to your appearing at future FOSSASIA conferences.
Absolutely. Thank you very much for the time. Bye.
Have a great day. Right. In the meantime, Floyd, can you please turn on your camera and unmute your microphone?
Hi, Roland. Good evening.
Oh, hello to you. Well, it is in fact evening where I am, yes.
Where are you today?
I'm in Singapore.
Likewise.
Oh, right. Okay. So good evening yourself. So we're on about 5 minutes. Couple of things. One, you are scheduled for a 25-minute slot, and there is someone 5 minutes behind you, so that's 25 minutes including Q&A, and I will hold you to time. 2 is presentation material. Do you have slides, a video?
So I uploaded the presentation, but one of the challenges, it doesn't download it properly.
We have a lack of. Oh, okay. So screen share is fine so long as you don't have any video.
No video, just screen.
Then screen share will do, but I would suggest you test it right now because there's strange browser compatibility problems with screen share.
Sorry, could you repeat that one more time?
There are some strange browser compatibility problems with being able to select an application or a screen to share. So I suggest to do it right now. At your bottom right, there should be a button that allows you to share screen.
So you want to test that?
I want you to start. No, not to start your presentation, but to share your slide deck and your title slide.
Good?
Beautiful. Okay. In that case, nothing further. That was rather
And
painful.
I'm taking 15 minutes to present, and then we take it from there. Good.
Okay, so in that case, please stand by for about 3 minutes. I'll start at the scheduled time. I will first introduce you and then invite you to give your talk.
Perfect. Waiting then.
Back in 3 minutes.
Perfect. Cheers. Roland?
Hello.
Hey, I've uploaded the file. Should I try that once again?
Feel free. Yes, yes.
Now the font's not, it's dropping the background.
That's right. Seriously, screen share is working fine so long as there's no video. It's only video we've had trouble with.
No video.
And so long as your browser works, which clearly it does. Anyway, yes, now might be time to turn your camera back on. Hello, everybody. Welcome back. Our next speaker will be speaking to us about next-gen cybersecurity for space systems, which is awesome. I think space is fantastic. Floyd DaCosta is the co-founder of Block Armor, a cybersecurity startup that was accelerated by Airbus and is featured amongst top 25 innovations in cybersecurity. Also co-founder of Blockchain Works, a Singapore-based fintech and regtech venture, has a background in management consulting, Capgemini, speaker and writer at various events, advises multiple public and private organizations, particularly on digital transformation, holds a master's in computer information systems from ITM Mumbai, and the exec general management program from IIM Bangalore. When he's not traveling, he enjoys spending time with his family in Singapore, which I think makes lots of sense. I like being in Singapore myself. Floyd, take it away.
Thank you so much, Roland. And good evening or good morning, depending which part of the world you are in today. And it's a pleasure to be talking about this subject here today. Here's for a quick introduction, and thanks, Roland, for starting that off. My name is Floyd DaCosta. I'm the co-founder of Block Armor. Block Armor is a cybersecurity venture based out of both Singapore and Mumbai. And we focused on exploring modern approaches and emerging technologies to counter growing cybersecurity challenges in bold new ways. Block Armor was accelerated by Airbus, and we did some very interesting work there. And more recently, we part of the Singapore Space Technology Association program in Singapore, and we're now looking to extend the same technology and the same solution slightly higher into space and look at how we can deliver next generation based space networks, secure and compliant. So here we go. Today, if you look at space, the space infrastructure has become an integral part of our everyday life for individuals, businesses, and governments who overwhelmingly now rely on it. From the first thing when you wake up in the morning and turn on your phone, the GPS, the phone automatically links up with the GPS systems, identifies your location, and at that point, you start the day connecting to space systems and go right till the end. Today, like I mentioned, GPS allows us to find our way around the planets and track all form of assets, not just humans or an Uber driver trying to find his way to your residence, but even all sorts of other devices, airplanes, ships, and a number of other devices that now rely on global positioning systems. The other thing, communications. Number one, we are able to deliver communications and the internet even today to some of the most remote places on this planet, not just in the forest and the mountain where there is absolutely no telecom coverage, but even deep down, right across the seas, but even in flight today where you're comfortably able to browse the internet sitting in flight. Like I said, we in space technology and satellites, communication satellites, now enable connectivity to some of the most remote locations on Earth as well as in space. And last but not the least, satellites and other space infrastructure have now become an integral part of security and defense objectives. To be fair, that's one of the places it started. But even if you go beyond this, today space infrastructure is one of those things which as a society we've come to overwhelmingly rely on, not just about safeguarding and things like that, but also things like predicting the weather conditions and how it's going to be today, trying to assess climate change and a whole lot of other critical issues that the planet is facing today. Well, it's an integral piece, it's an integral infrastructure that is critical to not just about communicating and finding a way around the place, but even survival and saving human lives today. And yes, it's expected to grow rapidly. As of, at last count, if I remember correctly, as of yesterday, SpaceX has launched over 260 satellites, and this is just a small start to their total global coverage, or the total coverage of the entire planet to deliver internet and connectivity via space. But given its strategic importance, space systems, which range from satellites to mission control center to ground stations, are now becoming the target of cyber attacks. And one of the challenges that the space industry has faced, despite its technical sophistication to date, the cybersecurity efforts of, right from satellites, ground station, and everything in between, has lagged behind that of other high-tech sectors. We've seen in the past the International Space Station was infected by the virus long back in 2008. In 2014, hackers were able to compromise the US weather system satellite network, NOAA, which is crucial to disaster planning, aviation, shipping, and a number of other use cases. More recently, researchers at the Black Hat conference in 2018 were able to show how you could take control of satellite communication devices to compromise and attack everything from planes, boats, military installations, and things like that. And in fact, I was looking up where now the US Air Force has a site, I forget the name, where they actually invite people to come and provide them with infrastructure so that they can attack these satellite systems, of course, the test ones, and basically pinpoint what might be certain shortfalls that they can fix. Given again, the other challenge is if the earlier satellites, when they were deployed, cybersecurity was never such a big challenge. And hence, it was one of those things which has always been an afterthought. So you've got systems out there which are now open to compromise. And the challenge is, how do you protect this, given the importance of space infrastructure and how important and what a crucial part of satellite plays in everyday lives, in our personal lives, in businesses, government, and even defense and security. But today, we have an opportunity. With the shift towards software-defined satellites and systems, the industry has an opportunity to fix many of these cybersecurity shortfalls that have been there. Today, to share a bit about software-defined satellites, you're seeing a shift from custom hardware to digital virtualized-based software systems that run these satellites and even the ground systems. To put it very simply, you're talking about something like cloud, shared infrastructure, virtualized, and that can be quickly repurposed and adjusted for different uses. Now, what this does, the moment software is there, it allows you to manage security. It allows you to upgrade security. It allows you to issue patches and patch up any critical vulnerabilities that could exist there. And this now is an opportunity. In fact, most of the new satellites, especially the low Earth orbit ones and the one which the one designed to provide faster, better internet and communication systems, pretty much rely on software-defined systems. And in fact, many of them, a few of them that I know of at least, are using some stripped-down version of customized Linux, which now makes it easier to say, how can we secure these systems? How can we secure the ground systems, the satellites themselves, which are, if you look at it, put by one of the satellite executives, nothing but IoT devices out there, right? So the ground system, your satellite, as well as the network in between. How can we fix this? How can we fix the security so that you deliver end-to-end security? And this crucial infrastructure, which is now which is a critical part of everyday life, can now be secured. Now, here is a couple of innovations that we've been working with. And like I mentioned earlier, the whole idea is to look at modern approaches like zero trust, more emerging technologies like blockchain. Simply put, one of the key things that we use is software-defined perimeter architecture. Now, today, if you look at the SDP, it's available commercially, but this is something that was engineered by the Department of Defense a long while ago, and it's pretty much prevalent in use in military. But like I mentioned, today it's now going commercial. It's used by the Department of Defense. It's used by the Department of Homeland Security. But now even enterprises like Google and Coca-Cola are starting to use this. What happens is a software-defined perimeter basically is an architecture that can render any device or any critical infrastructure invisible. How do you attack a satellite or a server or a ground station that you can't even see? How do you attempt to DDoS a system that you don't even know exists? And this is one way, and probably in military parlance they call making the infrastructure dark, putting that extra wall of security to defend any critical infrastructure. Could be ground stations, could be satellites when we're talking about space, but could be all sorts of devices that have now become an integral part of our lives with the rapid growth of IoT. On the other side, there's another very interesting technology which is in the news practically every day these days: blockchain technology. It has 4 key features. Number 1, decentralization. It's a highly distributed network, well adapted for today's distributed and hybrid IT environments. If you look at space, again, it's all over the place. How do you secure these systems, right? And it's and one of the things is, I get to ask this question very often: why do you look at blockchain technology? And here are the 3 reasons. Number 1, the decentralized or the distributed nature of the technology. Today, if you look at cybersecurity and traditional cybersecurity systems, many of them have a database, and then what happens, it becomes a single point of failure. If an attacker is able to compromise your database, your system is pretty much compromised. With a blockchain, what happens is, if you take out one node of the blockchain, it does nothing. It barely even, you can barely even infect the system. To compromise the system, you need to take out at least 51% of all the nodes to compromise the blockchain. Point number one, you need to know how many nodes are there to calculate 51%. And then secondly, you need to know exactly where those nodes are placed to bring it down. And that makes it resilient. Secondly, cryptographic encryption. Everything is cryptographically encrypted on the blockchain. The third part, which is the most crucial one, according to many in the cybersecurity space that I've spoken to, is the immutability factor of the blockchain. What happens is any data recorded on the blockchain pretty much is in there forever. Now, today, if you look at cyber attacks, sophisticated cyber attacks that take place, if you watch what the analysts are saying, it takes anywhere between 100 to 150 days for any enterprise or organization to even know it's compromised on an average. This is because sophisticated attackers are able to wipe their traces on their way out, and hence the company doesn't even often know that it's compromised. What happens is with the blockchain, every attempt that is made to log in or to connect to the system is recorded, and that can never be erased. So what happens is any organization today has instant visibility if anyone's trying to compromise its system, attack its system, or if there are a number of failed attempts, and it can immediately take steps to mitigate the threat. These are two technologies we've been playing around with. These are innovative emerging technologies, and what we've done is bring software-defined perimeter together with private permission blockchain technology and develop a zero trust security system that we are now that we're now adapting for space-based networks. And I have a slide on that in the next further down. Taking it a notch higher is the use of digital signatures. Today, a lot of security that you see, especially on the terrestrial and used in organizations, enterprise, government, is based on IP address. But with the whole boom of IoT devices and things like that, IP addresses are not going to be enough. And that is why you see the number of attacks on IoT and connected systems just going, skyrocketing. In fact, if you look to just about a month ago, an attacker was able to compromise the water system, the utility systems of a city in Florida, and tried to poison the water by dumping a large amount of a certain chemical that's used. The chemical needs to be there, but in very small quantities. But he was able to get access to the system and was attempting to kind of poison the water there, if you look at it literally. But fortunately, the admins were able to notice this and took control of the system and was able to mitigate the attack there. But coming back to the point, the use of digital signatures to identify, authenticate, and authorize connected devices provides us a whole new level of security. And this is because what you're able to do is secure the interconnected devices, not just the end devices, but also tightly ring-fence critical OT and IT systems. What you see is quite a bit of blending today with the IoT space booming between the operational technology and the IT systems. And now that's where the gap lies, whereas that's where the gap is, and attackers are able to compromise systems. If we can create this digital identity for all connected devices, both the connected devices and the resources within the systems, you're able to kind of provide an integrated platform that leaves no gaps between disconnected systems, but that are working together today. Like I promised, I wanted to share a bit about what we're doing, and this is one slide. While this is one of the and multiple use cases, but this is the architecture that we're using. What we're seeing is here is a unique opportunity to kind of deliver ultra-secure satellite-based networks, right? And this is available publicly, so we put it out there. We have what you call the Block Armor Secure Shield Controller, and that's the blockchain network and app sitting there. And that's the one that is able to dish out digital identity for all users and devices within the system. Now, if you look at this one slide on the left-hand side, you have your terrestrial networks, which is what we have in organizations today, whether enterprise or government and even home-based networks, right? You've got your data center, where all applications are, but now you're also seeing shift to the cloud. Organizations across the board, especially in the midst of COVID-19, now accelerating digital transformation and moving many applications to the cloud. You've got your gateway, which is often your Wi-Fi or your fiber optic networks and things like that, that help you connect to your private networks. You've got and you've got users that sit within the enterprise. But what we're now looking at is also enabling remote users, people in far-flung areas, but also as what popularly exists today is access to the internet on ships, on planes, that people are able to seamlessly connect to a telecommunication network. But you're also seeing the whole space of connected devices like cars and things like that. Today, if you look at autonomous cars and the growth in that space, a car has to these cars automatically drive themselves from one place to the other. Not only are they counting on the GPS system, but they're also counting on data being delivered to these devices. And our goal is to say, how can we have integrated security? How can we go with security across the terrestrial networks, but also for these remote systems? And that's what we are building right now. So if you look at the little agents out there, the little shields, those are our agent devices that sit on the servers, on the gateways, and secure them. And then the users also have these agents sitting on their remote devices. All users authenticate themselves against the blockchain. The devices authenticate themselves against the blockchain. And the combination of the user and the device ID provides them secure access to applications sitting in the data center, in the cloud, and elsewhere. Now, while we've done that on-prem, on the left-hand side, we're looking to extend that via satellite networks. And all communications between the end device and the data center, the cloud, is secured using 4096-bit encryption. Now, that's even the bare minimum that military organizations are ready to accept today. And our goal is to say, how can we provide that secure, zero trust overlay for connections that are going from the far right all the way to the left and connecting to and providing access to all sorts of data and applications that sit either in data centers or the cloud. This is one thing we're working on. Two use cases is how do you provide secure remote access to employees either sitting in far-flung places, but also these days, is there an opportunity to provide access to remote users, folks that need to access critical applications, irrespective of where they are in the world today. The second, the other use case we are working with is there an opportunity to provide ultra-secure backup, satellite-based backup networks for critical infrastructure and applications. These are applications that need access all the time, and should terrestrial systems, should the Wi-Fi or the fiber optic network go down, should the 5G or 4G network go down, is there a way to provide a backup network that now comes via the satellite? And can we deliver that in a secure and compliant manner? That's one thing we're working on, and that's where we're using software-defined perimeter architecture to secure these critical resources, the critical applications, and at the far end, use the blockchain to provide digital identity and access for all users and devices accessing these systems. Boiling it down into four key targets that specs that we're looking at. The need of the hour today is a next-gen, let's say, military-grade security platform to protect space infrastructure and systems against emerging cyber threats. The space infrastructure is no longer something that's like nice to have. It's critical and it's a must-have. And how do we secure these systems? And that's where we look at cryptographically secure digital identity, that I just spoke about, for all users and connected devices. Invisible lockdown critical systems that I spoke about. Best-in-class military-grade encryption, like I said, securing all connections between the devices, the servers themselves, and the network in the middle. And last but not the least, the immutable tamper-proof logs stored securely on the blockchain so that any organization has instant access and can know if it's being compromised and remediate the situation. I'm going to leave it at that. Here's my contact details. I'm happy to take any questions now.
Fantastic.
No, I hope I did it just in time.
That's some impressive timing. One thing I missed, however, where's the open source relevance in what you're presenting?
Correct. So going back, two things. Number one, actually three things. If you look at the satellite networks and the modern approach and the modern software-defined satellites, they're all based on Linux, open source software. There are customization because this has to be adapted for wide area networks and radio networks, and that's the adaptation that's there. Number two, software-defined perimeter architecture that I spoke about. One of the tools that we're using, it's open sourced. Like I said, it was developed by the US military, the Department of Defense, and it's now available for organizations worldwide. And this is an open source architecture that's available.
Which tool is that?
Sorry, let me just come back to the slide. The software-defined perimeter architecture is open source technology, and of course, blockchain. This is fully based on open source technology. So it's not just the satellite systems, but even the security systems and security overlay that run on top of that could run on top of the satellite networks is built using open source, and we are able to deliver it with open source technology.
Thank you for the clarification. This is a pretty spectacular case study for the application of open source technology, which is always appreciated. Only one question, which is an interesting question, from Alvin. Slide 3, when you say NOAA, I'm not sure this question makes sense, Alvin. Is this the same NOAA in the movie Battleship that they use as a early warning for tsunami?
Yes.
I think we can guess yes. The National Oceanographic and Atmospheric Administration.
Yeah, it's one that's used for weather satellite systems and stuff like that. And that was compromised many years ago. But they were able to retake control back of that. Of course, today you have much more advanced systems, but yeah. And that's what I was referring to. These are critical infrastructure, right? It's not just about stealing data anymore. There are lives at stake. And the whole question, and we rely on these satellites for way beyond traditional commercial users, right? And I'm not even touching the defense side of it. I'm talking about just everyday life.
GPS. If you take a boat too close to Putin's palace, your GPS is suddenly telling you you're 100 kilometers inland, which is kind of an unfortunate position for a boat to be in. We have one final question in 2 minutes, so we can just do it. Which satellites, this is from Harshit, which satellites or space companies are already using your solution?
No, we asked, just to be very honest and transparent here, we are still testing the systems. What we've developed it and we've tested it for non-space yet, slightly lower. We've tested it over 4G-based systems, and now we are piloting it to test it over 5G. So very simply put, and again, for us, it's about getting access to terminals. So, one of the things we're talking to the folks at SpaceX and Starlink to see if we can get access to their systems. So then what we do for testing is turn off the terrestrial systems and make sure access goes exclusively via the Starlink network and explore if we can still deliver the end-to-end security that I spoke about. So you've got the remote at our end and then connecting over the satellite network securely into the cloud and critical application servers. Okay.
Best of luck, and of course, as always, we'll encourage you to look for opportunities to make more of your pieces open, either to use or to share, as you.
Most welcome. We are always in collaboration.
Thank you very much, Floyd.
Thanks a lot. Thanks.
Okay, next up, we have, in about 5 minutes' time, Robert Reyes talking to us about getting the web back on track. Robert, if you're in the room, can you please turn on your microphone and camera? Paging Robert Reyes, can you please turn on your mic and your camera? Hello, Robert. Okay.
Hi there. Hold on. I'll just have to turn on my camera.
Yes, please.
Some issues. There you go. How does it go?
That's brilliant. We can see you and hear you. Fantastic.
Okay. I'll just share my slide deck. Hold on, give me a second here.
Don't know if you can do anything about it, but you've got a noise cancellation system that's being a bit aggressive. There's a click.
Yeah, I think it has something to do with my microphone. Hold on.
Soften that a bit. That would be great. But yeah, either or.
I'll just have to turn off my camera.
Sure.
If I can be given permission to share my my screen or slide.
Oh, I thought I did. I apologize.
Okay, hold on. Okay, there. How does it go?
That looks great.
Okay, can I start?
So stand by. We'll start in a few minutes, but do turn your camera back on.
Okay.
Is there any video in your presentation or just the slides?
Just a slide.
You seem to be having trouble.
There you go.
Okay, so let's talk some more. Yeah, it's still a little bit clicky when your noise canceller kicks in. Do you have a way to lower the threshold? Just let it keep running with noise?
There?
Somewhere you should have a threshold. I don't know if you can find it in 3 minutes, but you should have a threshold control that determines at what point it mutes. What I'm suggesting is you lower that
It has
threshold.
something to do, yeah. It has something to do with my GPU, but yeah.
If you can't quickly find it, then I guess we're kind of stuck with it. That's all right. Okay. So this way, did I ask already? Are you presenting any video or just slides?
Just slides.
Just slides. Okay, that's great.
No video. Yep.
Okay. So, where are we at? That's everything. You'll have 25 minutes, including Q&A, and there is another presentation at past, so I will need to hold you to time at the end there.
Sure, I'll be timing myself.
Okay, that's brilliant. Oh dear, I can hear you fine, but yes.
Yeah.
Others are hearing the chopping, and Hong Fook can't hear you at all.
How about this one?
Yeah.
Okay.
Yeah, it seems that everyone except Hong Fook can hear you so far, but keep talking.
Yeah, there. Okay. When I stop saying something, yeah, the mic will pick up the noise.
Yeah. All right. It's fine, apart from the fact that the noise cancellation is a bit aggressive, but that's livable.
I think it has something to do with the mic, and I got the GPU warning over the weekend. I think it has something to do with it too.
Oh, that's really breaking up. Oh dear.
Yeah. Mac issues.
I know we're now at the time to start your session, but I'm going to ask that we waste a minute. Do you have Chrome installed on your machine?
Let me try.
But
the audio.
But sorry.
Okay. But wait, my audio is breaking up.
It seems actually worse than it was initially. Yeah.
Okay. I'll try to stop my camera. How about this one?
Well, so far
Testing 1, 2, 3. Okay. Maybe it has something to do with my bandwidth.
Perhaps the two together, yeah. It's still a little bit clicky, but breaking up, yes. I take your point. Let's run forward and see what happens.
Okay.
This is Robert Rees, who is a tech speaker from Mozilla, a Mozilla Reps mentor, and lives in Makati City in the Philippines. We'll talk to us about how to get the web back where we think it should be.
There. Thank you, Roland. Okay. So yeah, good evening, good morning, good afternoon to wherever you may be in the world right now. So I'm based in the Philippines. So it's getting dark here now. If by any chance I will be cut off, I will blame my internet connection. Yeah, we have one of the slowest in this region. So I'm here today to talk about how to get the web back on track. If during the course of my talk my screen gets blank, please feel free to interrupt me. So I will not be monitoring the chat for now. I'll be focusing on my discussion and looking at the screen of my presentation. So again, my name is Bob Reyes. I'm based here in the Philippines as a Mozilla Reps mentor and tech speaker. Among the other things, yeah, I've been using Firefox since version 1. If you are on Twitter, my Twitter is @BobReyes. Yeah, I'm a Pinoy Mozillian. I'm so proud of it. So yeah, we have a couple of Pinoys with our names listed on the Firefox Monument in San Francisco. So what is my agenda for tonight? I'll be talking about briefly what Mozilla is, a brief history of the internet and the web for those who are too young to know what the history was. And I'll be discussing about what the web is right now and how do we get back the web back on track. Okay, and if we still have time, I'll be accommodating a few questions. Okay, so what is Mozilla? Mozilla is a global nonprofit. We started with this. For those who are too young to know, this is Netscape. So there was a point in time when Netscape's source code has to be given away as an open source project, and it was called Mozilla.org, so Project Mozilla. So that was in 1998. I was still in college, and for those who are too young, maybe you're still not around that time. So that is basically the shortest history of Mozilla. Okay, so as a global nonprofit, we have a mission. So what is our mission? So our mission is to build a better internet. We rely mostly today on the web, on the internet. Okay, especially that children are studying from home, adults are working from home, etc. And part of our mission is to ensure that the internet will remain as a global public resource that is open and accessible to all. If there are issues related to openness and accessibility, you can call Mozilla to be there. And we want to have an internet that truly puts people first, where individuals like you and me can shape our own experiences and we are feel empowered and safe, independent. Okay, so making the web or the internet as a safe space for everyone. Now, in order for us to be true to the mission, we need to have products. So what are the products that we have? We are best known for Firefox. So our mantra has been committed to you, your privacy, and an open web. And for those who are not using Firefox, since version 63, we are now in version 80 plus. Okay, all the desktop versions of Firefox included an experimental cookie policy that blocks cookies, okay, and other site data from third-party tracking resources. Okay, we started that a few years back. Okay, and we continue to work on this, especially now that we know that there are what we call now as super cookies. So before we know cookies are temporary files, and come to a point now that there are cookies that are actually staying on our computers forever, and that should not be the case. Of course, we have Firefox. There was a post somewhere over the web about this logo. This is not the Firefox web browser logo. This is the Firefox family logo. The Firefox browser logo still has that foxy thing. Okay, so we also have Firefox Lockwise. Okay, if you want to have a tool to safely save or store your passwords and login credentials. And we have Firefox Monitor. If you want to check if your email has been part of any publicly known breaches for the past few months, just go to monitor.firefox.com. And for those who are techie and geeky like me, there are other flavors of Firefox like Firefox Nightly, Firefox Developer Edition, and Firefox Beta, aside from the one that you see, which is the release edition when you go to firefox.com. So these are basically some of the most loved products that we have when it comes to Firefox. We also have Firefox for mobile, both for Android and iOS. Okay, and for email and security, we introduced some time ago Firefox Relay. So what is Firefox Relay? It gives you the ability to create relay addresses. So these are like forwarding email addresses so that you don't have to give your real email to websites that ask for it and you don't trust them. So like if you want to subscribe to something, maybe you can just create a relay address that forwards to your real actual email address, and once you are done, you don't want to receive any from those websites, then you just have to turn off the relay address. Because what happens is when we subscribe to some websites, the more that we tell them not to contact us anymore, when we unsubscribe, it is the more that they will send us spam emails, okay, unwanted emails. And yeah, so this is one tool that we can use to avert those kinds of things. So going back to my agenda, so let me tell you about how the internet and the web started. So when the commercial web, that the commercial internet that we know now started, people thought that it is something that is connected, open, and safe. Okay, so that was the general premise. It became a portion of our lives wherein we thought that the internet is a place to build our dreams. Many became millionaires, many found fortunes because of the internet. Just like anything, okay, the web needed nurturing. Why? Because it was during this time when many websites started to have pop-ups, viruses, unwanted codes, unwanted trackers, etc. Okay, it also became something wherein there are places in the web where people do not have any choice. It will ask you specific questions, but at the end of the day, you will have to agree to them. Okay, that is not good. Okay, that's not good, especially now that we as individuals begin to understand the value of privacy and online security. People need to have a choice. It also started walled gardens of content. Okay, what people initially thought that everything will be free became a part of something that is behind closed doors. So many people started asking, is this it? Is this the web that we want? Okay. So, or could there be something better? Okay. So the web now, when we talk about the web, a few months ago, we started this campaign at Mozilla. Okay, that later I'll be talking about. So we said that the web is FCK. Okay, for many reasons. First reason is that companies are making money by tracking users like you and I. Okay, they started monetizing this data that they get from us to advertisers. Okay, here in the Philippines, the common example that I tell people is that when you want to buy something, the first thing that most people do here in the Philippines is go to a search network or to a search engine. And before they knew it, after searching from an internet search service, when they go back to a social media site, all of the ads showing in that social media account is basically the product or the item that they are searching minutes before. Okay, so what does it mean? The data that the search engine collected from this particular user was passed on to as an advertisement to the social media network. Okay, and it's happening almost at instant. Okay, it's automated. It is not something that is being curated by a human being. So this is search engines and social feeds are governed by algorithms. Algorithms are everywhere, and algorithms are biased. How are they biased? They are biased in same ways as people who created them. What else? In the age of internet and of the web, false news stories online continue to confuse us to what is factual and what is fake. Especially during this time of pandemic, fake news has been prevalent. Okay? In places where elections are happening, here in the Philippines, election will happen in a year's time. As early as now, fake news is prevalent. Okay? And that should not be the case. The internet is a new kind of marketplace wherein many of the things being sold never existed before. Okay? Not just physical items. It's a marketplace for selling data. It's a marketplace for selling one's attention. Before, when we were young, we only have televisions and radios. So there's a saying, if you are not paying for the product, maybe you are the product. That is so true for the web right now. So what do we suggest? So we have this campaign, Let's Un-FCK the Internet, a few months back. So this is how it looks like. So how do we un-FCK the internet? Okay. So one, we have this thing called the Facebook container. So Facebook, if you're using Facebook, it follows you around the web, okay? Even if you don't have an account. That's the one scary thing about the social media network, okay? So if you're going to use the Facebook container, if you're using Firefox, so it's an extension that you may install to your Firefox account, to your Firefox installation, okay? It will prevent Facebook, that's why it looks like a fence. It will prevent Facebook from following you around the web. The less data that you have on Facebook means the less chance for bad actors to be chasing you. Okay, so the less data that Facebook have on you, okay, the less data that they can give away to bad actors. That is one thing to be safe. Okay, I was asked by a friend how to be safe when you are using Facebook. The simplest answer, close your delete your account in Facebook. Don't use Facebook. That's the safest way. Okay. What else? If you are into bookmarkings, we have this product called Pocket. So if you want to avoid misinformation, minefield, we suggest for people to use Pocket. So what is Pocket? It is a social bookmarking service with human with human curators. Why? Because algorithms have no taste. Okay, they will only show you the goods. They will only show you what they want you to see. All the good stuff is hiding from plain sight. Okay, algorithms count reactions, but they cannot count depth, width, knowledge, and truth. So with Pocket, since we have human curators, you share the most diverse, trustworthy, and accurate stories among your friends, among your family members, and to the rest of the community. And lastly, okay, so the internet is far from perfect, but it still has the magic that keeps us coming back. Okay, so as an organization, we at Mozilla ask people around the world on how the internet has kept them sane, hopeful, and connected this year, especially during the time of this pandemic. So if you are on social media, you might have the chance of seeing hashtag Dear Internet. Okay, so we encourage people to write down, okay, some sort of a love letter for the internet, okay, for the web. We are also calling on people to donate, not just to Mozilla, but to other nonprofits that fight for a healthy internet. Okay, so for example, if you will be supporting Mozilla Foundation, it will help us put you more in control of your online experience and shape the future of the web for public good. So how do you do that? Simply go to mozilla.org and click on the donate button. And basically, that's it. I'll be ending my talk with some 5 more minutes remaining. Thank you.
That was quick. Just munching on dinner and suddenly I can't. Right. So, questions?
Sure. I'll just check.
Apart from the unique spelling of Zuck. We are here to unzuck the internet. We have, actually, let's ask that question. So the technologies you've flagged this time around were the container in the browser, the use of an email address relay. What was the third one? Robert? We've lost him.
Hello?
Oh!
Hi there. Sorry. Hi.
Failed to
Just
clear
start
the Q&A block for this session. Thankfully, someone is stepping in and helping. Thank you, Invisible Helper. So I was going to do a quick poll, and the question was the technologies from Mozilla that you've just talked about are the container for the browser, Facebook container, but more generally, the email relay, and I thought there was a third one.
Is it Pocket?
What?
Pocket.
Oh, Pocket. Yes.
Bookmarking.
Okay. So the question is, if I remember how to do a poll. Start a poll. Here we go. So, quick show of hands. Who is using at least one of these three things? That is the Facebook container or one of the container variants inside the browser, the email relay,
Firefox relay. Yeah. Firefox relay.
For single use or non-attributable email addresses, and Pocket. And you're invited to say yes or no, right? It's not just only those people who are using can say yes. Okay, so amongst respondents, at least 3 times as many yeses as nos, which is nice. Oh, I've got to publish that. Okay. I'll give it another 5 seconds for those who have not responded yet. And voila. So there we go. We have, of the respondents, 80%. That's about a third of the people in the room actually using one of those three. That's fairly impressive. I didn't ask which ones people are using. Oh, Firefox VPN. Robert, what's the current view on? Okay, not available in most regions. Fair enough.
VPN is, yeah, it's not yet available in most regions. Even here in the Philippines, it's not yet available.
Got it. Fair enough. So the questions that we have then are. Actually, a good one. How are the relay.firefox.com aliases managed by the end user?
Sorry, come again?
How are the relay.firefox.com aliases managed by the end user?
Okay, so when you go to Firefox to relay.firefox.com, you'll have to log in. If you have a Firefox account, that will do. And our long email addresses, and then from there you can simply create one and make it redirect or relay to your real email address.
And can you also delete them?
Yes.
And if you delete them, are they?
So right now, yeah, go.
If you delete them, are they permanently deleted? Meaning there's no risk of somebody else registering the same alias.
Yes. That is one of the design of the Firefox relay.
Yeah. Okay. That's a fairly critical one. I don't know what the next question is about. When will send.firefox.com be reinstated with some clever management? That sounds like
Actually, I do not have the answer yet. It was offline concerns. Yeah, and based on the latest update, there is no plans yet of making it available to the general public again.
Okay, and that sort of dovetails with the next question about the strategy of Mozilla upcoming projects and which projects are going to be closed, in particular deep speech. Robert, are you still with us?
Hello? Yeah, I'm here. I'm here.
Yes.
Hello?
So
Yeah.
the question was about Mozilla's strategy, upcoming projects, and indeed projects that are to be closed. In particular, how about deep speech?
Deep speech is being maintained by the committee right now. I still check the other products related to deep speech. But last time that I've checked, this particular product is maintained by the community.
All right, got it. And I think what should be perhaps the final question, given that you're dropping out, it's getting worse. Will Firefox incorporate the Tor capability, like what the Tor project themselves have done?
From what I know, we don't have plans right now.
There are various of the capabilities, like the containers that originated in the Tor project, but no plan to do the entire Tor project.
Yeah.
Oh, that's fair enough. All right. Oh, hello. We do have one more question. Does Mozilla still want to be a tech organization or only focus on talking about privacy? What an interesting question.
Yeah. But I don't have the answer right now. Maybe we'll have a definite answer to that. I'll take note of that. I'll ask that question on the next all hands.
I would hope that actually any tech organization needs some sort of purpose other than tech. Tech is an enabler.
Yeah, yeah.
Privacy is
That is more of a high level kind of thing.
It is pretty high level, but I think it's a legitimate question.
Yeah, yeah.
You know, the Firefox is gradually losing.
We're asking that question.
The question is, where is Mozilla going to specialize? I would have thought the privacy supporting tech was a really, really good place for Mozilla to focus. Anyway, let's wrap it there. Thank you very much, and
thank you, Roland. Nice to see you. So this is the 6th year of me being in FOSSASIA. Thank you very much for having me.
Wow, we look forward to you being here for a 7th.
Yeah, see you soon.
Thank you and good night. Okay, our next session is in 5 minutes' time. Art Templeton, I understand that you are called Mike R. Yes. So could you let me make you into presenter?
Hello.
Can you please start your camera?
Medium quality it is. Start sharing.
Oh, you definitely use low quality. There's no.
All right.
There's just no benefit, right? It's a small talking head frame. It doesn't need to push a lot of bandwidth.
All right, sir.
Wonderful. Okay, I'm seeing you and hearing you very clearly. Are you presenting slides? Are you presenting video?
Yeah, I'll be sharing my screen.
Okay, so you are. But will you be sharing just slides or video?
I have a slide. I uploaded it, but it's on PDF, so I'll be presenting with some video clips. So perhaps let me.
Now, so this is important because if you do that, you will see the video clips, but most people won't. Are the video clips on YouTube?
No, it's in my slide. It's in my PowerPoint presentation.
Oh dear. All right. Our experience with that has been really bad. That the screen sharing is not very good at.
If you could see my screen.
Oh, we see your screen. The problem is that it's got to do real-time encoding of video, which. No,
the video is just it's already embedded in the PowerPoint, so it's not linked in anywhere else in the internet or so. But
all right. How much of your presentation time is video?
It's just I'm just presenting with
1
showing.
minute, 5 minutes, 10 minutes.
No. It's like a seconds.
Okay, that's fine. Just be warned. It might be that nobody other than you can see it.
Yeah.
Okay, that is excellent. So you have materialized in our environment as Mike R, but I understand that your name is in fact Art Rebeltown. Is that correct?
Yes, sir. Just call me Art. There's a
Art
long
it is.
story of that one, why I became Mike here in Singapore.
Perhaps for the Q&A.
Yeah. Right.
All right, so we will start at 6:30. I will introduce you. You'll then have 25 minutes for presentation and Q&A combined.
All right, sir.
Fantastic. In that case, let's stand by for about 3 minutes and then get into it. Paris has asked whether I can sing a song during the break.
Yeah.
Fortunately, the answer is no. Because if I do, everybody will leave. Okay, so welcome back. Next up, we have Art Rebeltown to talk to us about counterintelligence in ICS SCADA with FOSS, which I think is a particularly interesting area. I work in both privacy and security myself. So Art works with cyber counterintelligence at Equinix, almost 2 decades of experience with IT and OT professional, all the excellent security kinds of things, holds a master's degree in IT with a concentration in e-commerce security, and a graduate diploma in digital forensics and cybersecurity, specializing in computer forensics, network intrusion, data breach, cybercrime investigation, and long list of other excellent cybercrime things, or cybersecurity things. Also Krav Maga, and Judoka, and a freediver. Fantastic. Just the person we need to talk to us about counterintelligence. Art, take it away.
All right, sir. Thank you. Well, every contact leaves a trace. That's according to the forensics science principle of Dr. Lockhart. And I thought that I'll be, that will be my opening statement. It's because I think that's very much applicable in cyber threat intelligence. The reason being is, how does so many security solutions providers, CTI platforms, are they keep on saying that they're good, they're number one, right? So if you think of the old school or the military way of intelligence or counterintelligence, there should be a contact in between, the adversary and the antagonist and the protagonist. And there is no such thing as, not to mention those APTs here, Lazarus Group or whatever, that they will post in a dark web that, hey, tomorrow we will be, bombing or we will be doing some coordinated attacks to do a cyberkinetic attacks on your infrastructure. They were not born yesterday. There's no such thing. So, before we go on that, I think I was already been introduced, and just a few disclaimer here that everything that you will be seeing on this slide and links, has nothing to do with my current company, right? And I strongly believe on the movie Antitrust, which Milo mentioned, that human knowledge belongs to the world. So if you don't share your knowledge, you get hacked, right? Okay, few days ago, March 16, this is PST, right? American time, California time, which is 17, that is March 17 in Singapore. Mandiant, introduces a new service, which is more focuses on insider threats. What does that mean? They have threat intelligence, right? They have threat intelligence platform or services. And how come they still created this kind of service? I was thinking like it is timing on this talk. It's because that's what I'm going to to mention and to share, that there's no such thing that cyber threat intelligence would cover the whole defense in depth, right? And not to mention about micro attack framework, and we will be able to plot. Okay, this is the Sandworm APT, and this is their tactic, techniques, and procedures. Have you asked yourself that if the whole world already known their TTPs, do you think they will not change it? Come on. So let's be real, right? So I thought of this like the more realistic of performing or creating a threat landscape for every organization is the security solutions should be know their inside, not the outside. Because the outside, the threat intelligence on the outside, right, coming from the outside, what I mean is it's like prediction. And either it will happen or not will happen. Who knows, right? But if you are looking into like insider threat, just like these services, it's more accurate. Now, I will not go through with so many incidents happens in both the IT and the OT, and earlier in the blockchain talk, the great speaker mentioned about the water system in Florida got hacked because their team viewer where the password is password, right? They never change. So it's impossible that they don't have intelligence, right? And many companies last year Honda got breached, NTT got breached. It's impossible that they don't have intelligence, right? And still, these companies, these big companies, are still being breached. So, and by the way, these photos here are links. So I already uploaded this, and you could just click it. It will bring you to wherever I took this one, just to give credits on them. Right? So there are so many timelines that every day you could see there's a breach happening on the OT side and the IT side. I could not stress enough the one that I mentioned during the talk, 2018. Okay, this is a link on my YouTube channel, or their YouTube channel. So I just mention it here, that SIM, red teaming, threat intelligence here, endpoint detection and response, IDS, IPS, deep packet inspections, threat and vulnerability management. But imagine this is 2018, guys, and still, from then we keep on seeing so many breaches, right? So if you wanted to visit the site, just click it, and then you will see the whole video on this one. So this is about the defense in depth. So the one that is missing on that one is
Oh dear, I'm so sorry. That was me. Art, are you still with us? Hello, Art.
hello.
Hello, Art. I'm really sorry. That was my doing.
All right.
Ironically, I was adjusting some security settings.
All right.
You are welcome to start your camera and continue.
All right, sir. So let me go back here. So again, this was taken just today, this afternoon. So this is all about ICS SCADA OT side, right? So you could see there's every day there's 0 days. There are high severity of vulnerabilities that being exploited. This is the real world, right? And again, if you ask me, is this relevant to your organization, to my organization? Who knows? These are just, again, predictions that, the patch, yes, but some breaches, it may or may not happen to you because it happens to your neighbor. But being ready, proactively ready, it's good, right? But again, it's not that accurate. It's 50-50, I would say. Okay. Now, in the IT side, we know we could calculate how much would be the cost of breach, and because we're talking about the CIA triad, right? The confidentiality, integrity, availability. Now, my question is, will you be able to quantify the cost of life? I'm talking about this because I'm talking about I'm pertaining to the cyberkinetic attack. In OT, in IT, in ICS SCADA, CIA is it's not their thing. It's the SRP, not the suggested retail price, but it's the safetiness, right? The reliability and productivity. Of course, the availability of the production. Now, why am I asking this one? It's because in OT side, there's life that we're talking about, either human life, the trees. Again, to mention about the water system earlier, if if that water goes through to the garden or to whoever, not just the person, for sure, somebody will die, right? And even though, let's say I'm working in a, or let's say you are working in a petroleum company or oil and gas company, there's a hazard pay, right? Let's say 1 million. When you when you die on operations, you get your wife gets $1 million US, right? Is that 1 million versus your life? What would your wife will be choosing 1 million? No, come on. So that's the reason why I'm asking this one. So this is just a few attacks or some glitches on aerospace company, right? So computer glitch. This is quite old, yes, but still happening, right? So these are, and I took this one on my slide on 2018, and I mentioned about supply chain, but now, right, the solar winds attack, it's many people doesn't know about the supply chain attack. But imagine, I presented this one 2018 talking about supply chain. It's impossible that, let's say, I forgot, is it F-14 or F-50 something that was delivered to the Air Force, and after they plug it, after they connected it to the internet, it was hacked, right? That's the supply chain, and if that's not a supply chain, you'll ask yourself, the Air Force will be hacked, right? So that's how it works. All right, so petroleum chemical company, something's happened, right? So this is what I'm talking about. The cyberkinetic attack happens in some part of the Middle East. Okay, rail system, and you are there in the middle of the on the track, right? Now let's talk about security operations, the challenges, and this is something that I could see. I was able to see for since 2016 when I handled the incident response operations, right? The CSIRT. So there's a lack of network-based threat visibility. The reason being is most of the companies were focused on endpoint detection and response, antivirus. There's no problem with that, right? So is there, are they able to see man-in-the-middle attack, or make it simple, nmap attack, right? From the insider threat. So if you have an EDR solution or AV solution or EPP solution, ask your vendor, are you able to see somebody's doing nmap using their virtual machines, right? Not the actual machine, but they have a virtual machine inside their laptops or machine, right? So that's a good use case to challenge them. Huge data to correlate during threat hunting. Yeah, there's a SIM, right? The Google of all logs. But do you know what your threat hunting is? What your hunting is? There's so many. There's 200 plus of techniques in MITRE ATT&CK framework. Do you know where to start? Right? That's the challenge. Overwhelming false positive alerts, because this is a debate between an IT SOC versus the OT SOC. Many companies are leveraging, utilizing their IT SOC for their OT, and do they understand how Modbus works, how HMI works, PLC works, those kind of CIPs, common industrial protocols? So limited resources to respond, of course, and unactionable threat intelligence. Many threat intelligence nowadays, they will give you a bunch of 0 days, high severity vulnerabilities. But the question is that an actionable items that, is that relevant to your company? And very less, I would say, that are actionable, right? And huge numbers of APTs to monitor. Again, in the OT side, I've been monitoring a few on the OT side, but since my current company is also an IT, right? It's like more than 100, or to be exact, around 102 advanced persistent threats or threat actors that I've been monitoring, and I'm monitoring them when they will be in action again, right? And that's pretty much impossible that I could defend the company because of this thing. So I have come up with this counterintelligence. The use cases is detection on mass network scanning or mass scanning, exploitation, fuzzing, ARP spoofing, man-in-the-middle attack. So I will not be reinventing the wheel, but I'm sure some of you may already heard this one. But again, this is a good tool that you could use in your company for a decoy to trap, insider threats and creating your threat landscape. Because when I'm doing my threat landscape, I'm basing it before, right? I'm basing it from what's happening on the external. Okay, this company got hacked, so it's because of their team viewer were accessible over the internet and they did not change their password. So I'm gonna look for in team viewer in our environment if there is. So something like that. It's more of like threat intelligence is supposed to be proactive, not reactive. And the way I do it, it's reactive, right? Now, and I mentioned about earlier, there's so many. I don't know what to look for and where to start my threat hunting. So doing this, I will be able to know on real time, if someone did some basic nmap, because this will the conpat will react, right? And you have a basic tree, built-in template on once you install it, and it's quite very easy. You could see it in the GitHub or in some YouTube, I believe, right? So there's a Siemens S7-200, which it will open up a Modbus, or on this one is port 102, and then the Modbus is on 502, and a smart meter proxy will, if you wanted to use it, or SSL proxy. But if you're good in Python, you could open up a port for HMI and you could play around, right? And I'm sure you will enjoy this one. And now the question is, where should I implement this one? On what layer? If you're familiar with the Purdue model, right? And this is a sample. I would put it on the control station of the control engineer, right? On the level 3. So 3.5 is the DMC, right? It's like a horizon between the ocean and the river, right? Something like that. So and it's an option for you if you wanted to go if you wanted to deploy this one in the level 2. Now, the most frequently question that I get from friends and peers is, will not this disrupt any operational? Because I mentioned about SRP, right? The safetyness, reliability, and productivity in the industrial control system or building management system, energy management system. So I would know, based from 6 months of doing it POC before I deploy this one. No, because there's it's like more of an ingress rather than an egress in the network. So it does not do, right? It's just wait for the attackers to get in. So it will be the alerts will trigger, right? So conclusion, long live FOSS, right? Realistic threat landscape, as I mentioned earlier, rather than just copying pasting from the outside. And the reason being, many companies, many security solutions were able to come up with their threat intelligence or threat landscape. It's because they have an endpoint agents installed on those companies, and this is like similar to that one, right? Because if they don't have any let's say, for example, endpoint detection and response, or any antivirus installed on a certain company on their networks, they will not be able to come up that okay, there's so many Azeroths running in your network. There's so many trick bots, something like that. So that's how they come up with those threat landscape. But how about for you, right? The threat landscape for Peter is different from John, right? So this lessens the dwell time on breach detection as well, which many endpoint detection response are not able to do, right? Because this one is, if something's detected, like, why is this certain IP address keeps on doing some reconnaissance on the network, and if you use mass scan, it will literally scan all the network, and once any of these con path will get hit, it will trigger an alert, and you will be notified. So a complement of defense in depth. And I think I still have time, and that concludes my talk for today. Is there any question from the audience?
We can squeeze one in, and we do have one in the 2 minutes available.
Yes, sir.
Compot is compot.org. I hope it's the right tool. And the code is at github/mosh.org/compot. The question is, have you looked at having this be part of the Nmap ecosystem?
You're asking about the Nmap?
The question from the audience, unattributed, is, have you looked at having this be part of the Nmap ecosystem? I'm not sure how to interpret the question.
Yeah. Nmap. Good. I'm hearing about the Nmap tool. Is that correct?
Okay, the question is, have you looked at having Compot be part of the Nmap ecosystem? I don't know what that means. It's the other end of the game. So
yeah. Could someone decrypt that for me? It's it's very secure.
We might be out of luck. I will comment. Having worked in the past with a company that provides a specialized form of threat intelligence, not for industrial control. Yes, they had sort of a generic offering for everyone, and then at a higher price, an offering that says, we will put sensors in your environment and run that data through our engine to give you faster, more accurate alerts about the stuff you actually need to care about. It's not perfect, we can't catch everything, but certainly the difference between detecting a generic kind of attack and detecting what's happening to a particular organization at a point in time is, for some organizations, a really big difference. And I would have thought for those with big cyber physical systems, it would be a particularly critical additional layer of visibility. So I can certainly see the point.
Yeah, yeah, right.
The expansion, we're out of time. The expansion of the question was, I guess this means if it makes sense for Compot to be part of various other tools for IDS. Again, the tool does a different thing. So they're complementary tools. Can we go
right? Right. It's not like one size fits all, but if you don't, if you have, that's the reason why they come up with the XDR, right? The new generation of the EDR. The EDR is separate, and then the NDR is also separate, because there's so many network-related anomalous activity that an EDR could not detect, because it's an E, right, endpoint, and the NDR focuses on the network. So now they come up with this. Why don't we combine this? That's why they come up with the XDR. So if you have that one, but again, we're talking about ICS SCADA. If you deploy that one in ICS SCADA, I'm not sure if that is doable or something. Probably your control engineers will yell at you. Bonus if they have some kick on your butt, right? For sure, it will go down.
It's the usual problem. let's leave it at that. Our next speaker is supposedly in the room, but I can't see him at this moment. Art, thank you very much. And I look forward to hearing how you go with adoption and how you develop it next year.
All right, all right.
All the best. So, Duke and Mike, Art, yep, great. Duke, if you're in the room, can you please turn on your microphone and your camera? Duke Leto, who was at one point called Nocturnal Chital, but let's see him. Agent Duke Leto, please turn on your microphone and camera. Okay, for the benefit of those in the main hall, it seems that our next speaker is having trouble with his slides, so please stand by. Duke, if you're in the room, please unmute your mic and turn on your camera. Aha. have slides, but no Duke. Duke, if you're in the room, please unmute your mic and turn on your camera.
Hello.
Aha, Mr. Emerald Sponge. Welcome.
I am Mr. Emerald Sponge, the one and only, the one and only. I'm turning on my video is going to work, but my PDF broke the whole system. So I don't know.
I am completely astonished. I could not have predicted that that was going to happen. Excellent.
So
welcome to the show. May I do a quick intro for you before we get into your talk?
I'm an unknown character. What do you mean? There's history about me? The PDF has totally been ruined by the system. So I guess hopefully all the memes will carry the top because the words won't show up.
Okay,
it's privacy.
In that case, we are looking forward to a privacy-enhanced presentation from a man of mystery who may or may not be the developer of Hush.
Duke Lito, yes. Also, I think I have the record for longest time between FOSSASIA talks, which is 6 years. So the last talk I gave was 2015.
2015, wow.
Yeah, I talked about starting your own Git user group because I was a weirdo the first to start a Git user group. So I was like, I should tell people in Singapore about that. And then I just fell into a privacy hole, I guess, or something. I don't know.
Well, I think
basically, yeah.
Years between FOSSASIA talks, that you clearly are the record holder at this time.
I hope no one else beats me, but because I would have rather given talks in this time, but life got too busy. So I'm going to see if the whole system will crash if I try to go to the next slide.
Sure.
I don't even know what combinations of keys. Oh, I think it's that weird button. It's a very long lag as well. I have to hope and pray.
Please tell me there's no video in your slides.
There's no video. It's an 18 megabyte PDF that has crashed the whole big blue button system. It's rendering it like,
yeah,
I can't tell you. All these slides are written in LaTeX. Okay, so to see the damage that it's done to my slides it gets me.
It is important to have test cases that we didn't pick up early because you now get to be a test
I don't think that this is Eventye's problem either because the public, I uploaded the exact same file to the public side, and if you saw, it just took about a minute to render this slide. So let's, I guess, talk. You can see kind of, it says Magic Internet Money, private chat platform, store of privacy. And what do those words mean? Magic Internet Money is kind of a joke term, but that's what people in the Bitcoin world call this new digital money that we've created. And I think it's appropriate because it is magic internet money. Just like most people don't know how credit card processing backends work, and they don't know how, banks clear their debts at the end of the week. Like they just slide their card and the magic internet money works. So I like that term.
Let me step back and let you do your talk. You've got about 40 minutes. And then
I didn't. So Did the talk start, or are we started? Is this the talk?
It happens. We've got a bit of time, right? So you're scheduled for a 40-minute talk, but in fact, the next talk's at 8, so we've got a little bit of wiggle room. But
it's taking about 30 seconds to just go to the next slide, because I think maybe all of my meme images are. I don't know what I did to the system. But yeah. So
I am thrilled that we have a new test case. This is for Big Blue Button rather than for Vetye, but yeah.
Yeah, this is. And I even tried. So I can maximize the. Oh boy. Now I didn't move. Okay, so we're starting at the beginning now, or
yeah. Let me just step back and let you do your thing, and I'll be watching closely to see how well the technology
works. Text, yeah, something magical happened to the text. It's kind of funny. It looks like it's private, extremely private.
Very private. It's on brand.
Hieroglyphics. Okay.
We look forward to being wowed by your memes and, of course, your discussion, your talk.
I'm looking to educate and also entertain. I like both happening at the same time.
You are winning on both fronts. Take it away.
All right. So what is Hush? What is Hush? It's magic internet money, a private chat platform, and a store of privacy, which you may or may not be able to read. It's okay. And we launched our main net, we call it, kind of like what other people would call production. Like if you have a centralized web service that is on a few servers, and your most important live system usually is called production. That's what we call mainnet. It's a terminology that comes from Bitcoin, and that's like the main network versus the test network and stuff like that. So we launched in 2016, almost 5 years ago. We're kind of an old project in that sense. Many projects started much more recently to try to cash in on the craze of Bitcoin, but Hush has kind of been working on stuff for a very, very long time. And in internet years, right? 5 years. We have a global community all over the world. There's people, many countries, and as a testament to that, we have about 20 different languages. Our software is translated into about 20 different languages, and we can also render prices, like we can render the value of your Hush in over 40 different currencies. So that is a testament to, I guess, our internationalization, and we're very proud of that. And that's across multiple pieces of software, wallets and things. We'll have a little bit about that. So, oh wow, cool, my slide kind of worked. How is Hush like Bitcoin? Because, I think that's the easiest way for people to understand what Hush is that it's a grandchild of Bitcoin. It's not even a child, but it's a grandchild of Bitcoin, because there was a lot of innovation and things happening in privacy, but we can all trace everything back. That a lot of our code goes directly back to Satoshi, the person or group of people that invented Bitcoin. No one knows if it was a man or a woman or a group, so I prefer to say they, because I think that's more appropriate than assuming it was a man or a woman or even just one individual. And that image right there at the top of the screen, that's from the top of the Hush source code. So a lot of our files in our source code, the first line is copyright Satoshi. And that is our heritage. That's where we can trace things back to. I personally don't trust things that call themselves crypto coins that don't trace back their lineage to Satoshi. It's dicey. You have to be really good to not trace your heritage back to Satoshi, and that's okay. But most people, they try to create something better and different, and they don't even come close. So we build on the shoulders of giants, Satoshi. All these messed up words here gave some more details, but for instance, we have the same total supply as Bitcoin. Some of you might know Bitcoin has 21 million Bitcoins that will ever exist. Hush is the same, 21 million Bitcoin. We have no company and a decentralized community. So there is no Hush, just like there's no Bitcoin company. There are big companies based on Bitcoin, but there is no central company that controls Bitcoin. The same is true for Hush. There is no central company or even nonprofit or foundation or whatever other word you want to come up with. We're decentralized. We don't do that. And we do a lot of the same other tech stuff as Bitcoin. We mine with ASICs, we extend the Bitcoin protocol, and we like to say, Bitcoin is a store of value, kind of like gold or silver, and Hush is a store of privacy. That's how we're like Bitcoin. And I think it's important for people to know, where you come from, where your roots are. Now, how is Hush different? Obviously, Hush is not Bitcoin. Well, Hush is just like Bitcoin, but we have privacy. So this meme, the words are quite small. It says, "We were just fixing the leaks in Hell's Plumbing." And it actually has a Satoshi quote in there. There's a nice little bot on Twitter that will occasionally quote Satoshi. And he said, "The result is a distributed system with no single point of failure. Users hold the crypto keys to their own money and transact directly with each other with the help of the peer-to-peer network to check for double spending." So Bitcoin, Satoshi solved the problem of a global financial network that's decentralized. And the big problem in that is double spending. That means, you can't spend the same dollar twice in your pocket kind of thing. It's a very intuitive idea with paper money and coins, but it becomes very problematic with digital money. It's one of the biggest problems. So we like to talk about Alice and Bob in cryptography and especially Bitcoin, Hush a lot. So Alice sends Bob money. Now in Hush, Alice's address is private, Bob's address is private, the amount that was sent is private, and then additional on Hush blockchain, the encrypted memo field is private too. You don't know if it was used or not. You don't know if additional encrypted data was sent. And then even another thing that Hush has is you don't even know how many recipients it was sent to. There's like a confusion going on there at the protocol level that you cannot tell if Alice sent it to 1 Bob or 5 Bobs or 7 Bobs and something like that. That gives you even more privacy because you can't even tell how many people were being communicated with. And then we got this nice idea of plausible deniability. People, advanced privacy, security, people really like that stuff. And it's just another level of privacy in that less metadata is leaked. Like, did Alice even send a message to Bob? How do you know? How do you know Alice didn't just send a message to Charlie? There's all these layers of privacy start adding to each other, and you get this thing of plausible deniability for certain use cases and certain things. There's not. It's very hard to get perfect plausible deniability, and we can talk a little bit more about that later. And then another difference is Hush is a little bit faster. We have a 75-second block time instead of 10 minutes. And that's just not really much to do with privacy. But if you want to get something done, if you want to send a message to someone, or even if you want to buy, a piece of candy or something with Hush, who wants to wait 10 minutes for that? No one. So here we go to the memes, though. So Bitcoiners pay extra for privacy. That's the thing that really sets Hush apart, is that we have privacy at the protocol level. We have privacy at the lowest level. Applications don't even need to try to add it. It's already at the protocol level. And this is one of our, I would say, friendly competitors, Samurai Wallet. If you are going to use Bitcoin, I actually do recommend using the software from this group of open source free software weirdos, Samurai Wallet, and they add as much privacy to Bitcoin as you can. And to do that, you have to, it's called mixing your coins with other people, and you pay money to do it, and it takes time, and sometimes it doesn't work. So it's really like a impossible task that they're trying, and but they're the ones that do it the best. And if you are going to use Bitcoin, I do recommend using Samurai Wallet. It's the best you can do with Bitcoin in terms of privacy that I've seen. So Onward and upward. Survey says, oh boy, those are some messed up words. How is Hush different? You must use the privacy. It's no longer optional. So we have the meme to send in the clowns. So everyone must use the privacy. There's no choice, okay? So best practices are automated. You know, you don't have to think about what you're doing with the privacy at the low level. Hush is doing a lot of advanced stuff. So for instance, sending to multiple addresses all the time, only allowing you to use Z addresses. And then this is P2P encryption is mandatory, and it's the very latest TLS 1.3 for all the nerds that know about, you know, the little green lock in your browser and all that stuff. Hush uses that stuff and forces all nodes to use it. There's no options. You can't go and say, oh, I want to use this old outdated TLS 1.2 or whatever. Nope. So we're kind of a bleeding edge adopter of privacy practices because all of our users need to constantly upgrade to stay on the right blockchain, essentially. So we don't really need to support software from years ago. Like it's a, you know, we don't want to alienate users, but because things move so fast, we are a bleeding edge, you know, adopter of privacy. And that's why you see like so many things that we're doing that other projects that have to support code from 10, 20 years ago, they just can't do. So if you're a web browser, you need to allow someone to connect with a really old TLS implementation, right? So they allow that, but we don't. So it's a whole new world of privacy. Now, down here, we've got how much money was sent, how many people received funds, wasn't encrypted additional information sent, and herd immunity to metadata attacks. So when everyone in your village or everyone in your town or everyone in your whatever unit is using privacy practices automated by default, you get a herd immunity to metadata attacks. All of a sudden, you have to really go out of your way to mess up your privacy to have metadata attack work. Instead of on Bitcoin right now or most crypto coins, you have to be an expert and still it might not be good enough. So here's my zombie meme. Zombie mode's filling up, vaccinations are happening. This is from Z Nation, great show. Herd immunity is a network-wide resistance to metadata attacks. So Seach is a name of one of our things that I came up with as a defense for Hush, and it's one of the reasons why we're unique. And one thing it does is non-determinism. It adds randomness to how certain things work, and that means if you're going to try to predict or simulate or get information out of other nodes, it ruins that for you. It gives you a sad day. So another way to think of it is your neighbor isn't doxing you all day. Like imagine if you wanted to just, you know, have a little privacy, but then your neighbor just hung out their window every day videotaping you. Like that's not helping your privacy, right? So that's a lot what like Bitcoin. Using Bitcoin is kind of like walking through the street and everyone's got a video camera on you. Even though you could have good privacy yourself, the whole system is kind of set up against you. And that's how it has to work to verify things. So you're responsible for your privacy, not others. You know, that's another way to put it. If other systems are set up, and I'll talk a little bit more about them, like Monero is the biggest privacy coin used right now. I would say most popular, biggest. You have to be a very good expert and also hope that people don't mess up your privacy. And that's not something that I really like. So in Hush, privacy increases with time and a non-set goes up. Now this is fascinating, this bug, because if you see this character is perfectly rendered and all the rest aren't, and this is a math symbol. So that's a good test case for Roland and the Eventia people. So I'm a huge math person. I was a math PhD student, and then I decided that I didn't want to do that, and I just became a developer instead. I'm not sure if that was a great idea, but here I am. So I am a mathematician in a coder's body, and I like math stuff, and I put that in my code. So Monero, it has its like privacy set, the set of privacy that you're getting. Sometimes we call this a non-set or for anonymity set. Every transaction has its own. So that means you're just in this, you got this like small group of people that you're hiding, and maybe it's like somewhere between, it's around 100 it comes out to be based on their current numbers. They can tweak that, but they chose that so it wouldn't be too slow, but also it degrades over time. Your privacy decreases over time. As people that were hiding in the same set as you mess up or do dumb stuff, or just, you know, outright help, you know, remove your privacy, it can only go down. So with Hush, it's because we have a totally different kind of math and protocol going on. Ours is network wide. That means every time you make a transaction, you get added to the set of all of a huge network wide pool of privacy. So that's very different. And here's another math symbol perfectly rendered, much greater than. So the Hush privacy set is much greater than the Zcash privacy set. That's another, you know, related coin that Hush inherits a lot of math. So we're going to talk a lot about them too. So, wow, that's a lot of messed up text on that slide. Hopefully there's a meme on the next slide. I have no idea. Oh, thankfully a meme. Okay, so Zcash. They invented new zeros knowledge math, but they don't use it. How funny is that? Like I actually made this hilarious clown meme, and it offended some Zcash, you know, scientists so much that they told me it was inappropriate and they unfollowed me. So, you know, that's the way I vibe, I guess. But, you know, how weird is it to invent some crazy new thing but then not use it? It's a little weird. So I'll explain the meme a little bit here. This is a famous programming meme as well. I think it was originally maybe a C++ meme or something, I don't know. But you know, they designed a new elliptic curve using burrito narrated construction. This is some crazy math stuff. And then they implemented a new zero knowledge math and efficient Rust code with memory safety guarantees. I mean, if you're a programmer or a mathematician right now, you're getting very happy and excited. And then optimizes the shielded sapling addresses to be fast and use very little RAM. I mean, you get so excited. And then they allow transparent addresses as the default transaction type. And transparent addresses are what we call Bitcoin addresses in this privacy world. So it's a very bizarre thing where you invent new math from the future and you write this amazing code and then you don't use it. So Hush benefited from that because we use it and we make everybody use it. You don't get another option. So here we go. We're going to talk about a little math. I promise I won't have any math equations, but zero knowledge is a weird term. I think probably to people, they're like, what is this weird zero knowledge math thing? Is it even real? Here is an intuitive example that comes from the original example. The original was a cave, was a man going through a complex cave, I think. And basically, there's a way to prove that you get out the other side without telling this person exactly how you got through. And that's what this example is. This uses a little pin code in a door and then an Alice and a Bob. But you can basically think that there's a way for this person to prove they got through by coming out either side without telling this person exactly how. And instead of a pin code, you could think of, you know, a very complex set of cave passages that only, you know, someone would have to memorize and something like that. So that's kind of what a zero knowledge proof is. That's if you want to get more detail, it gets very complex very soon. But they were invented in 1985, very recently actually, for math, right? I mean, most math was invented thousands of years ago. This math was invented in 1985, right? So it only became usable in the last 5 years. Basically, when Hush was launched, that's when this math started getting actually usable on a computer, that you could actually like do it, not just an academic theory exercise. So the flavor of zero knowledge math that we use is called ZK SNARKs. That looks real bad on the screen. And that stands for some weird stuff: zero knowledge, distinct, non-interactive arguments of knowledge. The non-interactive part's really important, because the first zero knowledge math from 1985, it was interactive. And that means Alice and Bob both have to be online at the same time to prove things. And that's not really how a lot of things want to work. You know, they want to be able to, Alice says something and then the other person proves it, and they can do it at any time. So ZK SNARKs with the non-interactive, that was the huge innovation here, is that Alice and Bob can be offline. They kind of generate something almost like, you know, generate a private key or a public key. You could think of a proof as something like a SSH key, maybe even. It's this a data set that proves something is true or false. So you can prove X is true without saying anything about X. That's the huge innovation here. That's what allows Alice to send money to Bob and not tell the whole world exactly how much was sent. So very fancy math involving elliptic curves, fields, and group theory is involved. If you're a mathematician, then you can get super into that stuff, but it gets very advanced. It's fun stuff though. I studied a different kind of math, so it's actually new to me too. Wow, this slide looks pretty bad. So ZK SNARKs, they're a new atom for building privacy software. So one flavor is the Zcash protocol built on these ZK SNARKs. There's other things called Starks, and you know, academics, once one academic has a good idea, you know, everyone's coming up with a new flavor and thing and stuff. So there's actually, like, I think close to 100 different types of just ZK SNARKs. And then who knows how many types of zero knowledge proofs. There's an immense amount. It's exploded with research. So Hush uses the same lowest level, we call them cryptographic primitives, like the very lowest level kind of math functions, hash functions and stuff like that. We use the same things as Zcash protocol, but we enforce that they're used. We don't let people turn them off. You have to use the best version, the latest version. We deleted all the old bad versions, and we keep everyone in one pool. And that is for very good reason, because if you have people hiding in two different pools, then you have half as much privacy. You want more people in the group that you're hiding with, not less. If you hide in a group of two people, that's not very, very efficient hiding now, is it? So next slide. Oh, awesome. We got some good graphics. So Seach is something I wrote, which is a defense against an attack that someone released. Kind of an anonymous person came into a chat room and said, hey, I think that Zcash protocol and all privacy coins can be attacked by this new method. And a lot of developers from a lot of different coins talked to this person for many weeks, and everyone pretty much agreed. And then I actually went and wrote a defense against it. So I'm a weirdo that, you know, takes things seriously like that. And attackingzcash.com is that site you can go to read it. It's a 15-page white paper. It's very blockchain analysis, basically. If you're very interested from either perspective, from, you know, the attacker or the defender perspective, if you're into blockchain analysis, then you probably want to read that paper, because it is the latest bleeding edge in how privacy coins are responding to blockchain analysis. So here's an example. This is Zcash Z to Z transaction, and also it's optional. So here's the thing. On Zcash, it's optional to even use the privacy, the Z we call it. So if you happen to be one of the few percent of people that decide to use it, this is kind of how your privacy looks as a graph. You know, we get developers like me and nerds, we like graph theory, right? And blockchain analysis is a huge amount of of graphs. So here you have Alice sending stuff to Bob, and there's two outputs here, and sends something to Charlie, and there's two outputs. That's how Zcash works. It hides all the details, but you can still tell that there was two outputs. It doesn't hide this number of like receivers. So, and basically this attack that was told to us said, oh, this is really bad. There's new ways to use this information that you really shouldn't tell. Like, you can immediately tell that Alice did not send 3 people, a message here. It's impossible. And she didn't really even send 2. This is 1, and then she got and change or something like that. It tells the story too much already. So I decided to change things and add some weird stuff. So as you can see here, things look kind of different. This is, 1 transaction here, and then there's 8 outputs. So if Alice happened to be sending to up to 8 people at once, it will look like every other transaction. If Alice was sending to 7 people, it would randomly add another one to make it look like everyone else, and onward. So this makes it so you cannot tell if Alice was only sending to 1 or up to 8 people at once. That gives you this little cloud of privacy where all these attacks now, a lot of the things and assumptions and data that these new attacks were using go out the window. So, and another thing is that we randomly place, like, let's say Alice was only sending to 1 person here. It's never like the 1st or the 8th or whatever, or the 4th. It's randomly placed in there, and that gives us another bit of metadata protection, because anything that can be predicted can be used against you. It's like a blockchain analysis. If it can predict that your code or your stuff is going to work a certain way, it can use that data against you. So we remove any of that information leakage or metadata leakage, you might call it. So this said an underground fortress for every transaction. So that's what the word siege means, underground fortress. So next slide, I'm probably running out of time. Siege was translated to
7 minutes normally.
7 minutes in or 7 minutes left? Wow.
But you can go like 3 or 4 minutes. It's fine. But not 20, right?
I have 62 slides, so I'm going to start talking faster. All right. So we've got Siege is a paper I wrote, but it was recently translated into Russian. If you want to translate it to your language, then please contact us. I'm going to start talking faster now. The slides take so long to go to the next slide. Okay, if you're not paying for your privacy, you don't have any. All right, so this is a funny dad meme. I'm just going to go to the next slide. So we have an Explorer. We have a very advanced blockchain Explorer. It doesn't dox you. It doesn't use JavaScript, doesn't use images. You can do it on Tor. I'm sure you'll go check it out if you're into that stuff. So how does Hush build upon Bitcoin? We're at layer 2. So other things at layer 2 are Lightning Network, the BISC decentralized exchange. We don't compete with Bitcoin. We build on top of it. So that's a very important difference. Some projects try to compete. Hush Chat, you can think of as Signal protocol on a blockchain, and it's an encrypted chat messaging protocol and decentralized platform. That's a little GUI screenshot there from our wallet. I'll get to talking. Okay, so this slide might actually be interesting to people. Lots of people use all these things, right? Telegram, WhatsApp, Threema, Wicker, Signal, and obviously very few people use Hush now, but look, it's got all the green check boxes. We actually do stuff that people want. We're free software, GPL v3, client and server. Now, some people might get very offended by this little red box, but you know what? Signal server, they haven't updated their GitHub in a year. And people have definitely shown that there's new API methods that don't exist on GitHub that definitely are running on people's Signal. So you go do the math on whether, that's where the back doors are, right? So yeah, Hush beats everything else if you actually look at our stuff, our tech low-level tech is very, very good. Signal's centralized, we're decentralized. They have phone numbers, we have shielded addresses, they have a closed source server, we got GPL v3, and then obviously this says Uncle Sam backdoors, and this says question mark backdoors. If you know of backdoors in Hush and HushTech, please let me know. Who profits from surveillance? You know, all the companies, Microsoft, Facebook, Apple, blah, 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 governments, militaries, and advertising companies. Now, this next slide, oh, there you go. Backdoors are everywhere, right? If you disagree backdoors are everywhere, you probably get paid to cover up backdoors. You wouldn't believe how many people on Twitter that this angers. So Signal, it's got the best protocol, but it's backdoored by the USA. WhatsApp, backdoored by the USA. Wicker, backdoored by the USA. Threema, backdoored by the USA. Telegram, well, that's Russia. WeChat, obviously that's China. And then Zoom and Keybase, probably USA and China have backdoors in that. So have fun with all that info. And you know, it's just a small backdoor, just a tiny, tiny, tiny backdoor. It's okay, right? So nextly, we have who spies on you. It depends on your GPS coordinates. It's a lot of people, and we call it alphabet soup. Wow, this is very fun. So we've got Australia, Canada, you know, NSA is from the US, Russia has the FSB. You know, this slide is really hilarious now because you can't see any of it. You'll be able to download this slide, hopefully.
The irony is delicious. You are not allowed to know the names of the people who watch everything you do.
Yep, and then just in case you didn't recognize, the KGB was renamed to the FSB. And I just want to say thank you to the FSB so that the MIA Paper Plane song, you know, the lyric still rhymes. I've got more records than the KGB FSB. So it's all good. It's the same exact people. They just changed their name. So what else we got here? Surveillance devices. Everything's a surveillance device. And, you know, everything from fax machines to email to web browsers, to web servers, to voice assistants, it's all a surveillance device. If you understand it in that light, then everything makes a lot more sense. So one thing that I think that people don't realize is that privacy is a human right that was written down, Article 12, the Universal Declaration of Human Rights. No one shall be subjected to arbitrary interference with their privacy, ... It seems a little crazy, right? It's written down. The UN thought it was a good idea. A lot of countries say that it's a good idea, but they don't actually sign it into law. So we'll move on. Now, wow, this slide really got trashed. So Silicon Valley was started by these two professors that basically were the preferred electronic warfare contractor for the US military. Their students invented the best new spy everything, radar jamming, spy balloons, you know, measuring signals bounced off the moon to find Russian radar jammers. I mean, very, very advanced stuff. Their PhDs were top secret, okay? Those students, they went to form Silicon Valley. They literally created the very first companies that were, 1957 was the first venture-backed company. It was called Fairchild Semiconductor. That's when Silicon Valley started. It was to surveil. It was part of the Cold War, which was an electronic war. So Silicon Valley has always been Surveillance Valley from the very beginning. It was just rebranded as social media or whatever. And there's an awesome website here, steveblank.com/secret history, has a bajillion slides and, you know, just amazing detail about that. But it's all there. It's all public info. It's just kind of been rebranded. So Hush is privacy. People had privacy by default 100 years ago, and now we have surveillance by default. So I think this was taken, I think someone took this in Paris, I think, very recently. In the future, everyone will want to be anonymous for 15 minutes. And it's a play on the Andy Warhol quote of everyone wanting to be famous for 15 minutes. But it's the tides are turning, and what, you know, people are surveilled so highly now that they just want a little bit of privacy. So Hush delivers privacy in a world of surveillance. That, you know, it's very clear that this is the world that we're going towards. This is what's happening, and if you don't learn about your own privacy and how to have some, you're not going to have any. It's not profitable for companies. So the data they want is everything. You know, you can kind of see GPS, IMEI, that's your cell phone unique IDs, IP address, your browser details. You know, everyone can imagine what all these things say, facial scans, voice recordings. They want all the data. That data is how they can profit forever. You know, they mine it, they sell it to other companies, they sell it back to you. So you need to trust your hardware and your software. So that's a big thing. This is from a funny show that I can't remember, but it was so perfect. So you need to trust the hardware and the software. So I was so happy to see that Bunny gave a talk at this FOSSASIA just a few days ago, talking about precursor. And, you know, trustable hardware plus zero knowledge math privacy is a win. That when you add up all that stuff, that's an immense amount of privacy. And they're actually doing stuff with plausible deniability at the hardware level and like very, very advanced, cool stuff. So that's what Hush is looking at in terms of trying to put our software on trusted hardware. We do have a project called HushDroid. You can run, you know, we have Android apps and stuff like that, but man, Android they've got to deal with a lot of backdoors and just kind of hope. So having trusted hardware is amazing. So I'm just gonna skip a little bit of this stuff because I think it's too detailed. But we have privacy by default, and we've ported a lot of features and fixes from Bitcoin directly to Hush as well. We only use the most bleeding edge TLS algorithms, one from the NSA and one from DJB, who is a prominent anti-NSA researcher. So we kind of, you know, didn't want to just use what's considered the best because, you know, the NSA makes good stuff, but they also put backdoors for themselves in there. So we mix together kind of the best of both worlds, and we hope that there isn't a new Heartbleed vuln because we deleted OpenSSL from our code. So we use something called Wolf SSL, and you know, we do a lot of bleeding edge stuff that other projects can't. So this Erebus attack I wanted to mention because I ported this recently to Hush, and this is from research from National University of Singapore. I don't feel like I can pronounce these people's names correctly, and I don't want to do a horrible job, but Moi Tran is the main researcher, I think, and it comes from University of Singapore, and it was a very cool attack against Bitcoin that that I took their ideas and Hush is protected from it. So it's a lot of cool bleeding edge stuff. We get attacked all the time. Like a lot of people, you know, there's a lot of competing privacy coins and crypto coins, and they, you know, it's kind of like a bunch of startups that see that there's a bunch of competitors that can steal their spotlight. So there's a lot of attacks and things like that. So there's been many attacks over the years, and Hush basically evolves from each attack, and we get better. So one thing is called delayed proof of work, and that basically allows us to piggyback onto Bitcoin. And if someone wants to attack Hush, they need to attack Bitcoin as well. We inject our proof of work into Bitcoin proof of work, and basically we get this chain of proof of work, and that means that we're protected, which is cool. So Hush and Tor. If you're not familiar with Tor, that's kind of like the Tor browser or various operating systems that let you basically hide your IP address. You get an IP address that's kind of randomly chosen from the internet. And this Tor network was created and invented by the U.S. military. People should know that. There's other ones that are, there's one from France called I2P, and I think there's some others. But Tor is basically the most widely used, and a lot of, you need, just like Hush, you need a lot of people to be using something to get privacy features from it. So it's evolving now and being attacked, and Hush is doing the latest Tor stuff. Basically, we're merging in the latest Tor stuff from Bitcoin, and that's fun. I thought that this was a funny meme, spy versus spy. Zyatt or OPSEC, I'm going to pass because that's a nerdy Hush user thing already. And if you really want to know about Zyatt or OPSEC, then you can check out the slides. But basically, there's still more work to be done. There's still, you know, things aren't perfect. Obviously, things change really fast. So, you know, you do have to learn. You know, if you have good operational security, you can get more privacy. So, Hush recently, you know, from this attack from the researchers from Singapore, we can classify our peers in not only by their IP address, but like their ASN, their autonomous system number. That's at a layer below IP addresses. So we can actually say like, oh, there's too many nodes. This is an attack because a whole bunch of nodes from this one little part of the internet is trying to control what we see and what we think. So that's actually an attack at the peer-to-peer layer of Bitcoin. So this is just a funny meme. It shows like Zcash only has 6% of their funds in using the private addresses after 4 years, over 4 years. And Hush just recently, a few months ago, made it mandatory, and we have 41% already. So it just shows that just making something the default automated thing that people don't have to choose it, it's the only way to go. You can't get privacy otherwise. So Zcash is very confused about privacy. They're academics. They're very smart. They invent good math, but then they don't know how to make people use it, or you know, they're concerned with keeping their money machine going. So it's very hard to understand something when you get paid to not understand it, right? That's what Zcash developers, that's their problem. So this just makes fun of the fact that we have these big companies now, CipherTrace and Chainalysis. These are companies worth billions of dollars now, and they support Zcash, and they don't yet support Hush. And if they ever do, they're going to have a really fun time with it. This shows a little screen where you can actually spin up your own Hush-like network. So Hush is all about giving people their own freedom and keys to do whatever. So we want people to make their own and run their own. And if you don't want to do things the way the Hush mainnet does, then here it is. There's a website, shows you how to do it. You can copy and paste that. And obviously you're going to need to learn a little bit of stuff, but we're not trying to lock people into our system. Other coins do not let you do that. They want everyone to be locked in.
In a minute or two, please.
Okay, we're getting close. Use cases: lawyer-client secure chat, so you can actually enforce client-lawyer privilege at the protocol level. Got a censored journalist use case, so you can release data later. You can put your will in an encrypted global backup kind of thing if someone's going to try to censor your will. We've got international diplomacy too. This is the last use case that I kind of wanted to show, is that international diplomacy requires privacy. So for instance, China might want to use Hush technology in a way that they create their own chain, and it requires national ID and biometrics and VPN, and that's for foreign diplomats outside of China to talk back over, potentially malicious internet. Then you got maybe Russia, they use technology different. They might want to have a completely isolated thing that doesn't connect to the main network at all, and that, you have to be in a secure location and use it for different reasons. And then, the USA might want to use it more like Tor, where they're going to attack us and make sure we're really good in case they need to use us like Tor, So there's a lot of use cases more than just Alice sending Bob money. And then this last use case, I think is, I think it's good to know what you would do in certain situations. So in the case where the United States, Russia, and China want to do a cyber attack against Singapore, Singapore could use Hush and Tor together to contact other countries or the UN or whoever they needed to over a very malicious internet. Because if those three countries decide to cyber attack you, they own most of the internet cables on the bottom of the ocean. They own most of the satellites. You're going to have a hard time. So you need technology to level the playing field. So we find bugs constantly. So Hush finds lots of bugs. We've talked about some of those. So this is some of our software. I'll just very quickly go through. This is our light wallet. So you see there's a little bit of our chat GUI in there. We're getting pretty close. Here's our paper wallet. So you can kind of print it out and be offline, and that or idea of a cold wallet. There's a little Android interface for you. So that's what it looks like using Silent Dragon Android. We're almost to the end of these slides. I'm gonna go to the next meme here. You can get Hush mostly by mining it or joining our community. It's not really easy to buy Hush on a centralized exchange. A lot of them don't even support privacy coins anymore. So I was suspended from GitHub. I don't know exactly why, they won't even tell me, but they are a censorship platform, and you probably should stop using GitHub for all your projects. And I say that as, you know, the person who started the world's first Git user group. So I believe we're at the end here. So
a call to action.
Here is our join the Hush community. Depending, you know, no matter what kind of hacker you are, I don't even know how to classify all of these. I didn't make this graphic, but this little QR code will get you into the main Hush Telegram, and that's basically it. I think I just, oh yeah, there's this thing. We have masks now and stuff. And then this is the last slide. So if you are a developer, if any of the stuff I said is interesting to you and you know about technical stuff, please join our Telegram. And I guess it's time for questions or something.
Yes, indeed. It's very cool. And thank you. I'll let you run a bit long. We've really got about 3 minutes before I need to bring the next.
No worries. No worries. So let's see what the internet trolls can bring us.
The first one is spectacular. What do you think of GNU Taylor? And a better answer might be, what problem do you solve that GNU Taylor doesn't solve for the benefit of
I remember using, actually, is it still going, Nutella? If so, that's awesome. I
haven't paid attention, but yeah, it's
I think the 90s were maybe the last time I still used it. So Nutella is more as was something I think from before Napster. So that's solving a problem of sharing large files distributed.
No. GNU Taylor is an entirely different project. It's a payment system that ostensibly protects the privacy of buyers, but not of sellers. So it's I think I've heard of. Okay, it's a totally different thing. Okay. Let me ask the one question I'd love to get an answer to with the 2 minutes available, just to understand where Hush's dependencies are. How is this is one of the questions that have been asked. How is the project funded?
So 10% of all blocks mined, 10% of those funds go to the Hush developers. Originally it was zero for actually the first 2.5 to 3 years, there was no block funding thing. The original developers of Hush created a little bit of Hush for themselves. So now it's a 10% of every block goes to basically, you know, we have server costs and things like that. So, but it's just purely in our blockchain. 10% of every Hush block goes to fund the project, and then 90% goes to whoever mines it. And we have a active mining community, I would say. We're compatible. So for instance, there's a lot of miners out there that mine Zcash or other coins. We're compatible with their hardware. So we're an option for those miners to mine. So we fit into a larger ecosystem, I guess, of mining as well. I don't know. Yeah. So funding, I mean, it's not very much.
It's a solid answer, and it's well integrated. There's no obvious conflict there, apart from the general.
Yeah, I mean, it's the people. Yeah, 10%, and I'll tell you, I was very against that for the first few years I was involved with Hush, because that was seen as like a tax, and miners should get 100%, and that actually led to the project not having any funds to just buy servers and bandwidth. You know, when you get a bandwidth bill for $500 in 1 month from Amazon, then you're really saying, you know, who's paying this? You know. So yeah, I can say that I changed my stance, and I was against that 10%, and then people asked me to add it to make the project sustainable and have some funds, and because you know, yeah, people, it's a currency to pay people, and so yeah.
Being willing to adjust your approach is critical, and I think that's.
I've been wrong many times in life. If you can't admit to being wrong, I think you're pretty much a liar.
Yes. Look, I've got to call time because we're down to 4 minutes, and I've got to get Jens in. Jens, if you're around, please turn on your camera and your microphone.
Thank you. I just want to say, Roland, thank you. The messed up text is amazing, and somehow it's the math mode. The math mode gets rendered correctly. I should have just wrote only in math.
Just math would be fantastic. So what I'd suggest, to please hang around. There are other questions in the shared notes. If you'd consider perhaps brief answers to those questions just through text.
Yep, I will do that. Thank you for everyone for watching. Thanks.
Thanks, Duke. Jens, hello. Please unmute.
Hello.
So presentation. Give me a moment to do some judo here with
Rush.
the button. Well, no, because we've got a problem if we do things out of order. So let's not skip the step. We do that, and then I give you the presenter. Now, presentation material. Are you presenting a slide deck, videos, a screen share?
I am presenting a slide deck, which I have to upload.
We would encourage it, although as Duke has demonstrated, it's possible for that to go terribly wrong.
I saw that. Yes, it was very interesting to see that. So hang on, it's upload.
Your sound is a little bit choppy.
But my sound is a little choppy. That sounds bad. Can you hear me?
Okay,
now?
it's okay.
I'm uploading
maybe when I shut up, it'll be fine. Okay, so you up.
I don't know.
Beautiful, and there's no video in your deck, right? It's just slides.
There's no video. No, I thought about pre-recording, but I couldn't.
No,
and now I have a cold, so my voice sounds a bit rough. So
it would have been fine.
Let's see how it goes.
We just need to use a different mechanism for video because the screen share doesn't cope very well with video. Okay.
No, this is all I have.
In that case, let us just stand by for 2 minutes. We'll start you on the hour. At that point, I will introduce you and then hand the floor to you. You have 40 minutes for your presentation and Q&A once I complete your intro.
Hope it works, yeah.
Indeed. Your fonts look better.
My fonts look better. That's a big improvement. I have to say. I was trying to read the other slides, but yeah, I know. I mean, things can always go wrong now, right?
This is a live show.
Yep. The last thing I did was at FOSDEM, where the videos were pre-recorded, but unfortunately I was very early in the morning, so they hadn't really got out all the issues with the system yet. And for a while, we were very happy that the video was pre-recorded because otherwise nothing would have happened.
It's a really tricky trade-off because on the one hand, all kinds of problems get fixed if it's recorded in advance. On the other hand, like it's a conference, not a television station.
Yeah, it's not just that, but also you speak differently when you have at least a feeling of an audience, right? I mean, I remember starting that video 5 times.
So I did one for OSI State of the Source last year, and realistically, I did about 8 or 9 full takes. It's a totally different experience to do it on your own than having an audience. So I accept that.
Full takes, luckily I only did but the starts, like I did like 10 starts per take or something for like 20 seconds. Not long, no, but enough to throw me off track. And let's see how this one goes.
Yes, indeed. So everyone, welcome back, and I hope you have recovered from the mind-altering experience of Duke's talk. Jens Finkhauser, is that correct?
Finkhauser, yeah, but I'm used to
wonderful
other pronunciations.
He's a software professional, architect, founder, and established FOSS developer. His work spans around 2 decades and most of the internet stack, with a particular focus on security and networking protocol design and implementation. We started the Interpeer project with the intent of bringing this experience, which is to say bringing the human factor, back into the next evolution of the internet. He's adopted Bavaria as his home and lives there with his wife, 2 children, and a tortoise. Jens, tell us about designing a human-centric next generation internet.
Yeah, it's a big title, right? I'm not aiming low. Let's put it that way. Yeah, so let's just I don't know what let's get started. Just I said this just now a little bit when we were waiting for the talk to start. I did a similar talk at FOSSASIA. I thought I'd put the link here because the timing at FOSSASIA was very different. I didn't quite have not quite the same slide. So if you feel confused about something here, hopefully the other talk will help you, or vice versa. And just in terms of background, I have experience with going back quite a while with streaming live video over peer-to-peer networks, and a lot of what I'm doing here is sort of based around that experience. Button. See, already live makes mistakes. There you go. The Interpeer project is funded. It's not very well funded, but I wanted to get this out first. It's funded by NF as part of the NGI0 project. I said this in the last talk. I want to say it again. If you have any spare money sitting around for development in Europe, give it to NLNet. They will make sure that it goes to worthwhile projects. I'm also working as a part-time researcher at NEY Technologies, and that's interesting somewhat because there I'm working on drone projects, EU drone projects, I list them here, and in those projects we're working on developing reliable communication stacks. And while that work isn't quite the same as what we're doing here in the project, there's enough conceptual overlap, right? That I cannot call them sponsors of the project, but they let me work in a very similar domain with a lot of insights gained, and I can transfer from one to the other. So I like to list them as sort of quasi sponsors, or however you want to put it. Okay, so one of the bigger problems I have with this project is trying to explain why am I doing anything? What's the purpose of this? What's the problem you're trying to solve? It's very hard to even put into a few words unless you look at what most people are currently thinking of the internet as being. And of course, we all know that the internet and the World Wide Web are two different things, but for most practical purposes, when you do something on the internet nowadays, you use the web. And it's become so commonplace that nowadays, as a developer, if you have a that somehow involves networking, what do? You pick up a HTTP server and code something in whatever Node or whatever it is you're using, and you pick up a web client library, and then you try to connect the two, and that's your level of network programming. Not everybody, of course. So I think it's worthwhile at the web architecture, and that basically means the REST. Hang on. Here's the button. So I want to bring you back to what REST means. And when I say what REST means, meanings change over time. It meant a very particular thing at some point in time, and by now it means something else. The term comes from Roy Fielding's dissertation. He's written this as a, well, okay, it was his dissertation, but also he's written it as a sum of all the design, architectural design thoughts that went into standardizing HTTP. Before 96, HTTP had no standard. 0.9 is pretty much just writing down what people were doing rather than any, good effort at standardizations. And then with HTTP1, they made a few distinct changes to bring some architectural thought into the whole thing. So that makes sense. And then in 1.1, basically expanded on this. And if you look at the history, which is not really that important right now, but we lived with HTTP 1.1 until relatively recently. There was nothing for almost, well, 4 years basically. There was no development here. And one of the important things to understand about the dissertation that he is that it's not actually about what people tend to think about REST right now. When you talk about REST right now, you think about some sort of framework that lets you map HTTP methods and URLs to some kind of function in your code. And it tends to be the case that you try to map, that these frameworks map the HTTP methods to some CRUD thing, create, read, update, delete. But that's not at all what REST is about, or was about in the dissertation. However you want to look at it, right? I'm thinking of the definition that Fielding had as the leading one and the new one being some sort of distortion, but it's totally okay if you think of it the other way around. Most of the dissertation is actually revolving around how to architecture a world-scale network, and in particular a world-scale hypermedia network. And it goes about by examining different architectural styles and basically the REST as an architectural style that should help scale the web into the future. It also concludes that what HTTP does is not exactly what REST should do, but that's a separate thing, really. Read the paper. If you have that dissertation, if you have the time to do it, please do. It's gonna be interesting, if you haven't already. So the architectural principles that REST sort of derives after all of this are these here. I want to go through them. They're very important to understand for the rest of the talk. One is to separate the client and the server. Really, this is in contrast. You have to imagine this in contrast to something like CORBA or COM, or what used to be around at the time, or SOAP later, where you had a kind of interface description and you generated client and server code from it. That tightly couples client and server, and that's something that REST wants to break up. And the way to do is to have more fundamental request and response types, if that makes sense, right? That's why we have these methods of get and put and so forth, because they're very fundamental principles. The second thing is having a uniform interface. Again, this ties into the same thing. There's a very uniform interface to the interaction between the client and server. We have things like a get request, like a put request, or whatever. There's no real deviation to that from one server to the other. A very interesting point that gets most often, in my opinion, if you look at REST as the truth that you should follow, is that REST servers should be stateless. And what that means is that each request should contain absolutely all information for the server to process it. It doesn't mean that the server can't keep data around. The difference between data and state is basically something tied to the user, like a session or something like that. That's not really part of the architectural principles of REST. And it must be cacheable. They all tie together, right? I mean, once you have stateless requests, then it becomes much easier. The response is cached because they don't depend on any state that the cache needs to keep. REST wanted a layered system, so one where a proxy can pretend to be the interface that you're interacting with, and how many servers in the backend there are to fulfill the request you don't know about, and that lets each sort of entry point into the system decide by itself how to achieve the scale that's necessary for it. And finally, there's a principle of code on demand. Now, the paper is old, so speaks about applets. Nowadays, we have client-side JavaScript. That's what's meant as code on demand, right? You request something from excuse me, from a server, you get code back in return, and this code then does something. The idea here is that excuse me, the idea here is that you don't have all the code ready in the browser to interpret every potential resource that a server can send. And so you have to update the browser. And how do you do that? Well, you do it by sending code over that does the interpretation for you. So those are the principles that the REST architecture should follow. And as you can probably see, the web is currently doing much of this, at least on an architectural level. Okay, so this I can go through more quickly, but REST also lists a number of elements that are part of the architecture. So you have data, which is the information you store and process, resources or resource identifiers, the URLs basically. But it also is clear that what you send in each request or what you return as a response doesn't actually have to be the data itself. Rather, it's representation data. So you can think of it as a particular kind of view into the data in a particular format, rather than the raw data itself. And then connectors such as the client and so forth. So REST is called representational state transfer because you transfer representations of data and state. That's really it. The server can store data in a form that's completely opaque to the clients, right? Clients don't need to know at all how the server has the data because they only see the representations. And technically speaking, the server is not supposed to ever store state, sessions, or whatever. You might also think about this. Also, if you think of a sequence of requests that you need to execute in order to process something, right? That's not really something that the server should store. That's something that the client should supply at any given time. Okay, this just to recall what REST is supposed to be. Now, this one requirement, this code on demand, is one that's particularly tricky because it was optional in 1996, right? I mean, or in 2000 when the dissertation was written, published. Nobody used JavaScript for massive amounts of things at the time. It was a bit of a gimmick. It was a bit unreliable. There are still people who disable JavaScript in the browser completely. And Java applets were sort of on the way out because somehow they promised this code on demand thing, but didn't really fulfill it. And so we had a mixture. We had a mixture of Java applets, a little bit of JavaScript. Sometimes they were talking together in order to achieve anything at all. There was Flash as a sort of code on demand thing. And yeah, it was an interesting idea, but it didn't really do very much in the late 90s, 2000. But there's something very interesting here because the standard is very explicit in providing flexibility. It very explicitly allows the server to decide what kind of representation it wants to provide, which is the content type, right? You have the client option of accept encoding or so forth, so that the client can influence what it can reasonably process. But if that's not there, then the server can either send something else that doesn't match, or it just denies the request. It's the server that decides what representation it sends. Similarly, for patch and post requests, the standard is very, very explicit in saying, well, basically what you send in these requests is completely server-defined. We have in post requests historically the tradition of sending multi-part form data, and most server-side frameworks will somehow interpret this, right? Because it's and browsers do it automatically unless you specify something else. But for patch, that doesn't exist, for example. So what it means is that even though we have a sort of de facto standardization of the read view, of the view that you expect when you do a GET request, because you have HTML, because of the decision making that the standards leave up to the server, there is absolutely no way to write a truly generic client that modifies data or that submits something for modification. Which means that this whole command run thing is no longer a question of optional, right? It wasn't optional back then, basically. I think what happened in the last 20 years is that, excuse me, people exploited this more and more, right? Yes, it's undefined. So we define our own thing, and then we send code on demand because that's the way to deal with it. Which the standard wants it, right? The REST architecture wants this. So now we have some effects from this. One is that we tend to no longer separate between, what is code, what is data, it doesn't really happen. This whole MVC concept that you use in programming languages, or whatever similar concept you use, it doesn't really exist on the web in terms of the HTTP protocol, and very on that level and slightly above that. It doesn't really exist. You use exactly the same methods for requesting code as you would use for requesting data, and the data is a representation. You don't really, it's very, very munched together. And as such, there's no separation between what other people, this is terms from other people, which I quite like. There's no real separation between the document web that is dealing with sending documents back and forth for reading, for distribution, and the application web, which is more concerned with sending functionality around, if you want. And because of this, the way these things are tied together nowadays, basically the web has become the world's largest content dongle. There's a lot of content you cannot access at all unless you also download the code. That's the effect we have right now. And that means that we also are creating data silos. As far as I'm concerned, I mean, people might have a different opinion there, but as far as I'm concerned, data is most useful when you combine it with other data. And this effect of tying the representation of data to code that only the server knows about, that the server may send out to the client, but really it's the server who's in control. It means that this combination of data can really only happen effectively server-side. You can always take small parts of the data and process them in the browser, and depending on your use case, maybe you do even more of that. That's fine, right? I'm not saying it's not possible in principle to work around this, but it's certainly the easiest thing to do, to say, well, if you want to combine X and Y, send me both. And that means there's a sort of a drift, a natural drift for any sort of functionality that you build on web technology to become an all-encompassing platform that tries to fit more and more functionality into itself. And therefore it pulls more users in, because that's where they go when they want the functionality. And so while this isn't necessary, it's not necessary for surveillance capitalism to fall out of it. Very, very few incentives, basically, for companies that provide any sort of service to not use a form of surveillance on their users, because they already have all the data, because that's what the platform, the REST, the web platform, encouraged them to do, to pull all the data in. So from my point of view, and this is sort of the whole approach about the Insappear project, if you want to take privacy and security on for humans, right? That's where the human-centric part comes in. If you want to take this seriously, then maybe we should change the platforms that we use to interact with each other, and it shouldn't be a platform that encourages this pull towards platforms accumulating more and more. Maybe we should use a different technology. Excuse me, my voice is still a bit rough. I have to. That feels better. Now, historically speaking, I don't think the web has done anything wrong there, right? Or web developers, the people who developed the web, have done anything wrong there. If you look back at the early web, it was next to impossible for, my parents, my kids' grandparents to publish anything on the web. They would have had to rent a machine, a physical machine somewhere, or put one in their basement and install an operating system and a web browser, and the knowledge just wasn't there. So it was a reasonable assumption when the web was designed that those people who provide content on a web server are, if not the same people, and in the same group as the people who operate the server. And so this idea that you pull, that you accumulate all the information that is related to content to the server and process it there and maybe send out a view of it and, you know, that kind of thing, it made sense back then, right? I'm not trying to stand here and say, well, 20 years ago, people made stupid decisions. Not at all. At the time, it made the most sense. I completely agree with that. But of course, as I said before, these silos that this creates, they lead to this sort of platform effect where provide a service for users instead of letting them run their own machine that does the same thing. Commercial incentives also push you towards platforms. So this really this assumption that everybody who produces content and publishes content also runs their server no longer holds. In the Web 2.0 phase, we mostly concentrate on technologies that would help these platforms grow. There are a bunch of security features that got added. There's a lot of evolution on SSL and TLS, for example. A couple of different authentication methods were being tried out, and you know, some became more obvious than others. And a lot of things happening there. But what didn't happen is that nothing about the HTTP protocol really changed. That changed only when the scale became so large that now we have this sort of what I'm freely calling here container web that basically tries to treat, if you look at what they're doing, as opposed to HTTP 1.1, is they're solving scale problems. They're not solving user problems, they're solving scale problems, and that only occur because of the platforms that we have. If everybody ran their own server, we wouldn't have these scale problems. I know that it's not that simple, but you know, from a point of view of looking at the features of the HTTP protocol, that's definitely the case. Okay, so but the web has strengths. I might make sound here like it's all been terrible, a tragic mistake. I don't actually think so, but excuse me again. If you look at the strengths, the biggest strength the web has is that it hides complexity. It's very simple to get started with, right? You open your editor, you type a bit of HTML, maybe some JavaScript, and you can already get stuff done with the browser. It's very similar to how it used to be with the Commodore 64, right? You switched it on and you had a basic prompt. You start programming right away. You didn't have to do anything at all. The problem of course is not actually simple. All of this has complexity. It's just not immediately immediately there when you start. And you can kind of see that the complexity is there because we have this JavaScript framework of the week, as some people call it, where every short period of time, a new JavaScript framework is published that's supposed to be the silver bullet to all of the web's complexity problems. These things would have no appeal if there was no complexity. So you know that it's there, but it's hiding it very well in the initial stages, I have to say, and that's great for getting people to work with it. And of course, all the strengths from the REST architecture are inherited. Although some of their weaknesses, but the strengths definitely as well. I mean, I say no, that's it, but you know, that's enough in some way, right? It's not like this. Okay, so what we're trying, or I say we, I said this in my last talk as well. I'm doing this project on my own right now. There's a lot of people I talk about it, and the ideas get changed by the conversation. So it always feels like there's a community around there. But in terms of code, it's pretty much me right now. So, but what we sort of in this sphere of people that are working on this or other problems all seem to think is that we need some kind of reset. And One of the things is to learn from REST, from the good architecture principles that I said princesses, didn't I meant principles that the web is built upon. And one of the things is that, in my opinion, right, this is here purely my opinion, that the separation of client and server into relatively independent entities, that should stay. It also allows you to always create a better implementation, right? That's part of it. I think the cacheability is a good thing. It should stay because it does help with scale. Interestingly enough, we don't do this so much on the web anymore. Most of the caching that we do now is with CDNs, content delivery networks. So we do a kind of edge caching. Used to be very, very different, but caching in principle is still there to accelerate the interactions we have on the web. The uniform interface, I think, is a great idea. We should leave this, and also the layered system, so that we can, at each entry point, decide how to deal with requests. And when you summarize this, these are actually the design principles that lead to a very good document web architecture. Because with these principles, you can build a system that is geared optimally at transferring documents, right? Or making them cacheable, making them available locally as or as local to the end user as possible. But we also have some other interactions that don't really fit into this whole document web idea that currently a lot of people, a lot of companies put on top of the web, right? So we should look at those as well and learn from them. And one of the things what we're doing right here is video or video chat. I don't know how you want to look at it. Two ways to talk about streaming. One is this kind of on-demand type streaming that you get from I don't know, Spotify or Netflix or whatever you use, and the other is live streaming that we're doing right now. Another thing is collaborative editing. If you go to your Google Docs or whatever and you start typing a document and you share the document with others, and they can see your mouse cursor move, basically. Not quite, you know what I mean. And the last thing is APIs. A lot of what people do nowadays when they speak about REST is actually APIs on the web. The things that are interesting there is that they all have one thing in common. That's that they are sort of real-time interactions, right? This whole document web idea is not particularly real-time oriented. It isn't particularly concerned with seeing the latest change of a document. It's more concerned with the document and making it available to the user efficiently, right, through caching or something. And these real-time requirements, they sort of disable this whole caching and layering to a degree. The more caching and layering you introduce, the less real-time it becomes. The other type of interaction that we have is application distribution, which is sort of similar to the code on demand idea. Similar to the command idea, but I'm thinking of it more as how we use it for, I don't know, for our operating system or network development, software development stack, how we update packages, right? We tend to distribute applications to compose locally and use locally. So this might have it's not really so much a hard requirement, but there's some interest there in maybe separating more strongly in the document web and the application web. Maybe that brings us some benefits that code on demand does not. So how do I think this should happen? Well, what I'm doing right now, and that's something I'll talk about a bit more later now. I'm really going to the basics right now. I'm looking how to make real-time peer-to-peer transport, right? And transport is sort of on the level, near the level of TCP. Let's put it that way. I'm not interested in the higher level semantics of HTTP at this point, or anything even remotely like it. The next step would be to solve the document web use case, basically. It's not quite file sharing, but it's if you want a shorthand that's very easy to understand, then you use file sharing here. Make that security and privacy aware, because a lot of things right now are not. And then maybe you already have something useful. The next thing is that we should try and fit the real-time use case into the same interface that's provided by the document web. That goes back to this requirement of the uniform interface. That one requires a little bit of explanation, I think. If you, I don't know if you do, but if you know the Plan 9 operating system, or have heard of it, it includes this Unix concept of everything as a file. It's taken to the extreme. Everything is a file there, or almost literally. To the point where you don't really write network servers at all in Plan 9, you write file servers. And it's possible because there's a file sharing protocol, if you want, a remote file protocol called 9p that's built into it. And so accessing a remote computer's speakers, sound card, is, well, if you're connected and all that, it's as simple as opening a file that has a local name in your local file system, and you write some sound file into it. That's it. And I think this same thing in principle, right? There will be massive differences to 9p because we're talking not about a small stuff of computers that know each other, but the whole internet, right? But I think this on the of how does a user interact with this, right? That should be more or less, at least, the interface that we're offering for all real-time applications. Be it video streaming, where you just basically pipe your video camera into, you know, I don't know, a chat room or something, you know, that's represented by file, or file name, I should say, something along those lines. And when this works, when we have a good document web and a good real-time web, if that makes sense, then we can talk about putting this application web into there as well. And really what this then could look like right now, that's what I'm thinking, is that an application is really nothing but a executable document. You know, you access it via the document web subset of functionality. In order to run it, it has to be strongly sandboxed. I mean, at least to the level of browsers now, right? When they run some JavaScript, that's already problematic with browsers, so it's not going to be much easier there. But that's the sort of idea. And then you can give it access to the document web functionality as well for selectively accessing data, or even to the time parts of it, so to maybe connect to an API that's on a remote server again. Okay. Okay, so what this doesn't solve, and I have no better solution there, it will not solve this problem that there are still going to be document formats that nobody has documented, that nobody knows, you know, that can only be processed by a particular kind of application. We had these before the internet, right? I mean, if I remember, I forgot the name now, but if I remember that in the early DOS, there was a particular 3D modeling software whose name I forgot, and the file format from them was notorious for being completely undocumented at the time. No, now we have a web service that send you some representation of the data and some JavaScript, and the JavaScript is necessary to interpret the data. And you know, we won't be able to solve this on a very fundamental level. But what I'm hoping that a clearer separation of concerns between the document web, the real-time parts, and the application part, what I'm hoping that this will achieve is that we can encourage developers to focus more on building an application that reads a particular document format rather than pulls data from a particular server. No, I can never be sure of this, but I'm hoping that that's something we can achieve. And that means we can hopefully push developers away from this default of mixing data code without really considering that they could be considered, that they are technically separate concerns. Motivation of this is a little bit, I have to lubricate my voice, sorry. The motivation for this is basically, sometimes it feels to me like when I talk to developers, like this rule of the hammer, I think it's called, or Maslow's hammer, which is a former team lead of mine taught me this a long time ago. That if the only tool you know is a hammer, then all the problems that you see look like nails. So nowadays it seems to me, and I don't really want to be offensive about this, right? I completely get where people are coming from, but I sometimes get the impression that when people see, okay, I have to do something with the internet, then because they only know the web, they will immediately take the web as the only tool that they have to solve this internet problem. And it would be nice if we could break this up a little bit, right? There are other ways for dealing with stuff. But we have to embrace that the thing that's so tempting about the web to developers is that nobody wants to learn 10 different systems, right? The web is one system. Of course, it's attractive because it's just one system. And people want simplicity. And what the web promises in the initial stages is that it's very simple to get started. It's very simple to get into it. So what my hope here is that by decomposing the problem into a document and a real-time and an application web problem that sort of fit together, right, but aren't the same thing, that each part actually becomes simpler as a result, but that they can be at least as powerful, in as powerful a way or more powerful. And I also hope that this will prevent people from creating things that drift towards these platforms. From a commercial point of view, it's always going to be interesting to create these platforms to pull people in, right? I have no technical solution, but when commercial interests aren't at the forefront, let's put it that way, then maybe people will decide that actually sharing some documents or providing some functionality doesn't have to bring in all the rest of pulling user data in, of tying you to one platform and one platform only, and every other platform that offers something similar is necessarily a competitor. It would be nice if we could move away from this. And of course, we have to protect the privacy of users. We have to provide security, because those are, I don't know, if the audience is from the European Union, probably not predominantly, but here we technically have privacy as a fundamental right of our citizens. It doesn't always work out that way, but at least in principle, that's what the law says. So human needs include privacy, at least how I think about it. So how much did I progress so far? Well, not as much as I wanted, because just when I started this.
Can we step into Q&A in about 4 or 5 minutes?
Easily. I'm nearly done.
Great.
Perfect. Just when I started this, COVID hit, and I had the kids at home, and all the planning that I had went out the window. So what we have is a little platform here that I call Liberate, because why not? It's really a platform abstraction library. It's very small. It's really just focused on what I need. I don't know if it's used for anyone else, but it's there. You can use it. It's free software. There's Packeteer, which has a similar sort of idea, but a very much more constrained scope. It's meant to provide event-based socket API. It's a bit different from other event-based API event, because it does the whole socket thing also in a platform independent. it's really trying to aim a little bit more at low complexity as its highest goal, and as a result, performance is not quite as good as you can get elsewhere, but it's on the same level more or less, right? So for me, I think that was worthwhile, and that's what I'm going to use in the rest of the project. The Windows port works. It has a couple of bugs. I need to refactor it. There's a little bit of stuff to do. There's no scatter gather IO, but maybe we don't need it so much. And of course, there's always room for some tweaks or some extensions. And what I'm currently working on right now is really Channeler. Channeler is trying to use a package-oriented protocol that provides a multi-channel capability. The point is that in a peer-to-peer situation, and I know I didn't talk so much about this in this presentation, so very quickly, in a peer-to-peer situation, if you need to pick a firewall in order to talk to a peer, you don't really want to do this for 20 different reasons. You want to do this once, and then you want to sort of multiplex your 20 different reasons through this one whole. And that's basically the idea here. There's also I haven't worked on this yet, but that's sort of the next step, is to do things like multi-link things that are coming from the drone project, so that when you use your phone, use this on your phone, or you have a phone call or whatever through this protocol, and you go step out from your Wi-Fi network into the 5G network, that the phone call doesn't drop, right? As an example. Encryption should go into there on the transport level and so forth. And that's very much work in progress right now. But that's what I'm working on right now. So, contributing. You can contribute. I mean, different things are open completely for me. I have no, designs or anything. The website is looking a bit boring with a simple placeholder. There's no documentation template that I can easily fit into the whole thing visually. I mean, this is sort of more design fluffy. Any feedback is good. Absolutely, any feedback is good, because I have a few people that I talk about this regularly with, but for more people, what are their concerns? Is this fitting into what they are thinking? And then there's always room for financial contributions. I said that this is funded, and I want to not stand here with my hand open, because it's funded enough that I shouldn't be doing it. But if I'm being honest, I can only do this in less than half my available time. And in order to get this done a bit faster, it would be very nice if I could do this full time, if I could hire people and so forth. So I'm never going to ask you for that euro that you have to spare. Give that to an Elnet instead of me. But if you have any idea of how this project as a whole can get funding in a larger amount, I will be all ears, because I would like to do this until we have something solid there, pretty much full time, and that is not impossible. And then I think I'm at the questions part.
Brilliant, thank you. It's a little food for thought. I have a list of questions, but I will of course defer, as always, to the audience first. And in fact, it seems some have appeared. So let's have a look.
The Internet Society Foundation.
Yes.
I have the Q&A open. If you want, I can read it.
Yes. I mean, please go ahead.
Okay. Have I considered our Society Foundation for funding? It's possible. I don't remember. I did my last large search for funding in, and I know that there was something that sounded like that on my list, but I didn't quite fit in there at the time, right? Or I sent an application, it got rejected, or I don't remember anymore. It rings a bell. I can certainly ask again. If you have anyone that I should get in contact with, please, I will ask.
I can comment on that.
It is new. Perfect.
I'm part of the, in fact, I'm the president of the Singapore chapter.
There you go.
I got shanghaied into becoming the president about 10 days ago. Not even, last week. So
we can talk about this later if you want. But
the grant program is expanding. There's strong efforts in place to ensure sort of equity and probity. So there are definitely no go and talk to this guy. You enter through the front door, you apply formally, but there are sort of a growing set of pools available for grants to be made from. And I'd suggest that there are three priorities this year. To strengthen the internet, to grow the internet, and to empower people. You touch one, possibly two of those. So I think that's actually, and it's Harish, who's the secretary of the Singapore chapter of the Internet Society, who's made the suggestion. Thank you for the
Perfect. Then I will ask later outside of this Q&A. Tell us a bit more about my team. Well, my team is me. I mean, I have people that I work with in NEY on this drone problem, which is really the multi-link problem. And there's a paper that I've proposed. I should get feedback in the next couple of days, actually, on whether it's accepted in a journal. But basically, this is going to be wandering in some way into this project as well. And so, yeah, Osran there is very helpful on that level, but he's not actually working on this project. He's working with me on related things. And on this project, I only have people that I talk to regularly because they have shared interests. And I don't know if they want to be mentioned here. And I don't think any is from Asia, no. But I have no problem with people coming from Asia to help. It would be great, actually, because, for example, my experience from, I mean, people aside, my experience from China from, it's long, 15 years or so ago, is that the ISPs in China are actually kind of difficult for you to connect from one ISP to another as compared to here in Europe. So there are most challenges with real-time.
Fortunately, most people in Asia aren't in China.
There's that. I'm just mentioning China because I know, right?
China is a large, very large, very special case. But
it creates challenges that I can't emulate, what I'm trying to say. And there's other things that I don't know about. Great, I want to learn. So if you ask because you want to volunteer, or you know somebody who's interested, or anything like that, by all means talk. I can't anyone right now. I don't have chance. But maybe the Society Foundation will help with that.
Certainly, we might. Certainly, the rethinking of the sort of the dependencies. And I think I sort of wonder whether where we landed was part. I mean, the fact that the representation could carry code, and that could be used to determine the user's interaction, I would suggest is the major enabler. I mean, there was a bunch of e-commerce 20 years ago, fine. But what's happened since is so immense and has moved so quickly, it would have been essentially impossible without it. Except to say that, the mobile app stores, and this is kind of my counterexample for you. I wonder whether the app stores are, in fact, the separated app distribution layer. Because in effect, they are doing the thing that you are proposing, or part of what you're proposing, which is separated.
They're doing it in the worst possible way.
Sure.
They're doing it in the way that everybody's. No, I'm with you. But for me, the goal is. This is actually very good. This comment. Sorry, ignoring the next question there for a second. But this is actually very good. The comment. Yes, you're right. App stores, in a way, are doing what I'm proposing, but they're doing it in the worst possible way because they're not really building this on top of an open infrastructure, if you want.
Right.
What the app does with the server, with bot server, how that's completely hidden from us, unless we happen to have the source code, which is not the case for most situations.
No.
Basically, the way I'm thinking about it is that an app shouldn't be able to access the internet other than through these provisions that are built to the platform. I say platform, I've previously said platform in a negative way, like the document web, the real-time web parts, if that makes sense. And then that gives you a level of transparency as the user into the application is actually doing. It's not going to be a silver bullet, but I'm hoping
developers are
that will
perverse
help.
and will do it anyway.
And they will do something that can't anticipate anyway, yes. So the question, mentorship program or student opportunities, it's the same thing as with other people on the team. I don't really have bandwidth to deal with this. if you are a student and you would like to have an opportunity to do an internship, I will do my best to provide you with an opportunity. But I don't have anything in place. No, that hasn't really been. I mean, maybe it'll happen this year, right? But so far, that hasn't really been a focus, unfortunately. Unfortunately, I wish.
All right. Well,
okay.
We might leave it there. Thank you very much. This has been a very
Thank you.
session and a great way to end the day. All the best.
Well, for you it's the end. Yeah, for me it's the beginning. Middle.
Not even. I've just been asked to moderate a workshop. So the end of the main session.
Okay. The end of the main session for today. Okay, great. Well, thank you for having me. That's very good.
Pleasure. All the best. Okay, so that ends the main hall session for day 6 of this FOSSASIA Summit. There is a workshop happening in about 10 minutes. I had forgotten the details. Over in the Jitsi room for workshops. This is on Suzy AI Smart Assistant Installation and Skill Development Workshop with Norbert. That's all for here. Rest well, and we look forward to seeing you tomorrow. Good night.